Let me start the session. Yesterday we did only the introduction part. The actual training will start from today, and I'll open the notes, and the same notes you will find in the mail as well as the hard copy with the classroom people. So you can find out page number 1 and chapter 1. So let me start the training. So in today's session we'll complete chapter 1. So chapter 1 is the introduction. What we learn, the same thing quickly I'll repeat, and we'll also discuss the applicant and standard societies. Okay, in chapter 1, which is again an introduction part. So I think you remember yesterday we already learned what is HVAC. It's a heating, ventilating and air conditioning. And you know ASHRAE, already we discussed American Society of Heating, Refrigeration and Air Conditioning Engineers. And we also discuss this heating, ventilating, air conditioning. But apart from this, some more additional information in the notes. Yesterday we discussed the standard temperature for summer for human comfort is 76. Okay, similarly the standard temperature for winter we are considering 72. So how we got this? The reference you can find out on screen. On the left side of the screen you can find out a human comfort standard, and below that you'll find ASHRAE comfort zone chart. Okay, and this chart is taken from ASHRAE handbook 2001, or if you refer 2017 also you'll find the same chart. And this chart is a part from psychometry. And if you don't know psychometry, don't worry, we have it chapter 4. In chapter 4 we'll discuss in detail about the psychometry. Okay, so this part is taken from the psychometry, and this 60, 65 up to 90, this is the drivable temperature, and this line, this curved line represent our drivable temperature, nothing but temperature. The normal temperature we used to call drivable temperature. So here you can find out the reference winter and summer. You can see the hatching, and in between the combined hatching, this will cover winter as well as summer. So if you talk about winter, the temperature, you see the temperature range is almost 68 to 76. So here you can find out 68 to 76. In between we are considering standard as 72 for designing point of view. If you take less than 72 up to 68, more than 72 up to 76 also accepted. In this range 68, 76, 72 we are considering standard for calculation. Similarly, if you talk about summer, you see the summer hatching start from here up to this point. So this is 74 to around 81. Okay, so or 82. So you can find out the same 74 to 82. In between we are considering 76 as standard temperature. Okay, and in US mostly they are designing with 74 also in the range. In some region they are designing with 75, that is also okay. And this standard temperature we are considering for multiple occupancy. Means, for example, if you're designing one person room like a manager room or a director room, etc., as per his requirement we can design the required temperature. But this standard temperature we can consider for multiple occupancy. For example, open office. So we cannot design in open office, for example, 50 people are working. I think you can understand open office with the cubicles. So 50 people means we cannot maintain the required temperature as per individual requirement. So in that case we are considering this as a standard. Similarly, if you are designing classroom, in the classroom you will find multiple students, so it is difficult to maintain the standard temperature as per the individual requirements. So we are considering this as a standard. So here you see. So I think what the standard question, and it may ask in interview. Suppose if you say this is a 6 degrees centigrade, sorry, Fahrenheit, not centigrade, is the standard temperature. Then if they may ask the reference. So the reference is ASHRAE comfort zone chart. Okay. Next, so I think remember we already discussed what is heating. Quickly let me repeat this. Heating is the process of adding heat in an internal space, the temperature less than what the standard temperature, and already we discussed standard temperature, say 25 degrees centigrade or 76 degree Fahrenheit, by using what? Electrical resistance heater, boiler, furnace, etc. How to provide, don't worry, we have a topic we'll discuss at the time of types of machines, machine selections, etc. At this level, why to provide? So normally, you know, in Western countries most of the time heating is required because the temperature is very less Like if you talk about UK, -5 or -10. In Canada, 20, less than -20 also. So even in Gulf also, for 1 or 2 months, we required the heating. Or in some hill stations also we required heating. In India also, like in Jammu Kashmir, or even in New Delhi, in winter the temperature is very less, so we required the heating. Next, we already discussed about ventilation. So quickly, ventilation is what? Providing fresh air, and already we discussed in detail in yesterday's session. Next, air conditioning. You know the definition, and as per ASHRAE. So air conditioning is what? Maintaining the parameters. What are those parameters? Temperature, relative humidity, cleanliness, motion and distribution of air, and noise level. So today, just quickly I'm reading this because already we discussed this in detail in yesterday's session. If next application, for example, if you talk about application of air conditioning, uh, so any one example classroom of air conditioning, where air conditioning is used. Any one example? Residential, okay. Online, commercial. Commercial means like office, hospital, etc. Yes, online, any one application for air conditioning. It's like hospital, like supermarket. The list will continue. Okay. So here the application is divided into two is classified into two categories. The first is human comfort category, and second is a process control. For example, if you design an air conditioning system, and if the prime concern is human, means human comfort, then we can consider that as a human comfort category. Like you can read here, residential buildings, offices, hotels, supermarket, hospital, classroom, the list will continue. Okay, so in this area, prime concern is human, human comfort. And if you design air conditioning for process, for a machine, because you see nowadays we are dealing with the different process, different machines with electronics. Maximum machines work with the electronic circuit, and it will work means in order to get the efficiency, the electronic will control, and electronic required a particular temperature to work efficiently. And even we are maintaining the temperature to the machines to increase the life of the machine, to decrease the wear and tear, to dissipate the heat, etc. So in almost all the application in process control, maintaining the temperature is required. So if you design air conditioning for a particular machine, for a particular process, that comes under process control. Some examples are given here, like textile machines, photographic process, CNC as a mechanical, computer numerical control machine, clean rooms. One example of clean room is kitchen or medicine area. That area is clean room, or preparing this Intel motherboards. So if you talk about clean room, in clean room we are providing 100% fresh and clean air with a laminar flow. We have different categories or different types of classroom also, but generally clean room is 100% fresh air with no return, directly complete exhaust with a laminar flow. Okay. Similarly, in hospital, pathological lab, MR rooms, operation theater, even food processing. Actually, food processing belongs to refrigeration side, but the base or the basic of air conditioning is from refrigeration. So this frozen foods also comes under this process control. Okay, so the mainly the air conditioning application is divided into human comfort and process control. Apart from this, you will find automobile air conditioning like car AC, like this vegetable, this truck AC. So you'll find automobile side also. Next, we'll talk about the standard societies. Yesterday we talked about the society, the difference between a society and a company. So society deals with the research and development for that particular area, and dealing with the survey, and dealing and creating the courses standards, and that courses standard will follow at the time of design. So you'll find the list of societies here in the notes. The first is ASHRAE, already we discussed. So at the time of designing, HVAC system will follow ASHRAE standard. Similarly, if you are in India, we have a local society, ISHRAE, belongs to India. Next, we have SMACNA. SMACNA is important for ducting side, and we asked in interview also. SMACNA is what? Sheet Metal and Air Conditioning Contractors National Association. This society also belongs to US. They are also dealing with the research and development for ducting side, and like duct designing, duct installation, duct drafting, etc. All these courses standard you can find in handbook. Okay, and internationally accepted. And in interview also this is important. If they talk about the ducting side, duct design, etc., this MACNA they may ask which standard you follow in your previous job or in your training, etc. So this is important. Next, DW144. This also one standard used in Europe and some areas or some as per the project requirement. DW is what ductwork. 144 is a section given to the ductwork. Similarly, you'll find a different sections for different components. Next, we have IS Indian standards. So if you are dealing with the projects here, we are following ISHRE and IS. Next, ARI. ARI is what? Air Conditioning and Refrigeration Institute. So this society or AHRI, this society deals with the what? Research and development for air conditioning equipments. You see, ASHRAE is for system designing. ASHRAE code is for system designing, but ARI is for equipment standard. For example, if you purchase a air conditioning machine, and in that machine if you find the ARI logo, it means that machine is approved by ARI, internationally accepted. Like for example, Kirin machine, Daikin machine, Voltas, etc. If you get this ARI logo, means that is standard and internationally accepted. So if you talk about air conditioning machines, standard will follow this ARI. Next, ASTM. This is also important. When we talk about the metal standard, not only for HVAC, it can be for other services also. So ASTM is the American Society of Testing Materials. So they are dealing with the research and development for material. For example, I think for vapor compression cycle. I think as a mechanical, vapor compression cycle. But if you don't know, don't worry. We designed this course from the basic to advanced level. So if you don't know vapor compression cycle, we'll discuss chapter 3, which is very basic to understand the types of system. But those who don't know, as a mechanical, I believe you know this vapor compression cycle, like compressor, condenser, expansion, evaporator. And I think all these components are connected with the which pipe, which metal of pipe? Copper, right? So how we come to know copper is good for that particular application? Similarly, you see that is one example. Similarly, when we are dealing with the ducting, we are using GI. When we are dealing with the chill water piping, we are using black steel or mild steel, etc. So this information is based on the research and development by ASTM. And when we are dealing with the standard project, we are following the metal from ASTM is ASTM approved. Like for example, copper pipe M88 is a code by ASTM to the copper pipe for that particular application. So you'll find the different standards for different metal for different application. So when we talk about the material, we'll follow the ASTM standard. Next, if you're working in UK, because UK people don't want to follow US standards, right? Because they have their own monopoly. So if you're working in UK for their local project, UK local project, so mostly you may find or you may use CIPSI. What is CIPSI? Chartered Institute of Building Services Engineers. It's a UK standard. But again in UK, many for many projects they are following ASHRAE also. But as per their country standard, you need to follow the CIPSI. So similarly, CIPSI is not only for HVAC. CIPSI is for complete building services, like CIPSI Guide E for fire fighting, CIPSI Guide A for HVAC, etc. You'll find different guides you see for different services. So it's a UK standard. Next, if you're working in Dubai, actually DEVA is for water and electricity department. For HV standards, you may find DM. You can make a note here. DM, Dubai Municipal. Especially for ventilation standards, you need to follow the DM, Dubai Municipal. So as per the location, you'll find the different codes like Qatar, you see Qatar Kharama, it's municipal. Next, RC Royal Commission, if you're working in Saudi for Jubail, Yambo or Al Khobar region, you need to follow this RC Royal Commission standard, Royal Commission codes. Next, point number 12, 13 and 14. This three society belongs to green building. Okay. So before dealing with this societies, we'll talk about what is green building first. Okay. So green building information finding page number 4. I think Most of the people know this because nowadays people are talking about green buildings, saving of energy, saving of environment, etc. So if you don't know, don't worry, I'll explain here. So what is green building? Any idea? Online or classroom? Green building. So it's very simple. Green building means the color of the building is green, right? Just okay. The concept of green building is to save the environment, to save the earth. The major concept. But as a HVAC engineer, your responsibility to reduce the power consumption by power consumption means from the equipment means HVAC equipments. Why? Because I think you remember we learn HVAC equipments will consume 60 to 65% of total electrical energy of the building. In remaining 40% of that electrical energy will be used by the lighting appliances of the building. So the major part of the electrical consumption by HVAC equipment. And how this is related, this power consumption and green building. So as I said, the concept of green building is to save the environment. And saving the environment means the major issue in today's world is CO2, carbon dioxide, greenhouse effect, different emissions, etc. So here, if you talk about the generation of carbon dioxide, CO2, so I think you know CO2 will generate with the generation of electrical energy using fossil fuels, like coal, like nuclear, like this different fuels, etc. And that this electrical energy we are considering as a high grade energy produced with the low grade energy like fossil fuels, coal, etc. And whenever the electrical energy produced with this uh, non-renewable energies like fossil fuels, CO2 will generate per kilowatt of electric energy. Some amount of carbon dioxide will generate. Okay, so the idea is, as a HVAC engineer, if you design your system with the maximum efficiency for your building, and the same follow all the buildings in the entire city or in the entire country, what will happen? The total power consumption will reduce. And if the total power consumption means I'm talking about electrical energy. If the total power consumption reduces means the generation will reduce. And if the generation reduces, the generation of CO2 will reduce. Or else we have other option. We can also use natural resources like solar energy, like geothermal, like wind turbines, hydro plants, etc. And these are all renewable energies and will not reduce the CO2. So either we can use this renewable energies or reduce the power consumption. So here, let me read the definition for green building. A green building is one which uses less water. Again, I think remember as a mechanical, your responsibility to deal with the plumbing service also. Okay, so when you're designing a plumbing service, you must design the plumbing to reduce the water consumption. Next, optimize energy efficiency. This is your part as a HVAC engineer. You must reduce the power consumption by optimizing, means by making your system with maximum efficiency or designing your system with the maximum efficiency, or else conserve natural resources like renewable sources and generate less waste and provides healthier space for occupants as compared with the conventional building. Okay, so I think you got the idea about the green building. You see, lead, point number 12, leadership in energy and environment design is a society. Deal with research and development for the green building, again belongs to US. And we have BC, local United Green Building Council. In India, we have IGBC. Similarly, if you talk about Australia, they have Green Star. So every country have their own society. And the major society deal with the green building is LEED. And if you have 1 or 2 years experience, you can contact to this lead people and they will provide you some data to study, and after that you can able to write the lead certification exam. And once you get certified with the lead, or once you get the lead certification, that will add advantage in job, in resume, as well as in your job. With this we did this chapter 1, which is again the introduction part. And in this chapter 1, you see chapter 1 is also very important because it's very basic and may ask it to you. They may ask the definition of air conditioning, they may ask what is HVAC, or this application or societies. These are very useful. Till then, we'll use the codes from ASHRAE, SMACNA, etc. So you must know abbreviation of all this. So they may ask what is ASHRAE, or expand ASHRAE, or expand this SMACNA. So as engineer dealing with the this MEP services, you must know all this. Apart from this, I'll provide you some more societies which is belongs to plumbing, firefighting, and electrical, because yesterday we discussed if you're dealing with one service, you should know at least the basic of other services. So as a mechanical, you are supposed to deal with the HVAC, plumbing, and firefighting, and you are also involved in electrical for coordination, and the electrical people also involved in mechanical services for coordination. So at this level, at this level, we are dealing with the HVAC service, but let me provide you the basic of the societies for other services, and it's not in the notes. Please make a note. You can make a note online in class. IPC. IPC is International Plumbing Codes. For plumbing, we'll follow this IPC, internationally accepted International Plumbing Codes. For IPC, we have UPC. Next, you can write UPC. UPC is a Uniform Plumbing Codes. Make a note NFPA. This is National Fire Protection Association. National Fire Protection Association. Next, for electrical, we have NEMA, NEMA. National Electrical Manufacturers Association. So with this, we conclude this chapter 1. Next, we'll deal with the chapter 2. This also very, very important. You see, chapter 1 and 2 to get the idea about this service. Very basic and very, very important. Especially this chapter 2. Because in chapter 2, you are going to learn the steps involved in designing what HVAC system, and the steps involved in installation. Okay, and the steps involved in drafting, and the steps involved in estimation. You'll find in the estimation and drafting class. At this level, we are dealing with the designing and installation. So here, this chapter 2 will give you the idea about this HVAC service. Okay, how this HVAC service means the steps in order for designing, and the steps involved in installation in order, and we'll also talk about the other services because for coordination, because as I said, you cannot say means you cannot deal with only one service without coordination. Okay, and we have an order for the services also. So you'll get the idea about this building services and how this initiate, and who is going to initialize this project. Okay, so very interesting and very important. So you consider this chapter 2 is like the overview of the entire training in this service, this HV service. So first we'll talk about the designing, then we'll deal with the installation steps. Okay, and so here you can read on screen chapter 2, project execute. First, designing of the HV system. So you see that the project start from whom? Client. Client means what? Is the owner. For a small project like window or split, we can call customer. But for big project, generally, technically it's a client. Client means the owner of the building or owner of the project. For example, what you do now, assume that you are the client and you have enough space or land in commercial area, and you are willing to construct a 5-star hotel of say 10 floor, for example. So assume that you are the client and you are looking to construct a 5-star hotel in the commercial area. So to whom you are going to contact as a client? Architect. Why architect? And what is the difference between a civil engineer and an architect? Yes, online. If you talk about the civil engineer, in engineering, so in engineering you'll find BE civil or BTech civil, right? In many universities the same. So if you talk about BE civil, or BTech Civil, it's how many years? 4 years, right? But if you talk about B Arc, is of 5 years. So the major difference between the BTech or B Civil and B Arc, you see, B Arc means the architect also basically belongs to civil side. So they learn what the civil people are learning. Plus, they are also learning about the services. So you see, this is 5 years. Means they know the civil side, plus they know about the services. But it not mean that the architect can design the HVAC system, electrical system, firefighting. No, that will take care by mechanical and electrical people. But the architect can coordinate and provide the clearance for all the services, because the architect will learn the civil plus the services, means the architect can provide the clearance for services. For example, again the same example. So you are the client now, and you are going to contact to architect. So architect will go for will deal with the overall planning of the building. Overall planning of the building. Okay. For example, your requirement out of 10 floor, suppose ground floor you want to leave for parking. Okay, this is a hotel project example, and the first floor is for reception area plus kitchen plus this admin area plus for example employee rooms. Okay, so this is not the hotel area except reception. Okay, and the actual hotel rooms start from second floor. So this is first floor and this is second floor, and from second to 10th floor all hotel rooms, hotel area. And as a client, your requirement central air conditioning from second floor to 10th floor, central air conditioning. And yesterday I think you remember central air conditioning means uh, we require the ducts. Okay, so you know ducts yesterday, the box, and you know that ducts maximum clearance compared to other services. So how the architect will plan? He will plan the height of the ground floor. This is one example to get the idea. The height of the ground floor, say 12 feet. Height of the first floor also say 12 feet. But from second floor to 10th floor, he will maintain minimum 14 to 16 feet height. For what? Because above the false ceiling, the ducts will run. So this is one example how the architect will plan the or how will architect will do the overall planning of the building. Okay, apart from this, he will give the clearance to electrical services, mechanical services, and other services. It means the architect will take care for overall planning of the building, not just a civil engineer. Civil engineer also involved in the construction side at the time of structure design, at the time of other designing, at the time of his construction. The civil engineer will take care, but the initialization of the project is done by whom? Architect. So architect is above all. So all the engineers, mechanical and electrical, all the services going to coordinate with the architect. Okay, because he know the services and he can able to coordinate with the mechanical electrical services, and he will provide the clearance for designing this services. Okay, following online. But if he is a beginner, then means most of the time you'll face difficulty if you deal with the beginner kids, because means they don't if they don't have the experience, it may create a lot of issues. So they may not provide the proper clearance, or because they are also learning. But if you talk about experienced architect, generally will not find the issues. Okay, so he's the architect. So client, then the project initialization is done by architect based on the client or application requirement. One example I've given like this. We have a number of example at the time of learning. You'll get the idea. Don't worry. And the architect will prepare what? He will do the planning and he will prepare the architectural layouts. Architectural layouts. But before this, do you know the difference between the architectural and structural? Yes, what is the difference? This online. The difference between architectural side and structural side. Hmm. If you don't know, you please make a note. Please make a note online class. Architectural includes walls, comma, door, means doors, comma, doors, and planning of spaces. I'll repeat. Is there in the notes? Is there? Is there? Okay, okay, sorry. So you see already, you can verify online. You see architecture includes wall, partitions, doors, windows, and planning of the spaces. Spaces means I'm talking about the rooms. Technically we'll call spaces. Like bedroom is one space, drawing room is one space. Similarly in office cabin is one space. So technically we used to call spaces. So planning of space. But when you talk about structural, you see structural means which will bear the load of the building. And remember, wall itself is a load on the building. Wall will not bear the load. In RCC, we are dealing with the RCC structure only. The old construction is outdated. So if you talk about RCC construction, the wall is not a structure member. Wall is itself is a load on the building. Wall will not bear the load of the building. Okay. So that's the reason wall comes under architect, means architecture side. But structure includes what? Footing. Footing means the foundation of the building. Beams, column, and slab, which will bear the load of the building, load of the occupant, load of the appliances, plus load of mechanical and electrical equipments. This is also important. For example, on the top of the means on the roof, if you place a big machine called chiller, we'll discuss what is chiller, a air conditioning machine. So that is very heavy, like 700 kg or 800 kg or 1000 kg, etc. So in order to bear that load, the structure people must design the structure to bear that load. So remember, the structure includes footings, means beams, column, slab, which will bear the load of the occupants plus the appliance plus the mechanical and electrical equipments. So this point again we'll discuss. Don't worry. Next. So let me continue. So the client and the client requirement, as per the client requirement, the architect will initialize the project. Okay, and he will prepare what? Architectural layouts. I'll show you one example of architectural layout. But we have a topic in chapter 6, and in chapter 6 at the building survey in detail we'll learn how to read the architectural layout. At this level, just let me open one small example, a small So if you don't know how to read this architecture layout, don't worry. Before starting the design, we'll learn in detail how to read the architecture layout. Because if you cannot read the architecture layout, means you cannot think for planning of any service. So at this level, just I'm open to get the idea. So this is one example of architecture layout for a small villa, like men's majlis, dining room, kitchen, etc. So this is one example. Don't worry. So the architect will do the planning of like this. Planning of this of the building as per the client or application requirement. Okay, and after preparing this architect layout, the architect layout will send to different department to add what? Different services. And you see, I'm talking about designing only, I'm not talking about installation. Still we are talking about designing. So after preparing the architect layout, you see, firefighting designing, electrical designing, HVAC structure, etc. And the time of architectural structure also design, but the final structure can be done after completing the services. Why we'll discuss. But one question here, for example, if the architectural layout then to all this department, like to add all this or designing of all the services, can all these services start designing parallelly or simultaneously? Yes or no? You see, all the services going to design and install for one building now. Okay, so for example, at the same time, electrical people adding light fixture in the fall ceiling here, and if this excuse me, if this information not known by HVAC people, they may add the diffuser also on the same location. So light fixture, you know, do you know diffuser? Okay, quickly I'll show you diffuse. If you don't know, just you'll get the idea. Anyhow, we have a detailed topic at the time of 8 terminals selection. But here you see, you know this diffuser you'll find in the false ceiling, right? So this diffuser location is different from the light fixture location. Similarly, you'll find the sprinklers or the smoke detectors, heat detectors, etc. So all this is going to be in the fall ceiling. So if the designing of all the services done parallelly, there may chances it the services or the services device may clash. Means again coordination issues. So that's the reason we are following the order of the service. We bother about HVC, but as I said now, without learning at least the basic of other service is difficult. So the first priority is given to the firefighting designing. After preparing the architecture layout as standard, you see in different location the order may vary, but as per standard, the first priority is given to firefighting designing. Why? Because we have two reasons. The first reason is firefighting service required approval from municipal, and the for firefighting you must follow the codes and standard from the municipal. For example, distance between the sprinkler, for example, most commonly 3 meters. So later, if you not get the clearance of 3 meter, and if you place more than 3 meters distance from the between the sprinkler, the municipal will not approve your design. Okay, so that is also one reason. And second reason is it's a safety service, so we'll provide the priority. But it not mean that complete service is done, then it will send to the service. First priority is given to firefighting, and after completing the firefighting designing, the architectural plus the firefighting service in that will take care by electrical people in designing. And this you see this designing can be start parallelly, but the coordination side will follow this order. Okay, like arrangement of this light fixtures, diffusers, and sprinklers. So for that we'll follow the order. Okay, it does not mean that we'll wait till the completion of firefighting. Parallelly, electrical people can start finding the lux level, finding the total power, etc. Okay, so then electrical is second priority. Why not HVAC? Yesterday we learned HVAC one of the major service. Then the second priority is we are providing it electrical. The reason is excuse me, arrangement of light fixtures. Why? Because diffuser, if I place here, I can move to left side, right side, or 2 or 3 feet. It will not affect much to the distribution of air. But if you not arrange the light fixture uniformly, it will affect to the distribution of light. And remember, light arrangement or light is also one of the major major parameter or major I can say for interior. Okay, suppose the interior design is totally very fine, but the lighting arrangement, the distribution of light is poor, then it will affect to the interior. And finally the client is looking for the good interior. So the light distribution, uniform distribution of light also one of the major parameters for interior. So there is a reason arrangement of light priority is given to electrical. Then HVAC. You can arrange the different other devices, but it not mean that we'll wait till the completion of electrical design. Parallel we start designing like load calculation and other. But when we talk about the arrangement and coordination with other services, we'll wait till the completion of arrangement of light fixtures. Then only we can go for arrangement of diffusers or other A terminals. Then structure designing. Here you see structure initially with the architect will complete. For example, you see here you can find out the grid lines. This grid line along with the beams and column. Here is a column. So with the architecture layout, you'll find the structure also. Then again, why even structure designing? The final structure designing can be done after completing the services, considering the load of mechanical and electrical equipments. Because as a given example, this big machine we are interested to place on the roof, so the roof slab must bear the load na? Okay, so after completing the electrical mechanical service and in the drawing we'll show the locations of machine. According to that, if required, the structure people will modify or finalize the structure design as per the load requirement. Okay, and finally other consultants or other services like interior, furniture, carpet, etc. And remember, when we talk about designing, all the services, all department, we can call as consultants. So remember, consultant will take care for designing. Okay, and we talk about installation, will consider that as contractors. Okay, so we are talking about design. So these are all consultant. So it can be a big consultant having all the services, or it can be a separate consultant for mechanical, separate for electrical, separate for civil, etc. Depend. or it may be a big consultant offering all this with a different department in the same in the same roof. Okay, following online. Now we bother about HVAC. So in the notes, you'll find the steps involved for HVAC designing. So first of all, basic theory, what I explained just now. So design of large building project is an extremely complex task. Why? Because of coordination, because of all the services, and this all services design and installed for one building. So it's not that much easy. If you talk about big project, okay, it may take months or even years to complete and may involve many engineers. And you see, months and year and involve many engineers means I'm talking about designing only, not installation. Even for designing, suppose a 10 floor building or 30 floor building, it may take months to complete the designing only. And once the complete designing is done, then only the installation, the construction will start. Completes not 100%. At the time of construction, you'll find a lot of changes, and on site you'll find changes and coordination changes. But this design, this architectural structure and services designing is done, then the construction will start on site. Okay, so only for designing, you see, it will take years or months or even years and involve number of engineers, a team of architects and mechanical engineers, electrical engineers, draftsmen. So completely they are involving in designing only. So the design of, but if you talk about a private residence, you see, the design of a private residence is much simpler and may involve only one or two engineers. One engineer will take care for civil and architect side, and other is will take care for services. For a small project like G+1 or a small office or a small villa, etc. Next, the design of HVAC system of large project is responsibility of whom? You see, HVAC consultant company. Consultant means will take care for designer. Next, consult companies also carry out other duties such as cost estimation. Because after designing, before starting construction and the services, the client is interested to know the expected cost. Based on his budget, only he can start the project. So the cost estimation also will take care by the consultant. Initial cost estimation, not the exact cost estimation. Definitely you'll find 10 to 50% this tolerance. So not exact, because the exact costing can be done only after the final bills, after installation. But the estimate, rough estimate can calculate by the consultant. So cost estimation also done by, and for cost estimation, metal also required. Okay, and field supervision installation. So don't confuse with the points. Already we discussed the consultant will take care for design, and here it is written field supervision of installation. So it means they are also involved in site. Yes, they will involve on site, but partly, not completely, just to supervise the installation. For example, after completing the design by consultant, the design will take care by the contracting company and start the installation. Okay, and at the time of installation, any clarification, any issues or any changes, if want by this contracting company, they need to contact to the consultant, because consultant is responsible for design. So they will contact to the consultant. So that's the reason some engineers from the consultant side will also available on site with the contractor to supervise the installation, to clarify the dots. If any major changes, they will help. And the responsibility of design is by consultant. So if any major changes by done by the contractor, and finally the parameters are not achieved, the responsibility, the design responsibility is on the consultant shoulders. So for that reason also, to keep an eye on installation engineers or installation, uh, you'll find engineers on site from the consultant only for supervision. So they will involve partly, not completely. Each of these tasks is performed in cooperation with the architect, already we discussed, who carry out the overall building planning and design. Okay. And next point. So next, coordination of work between the architect and other department is an important and difficult task. An error in coordination will give you disaster results. For example, before completing the arrangement of electrical light fixtures, as a mechanical dealing with HVAC, if you complete the arrangement of 8 terminals, then your design or the arrangement of this diffusers and 8 terminals will not accept. If it is a big project, it's a lengthy task. Again, if you want to rearrange. So this is one example. Similarly, so even the electrical people also, if they not wait for firefighting sprinklers and etc., if they complete the job, so redesigning, rearrangement is required. So waste of time, waste of energy. See, designing new project is easy compared with the modification in the project, the major modification in the project. Okay, so coordination is important. Next, the design of HV systems involve determining. So we are dealing with the HV service. So in this list, you'll find the steps involved in designing. Okay, so just I'll take 2 minutes to finish this today session. So here you see building survey, and at this level, just I'm going to read these points. And when we start the designing, each and every point is a separate chapter. Building survey is chapter 6. Selection of machine is nothing but classification of machine is chapter 5. Load calculation, one of the major and lengthy part, cooling and heating load calculation in manual plus software, and you'll find this in chapter 7. Machine selection, chapter 8. Duct designing, I'm considering this as a module 2. Then fan selection, water pipe sizing, fitting selection, pump selection, selection of type and equipment, and finally planning the location of each piece of the equipment in the building. And this also cover in drafting part also. So at this level, just I'm giving the idea about the designing, and you must follow this sequence also. For example, without building survey, you cannot think for load calculation, and without load calculation, we cannot think for machine selection, and you not select the machine, you will not get the CFM, GPM, so you cannot deal with the ducting and piping. So this must be in order. And if you talk about ducting, this pipe means I'm talking chill water pipe. So chill water pipe is related to chill water system. Ducting is common for AHUs for different system, etc. So as per the type of system also, you'll find change in the steps. For example, if you're dealing with the window or split system, only load calculation, machine selection is done, no ducting, piping. Okay. Similarly, if you're dealing with the package, we have list of system, we'll discuss, don't worry. So at this level, just this order is important, and this may ask in interview also. If they ask the steps involved in HVC system designing for chill water system, you can able to read. Initially, you can read all these points in order. But don't worry, each and every topic, each and every point is a great chapter. In detail, we'll discuss in the next classes. Okay, so this is just to get the idea about the designing. So how this designing, the sequence, who is responsible for initializing the project, who is the client, who is the architect, and how we are going to coordinate with other services as a mechanical, and means the order of the planning for the services and the steps involved in HVAC designing. Okay. So this topic, this is very important to for mindset, to get the idea what we are going to learn in the next classes. Okay. So this is done for today's session. Anything to discuss online? Tomorrow I'll show you the steps involved in installing the HS system. And at the time of installation also, we need to follow the sequence for the different services, and who is responsible for installation and all we'll discuss in detail in the next session. And we'll also talk about the types of drawing, like design drawing, shop drawing, etc. Okay. So done for today's session. This is part 2 of chapter 2, installing the HV system. After designing, the next step is drafting. After drafting, estimation, then installation. But I'll take care for design and installation. So in this notes, you'll find design and installation. The drafting faculty will give you the steps involved in drafting, and the estimation faculty will provide you the steps involved in estimation. So directly after designing, in the notes for designing and installation, you'll find installing the HV system. Okay. So installing means what? Site execution, the work on site. For example, those who joined today, for them, here you see, these are some images related to the installation. For example, before installation, fabrication of duct, and this is the installation of duct, pipe and other services, just to get the idea. So this is on site, and this picture is taken before what? Before fall ceiling. And fall ceiling, as you know, this is a fall ceiling, this is grid fall ceiling. Rakesh, I think you know what is fall ceiling. Hello? Yeah. So this is grid fall ceiling, also known as tile fall ceiling. So grid because of supports, and in between this box is called tile. It can be thermocol, it can be metal grid, it can be Armstrong, different metals are available. And in that other office you'll find gypsum fall ceiling. And in gypsum you'll find step also if required in some cases, and in step you'll find the grill. So we'll discuss about this fall ceiling. So this picture is taken before fall ceiling. So before fall ceiling, this installation is done, and then we'll cover. And in the fall ceiling, you'll find electrical light fixtures, sprinklers, diffusers, smoke detector, heat detector, alarm, etc. As per the requirement. So now we'll talk about installing the HV system. But again, in installation sequence, the order is important. Simply as a mechanical engineer, you cannot start work on site for installation. An installation after preparing a important drawing called shop drawing. So before starting this, I'll give you the list of drawings. You can write here. It's not in the notes. In page number 6, some empty space. You can write uh, types of drawing. Types of drawing. And this types of drawing is common for all the services. Now I'm providing the drawing which is common for all the services. But when we talk about architectural, we have list of architectural drawing. When we talk about HVAC, we have list of HVAC drawing. But this 4 drawings is common for any service. Okay, so you can start with point number 1, concept drawing. Concept drawing. Second point, design drawing. Point number 3, shop drawing. And point 4, you can write as built, as-built. As built, as-built drawing. And you know who is consultant? Consultant means design side for you people. Yesterday we learned consultant means who will take care for design, and the installation will take care by the contracting company. We have 2 types of companies. It can be a big company dealing with the design as well as the installation, but in actual practice, in market you'll find separate consultant and separate contractor and combine also, but generally. So what we learned yesterday, the design part is belongs to consultant, and today for installation means we are talking about contracting company. Okay, so drawing 1 and 2. 1, so point 1 and 2. 1 is what? Concept drawing, and second is design drawing. You take both in flower bracket and write by consultant. And point 3 and 4, prepared by whom? You can write by contractor. 3 and 4 by contractor means shop drawing and as-built drawing by contractor, and design concept drawing and design drawing by consultant. Yes. Who said? Let me complete now. After getting the what is as-built drawing, you'll get the idea. So first we'll talk about concept drawing. Okay. So what is concept drawing? And remember, concept drawing you'll not find for all the project, only for big project. For small project, concept drawing is not required. It is understood for small project, either window split or ductable. But for big project, say like high-rise building, say 70 floor or say 30 floor, or at least 10 floor. 10 floor also we can consider the high-rise. So for the big projects, concept drawing is required because a matter of crores. Investment is a big investment. So initially, for big project, in that meeting you'll find the client, architect, senior mechanical engineer, and senior electrical engineer. And it may be some legal people like advocate or some people. Initially in that meeting, based on the client requirement, the architect and the mechanical people suggest the system. As a mechanical, we'll suggest based on the client requirement. For example, is high-rise building, suppose a hotel project. So as a mechanical for high-rise building, we'll suggest air-cooled chiller. But on what basis? After learning chapter 5, you'll get the idea. For example, as a mechanical, I suggest air-cooled chiller. Okay, in the meeting they will accept. And based on that, as a mechanical side, we'll prepare a concept drawing. In that concept drawing, just we'll give the idea. We'll prepare a report. In that report, we'll write for this particular building, this system is applicable, and we'll mention the reasons why this system is good for that particular project. And in the drawing also, we'll just provide the basic idea about the locations, rough locations. Okay, so concept drawing is only for big project. So for example, as a mechanical, we'll suggest a particular system, and in the drawing we'll give the rough idea. For what? For approval. So based on that concept drawing, again in the next meeting or by the architect, as per the client requirement, they will check if it is okay, they will approve. Or else again meeting. In that meeting will change the system. So like this, finally decision will complete. And in the concept drawing, if they approve the concept drawing, and if after approving or after getting the approval of concept drawing, based on that we can start working on design drawing. So the next is design drawing. So concept drawing is only for the big project, not for all the project. Okay, so it's like at the very initial stage, as per the requirement, because for one project multiple system may be applicable. So in that, which is best, and as per the type of project, as per the clearance, as per the budget, a lot of issues. So as a mechanical, you cannot decide that one. So involvement of interior, architect, client. Why client? Because client is going to invest. For example, if you suggest chill water system, the initial cost is high, but no doubt running cost is less. So if the client is not able to bear that initial cost, we can go for the VRF system. Okay, so we have these options, and after learning chapter 5 you can able to handle this. So I think you got the idea what is concept drawing, right? Next, after getting the approval of concept drawing, in the consultant will start working and prepare what? Design drawing. In the design drawing, you'll get the design like equipments, ducting, piping, etc. as per the type of system. We'll discuss in detail. At present, just I'm giving the idea. What is design drawing? This exactly you don't know. After learning the system, ducting, piping, etc., you can able to read the drawing. In the drafting also, you are going to draw this type of drawing. So next is what? Design drawing. Okay. So who will prepare this? Both consultant. After preparing this design drawing, the design drawing will again submit back to the architect or to the concerned person who is taking the responsibility, generally consultant. So consultant will take the design drawing, then think for what? Installation, for site execution. So they will contact to whom? A contracting company. So that will discuss, and they will submit that design drawing to the contracting company, and for that a procedure, they will follow a procedure. The consultant will open the tender to the contracting companies, and the contracting company will take part and submit their quotation before the end date of the tender, and the best will win. And depends based on the rate, based on the company good, this market goodwill, etc. Suppose out of 10 contracting company, one company win the project, and after getting the project by contracting company, that we can call job in hand. Job in hand means the contracting company got the project. That stage we can call as job in hand. Before that we can call tender stage, then job in hand. After getting the project, that is job in hand state, the contracting company will add the details in design drawing which is required for execution on site as per the actual site conditions, as per the this other services, and dealing with the coordination between the structure, architectural and other services. So that drawing we can call as shop drawing. So shop drawing is important. Shop drawing also known as site execution drawing, or in short we can say detailed drawing, which is required for installation, because in design drawing you will not find the complete information. For example, in design drawing you will find the capacity of the machine, but the exact dimension of the machine can be decided by the contracting company only. Why? Because the contracting company will finalize the make. Initially, as a consultant, as a design engineer, we can suggest carrier make, carrier or blue star. But exactly what you suggest will not install on site. The contractor, based on that tendering and based on that quotation, they will decide. Suppose they are using Daikin as per the requirement, for example. So for example, what you suggest based on that will draw the size of the machine in the drawing, but exactly will not match with the other model of the same capacity. This is one example. Okay, so this detail will add by whom? By contracting company. Apart from this, the actual levels and the specification, final specification of the metal, etc., all will take care by, all will follow the specification by consultant and follow by the contracting company. But the shop drawing will prepare by whom? By contracting company based on the actual conditions. But it not mean that design is not based on the actual condition. Design also based on the condition, but not accurate. Okay, so in shop drawing you'll find more accuracy, and as per the installation requirement, and in shop drawing you'll find more detail so that the workers on site can understand the drawing for a fabrication and execution. So in short, shop drawing is what? Detailed drawing which is required for site execution. But what happened on site? Already we discussed yesterday. We have number of services. So after shop drawing, the work will start on site. But definitely there will be some changes because of change in client requirement, because of change in one service or some other issues. So there are some changes on site. Okay, and based on the changes, we'll complete the installation. For example, initial the duct routing. For example, this is a open office, for example, area. Initially in the design drawing, the machine location is here, and from this machine location, we are running the duct like this, for example. But later, because of some issues, we cannot install the machine somewhere. We cannot install the machine here, and we shifted to this site. And when you change the machine location, the duct routing and the pipe routing will will change. So this updation first based on the site condition, if it is a major issue, in the meeting we'll solve with the MEP coordinator. If it is a small issue, we'll directly rectify on site. But what are the changes on site as per the shop drawing? Must update in the shop drawing. For what? First reason, for maintenance purpose, and second is for to prepare the final bill. Why? Because for example, initial in shop drawing, the machine location is here, and because of this duct routing, the sheet metal used say 500 or 5000 square feet area. But because of change in location, the consumption of sheet metal or the length of the duct or pipe may increase or decrease. Okay, so to prepare the final bill, modification as per the as-built drawing must update in, sorry, as per the shop drawing must update in the shop drawing as per the actual site condition. For final bill as well as for maintenance. Why maintenance? Because many equipments or devices is above the fall ceiling or concealed, it's not visible. Okay, so if something in the drawing, but in case of maintenance the location of the equipment is different, that will create confusion to the maintenance people. So for maintenance and for final bill, what are the changes on site as per shop drawing must update in the shop drawing, and the modified shop drawing as per the site condition, as per the installation, we can call as built drawing. Okay, as built drawing, the modified shop drawing as per the actual installation is called as built drawing. So who is going to prepare this? Again, by the contracting company. Based on the changes on site, the engineer will mark as per the changes, and again he will sit with the draftman, or he will instruct to the draftman, or if he know drafting, he can able to do the changes. So the final drawing as per the actual condition, as per the actual installation, we can call as built drawing, right? So the same you will find in the theory, don't worry. So these are the 4 types of drawing, and this drawing is common for any service, not only for HVAC, not only for electrical, not only for architect. This is common for all the service. In any service, first concept drawing, then design drawing, then shop drawing, then finally as built drawing. Okay, and concept drawing not for all the project, only for big projects. Okay, so the same we'll discuss in this. So after designing, now think that the architect have all the design drawing with him, because yesterday we talked about design and today we finish this steps. So just assume that the architect have all the design drawing with him. So what he will do now? He will contact to the contracting company, as I said just now, tendering, state, job in, and etc. So here, general contracting company, one company offering all the services, we can say general contracting company, or a construction company, a big construction company will take care of all this. Or else it can be a separate contractor for civil, separate contractor for mechanical, and other services. So these are all contractors or contracting companies. Or it can be a big general contracting company. Whatever the case, the architect will follow and provide all the design drawing to the contracting company when the contracting company win the project. Okay, then the same thing, they will prepare the shop drawing setup. But before this, we'll talk about the sequence of installation. So in design, yesterday we learned the sequence for design. Similarly, we have a order for installation, and this is not same as design. For installation, the first structure is required. Without structure, can you think for installing any service? And structure includes, for you people, structure includes footings, beams, column, and slab. The structure, you know, and generally, first of all, the structure will complete. You see, this kind of structure will complete first by the civil people. And without structure, you cannot go for any service. But at the time of preparing this structure, first the steel work, na. At that time only, as a mechanical, you must check pipe sleeves for plumbing, for HVAC pipes, and for firefighting pipes. I'll show you one example for pipe sleeves. This is important. So especially for big project, you must take care this pipe sleeves, because later we cannot disturb the structure member. For example, yes, online image 0208. Yeah. So here you can see pipe sleeve. This is pipe sleeve, and as per the design drawing, initially as a mechanical engineer, when we are dealing with the HVAC, plumbing, and firefighting, your responsibility to mark the requirement of the sleeve in the structure, like in first floor, ground floor, whatever. Okay, and after the marking this sleeve location, at the time of structure work, they will do the centering, the steel work, and they will add all this sleeves, and they will ask you as a mechanical engineer or a mechanical department to visit on site and inspect the location of all the sleeves. Because if you not align, for example, from this sleeve the pipe will run to the next floor. Suppose 10th floor building, and the one pipe is running from ground floor to the top floor. So this sleeve must align with each other, na? In one floor and second floor and next floor, it should be with the same alignment. In one floor it is at one location, other floor it is moved to 2 feet or 3 feet, means it is very difficult. Okay, so they will ask you to visit on site and verify the location of all the sleeves in construction. So at the time of structural, partly plumbing work also complete, especially this sleeve locations. Okay, next, after this plumbing, then electrical. Why electrical first? Because here this image will help you. And don't think that complete electrical is done, then only HVAC. Coordination with the coordination, but the electrical will have the priority to start the work, because building supply is required to deal with the other works also. And apart from this, in this image will you'll get the idea. This cable trays are running above this box, and this box is sheet metal box called duct, for it belongs to HVAC. And so this cable trays are running above the duct. Why? As per standard. In some cases, this may run below the duct also because of coordination issues or because of some delay in project, etc. But we are talking about standard, and you just visiting on site and observing on site, we cannot say that is only standard. Many times, because of coordination issues, because of some delay, you'll find change in standard also. But at this level, we are following, or we are learning the standard, because we are learning at this level. So as per standard, the cable trace is going to run above the duct or just below the slab. Why? Two reasons. You see, first structure, then partly plumbing, then electrical. Why electrical is above this duct? The first reason is uh, if you run this cable tray below this duct, in future, if you want to do any maintenance to the work, it is difficult to access the duct. First reason. Second reason is, if you run this cable tray below this duct, inside the duct we are supplying cool air, moist air. No doubt with insulation, but after some time, because of some maintenance work to other service, the insulation may damage, and where damage of insulation in that area, chances of condensation, the droplet of water normally in winter season, so that water may drop on the cables, and if any joints, that may cause short circuit. So for that reason, generally cable trays are above the duct. Okay, next, after this, as a mechanical, you can able to start your work, but before that you can go for fabrication of duct, another work, planning, etc. It's not like that. First the electrical will completely done, then we'll start. Suppose they complete 25% or 20%, you can start from that area. Okay, but after completing the this cable tray, then you can able to install this duct. But it's not completely one after other, parallelly, with some delay. The project will start by the mechanical people, because it is difficult. For example, one service is completely done, then other service means it will take longer time, and it is difficult also. Why? Because you see, after completing all the services, then fall ceiling, and after fall ceiling only the electrical people can add the light fixture. Then the diffuser you can attach the diffuser as a mechanical, then firefighting people, the sprinkler, etc. So final work after fall ceiling. So it is in sequence, it is in order. Okay, so after this mechanical, then firefighting. Yesterday we learned the firefighting have the first priority in design, but in installation it is last. This is standard, but normally in India, in local project, you'll find the firefighting pipe above the duct also, because firefighting work is very easy compared to, or installation is limited compared to HVAC. So they will visit on site and they will complete the job. So if the duct is not done, they will install the pipe above the duct also. But anyhow, the branches should be up to the fall ceiling. But as per standard, this firefighting pipe should be below the duct. Again, two reasons. First, after installing this service, the municipal will visit on site and they will test this service after before giving the approval. Okay, and this electrical service will use on daily basis. This HVC also use almost throughout the year. This plumbing also will use on daily basis, but firefighting will use only in case of fire event. Till that time, proper maintenance is required. And for easy maintenance, if this pipe is available just above the fall ceiling, that will be easy to access. Okay, so for that reason also, it is recommended to go run this firefighting pipe below the duct or just above the fall ceiling. It is recommended, but you'll not find all the time because of coordination, because of delay in project, etc. And definitely we are maintaining some gap between the services, especially this firefighting pipe in duct, because cool air, so the chances of freezing the water in Western countries, not in but anyhow, continuously chilled air, and if the pipe is touched to this, the chances of freezing. But anyhow, we are using insulation, but still it is not recommended, or it is required, but is highly recommended to maintain at least one inch gap between the services. Okay, and right side you can see the plumbing pipe, drainage pipe. Similarly, you'll find the water pipe also. Okay, and other services like interior, means fall ceiling, furniture, security system, etc. In this way you can handle the work on site in this sequence. Okay, so this is a sequence, but we are bothered about what HVAC, because we are learning HVAC. So in this theory, you'll get the idea about HVAC installation. The first step, what we discussed, the mechanical or the HVAC contracting company. Already we discussed the installation will take care by whom? The contracting company, and you can highlight this. The contracting company takes the HVAC consultant design drawing. Design drawing also known as engineering or contract drawing, because when the contracting company when they win the contract, the drawing they are considering as a contract drawing. But in actual practice we are calling design drawing. And then prepares what? Shop drawing. Okay, this is the first step. First they will prepare the shop drawing. Then after preparing the shop drawing, the next step, you see what is shop drawing? Shop drawing are detailed drawing, larger scale, minimum A2, A1 or A0 is required. I think you know these sheet sizes. Anyone don't know these sheet sizes? Any confusion in the sheet sizes? If you don't know, I'll explain. Okay. So when you are in engineering, I think you purchase the sheet from the market for drawing, manual drawing. That sheet is A1. And when you cut half sheet, we used to call half sheet is A2, and A0 is bigger than that. Just to get the idea. And for this print, we cannot print this in normal printer. We used to call plotter. You know this plotter, a big machine for printing. That is a plotter, not the printer. So A2 is A1 or A0. A4, you know, paper size, normal paper size. A4, A3 is not at all accepted for shop drawing because it's very small. You cannot read this, and you'll not get the approval on even on A3 also they will not accept. Minimum A2, A1 or the big sheet A0. And we have other standard, other non-standard size also as per the plotter model. But standard is A2, A1 and A0. And most commonly remember 1:100 scale. This is very, very important. You must highlight this. 1:100 scale. What is exactly we'll discuss. You'll find in drafting about this scaling, but I'll give you the idea. 1:100 scale means in actual it is 100, but in the drawing it is only 1. After print, at the time of drawing in CAD, we are drawing with 1:1 scale only. Suppose 100 meter means we'll draw 100 meters in CAD, because in CAD the screen is unlimited in all the sites. But for print, some limitation. We don't have big sheets like this room. Suppose if I want to take the this office print, we don't have this much of big sheet size. So at the time of print, we are going to reduce the size. So 1:100 means in actual it is 100, but in the drawing it is 1. So if you measure 1 mm in the drawing, it is 100. So we'll multiply with the scale, that is 100. It can be 1:150, it can be 1:200 for very big project, etc. But most commonly on site you'll find 1:100 most commonly, but it's not all the time. Depend, 1:50 also you'll find, 1:200 also you'll find. But worker can understand this scale very easily, and generally they are following. So we'll try to print with 1:100 scale. But about the scale in detail you will find in drafting class. Okay, at the time of drafting, not even in CAD. After CAD you'll find the drafting. In the drafting you'll find this scale concept. Next, of the HVAC system which will be necessary for the workers. So step 1 is preparing shop drawing. Step 2 is what? The HVAC contracting company has their people, which includes what? First, sheet metal contractor. Nothing but you'll find 3 types of subcontractor. I can say these are all subcontractors. Suppose I am running a contracting company and I got the project from the consultant. So what I'll do, we have 2 options. Either I can hire the worker on permanent basis, means based on salary. Whether work is there or not, I need to pay the salary. Generally big companies can afford that one. So big contracting company hires the worker on salary basis. Whether project is there or not, they can pay, but not all the contracting companies. So the small and medium contracting companies will not hire the workers on salary basis. Whenever they get the project, they will hire the subcontract from the market. In the market you will find subcontract, a person with a team of skilled workers who can able to handle this duct fabrication, like this duct installation. So this is one type of contractor, subcontractor, sheet metal contractor, and they are dealing with the all about the ducting side, air side. The second type of contractor is pipe fitters, nothing but machine subcontractor. They are involved in machine installation, pipe welding, pipe installation, pipe insulation, etc. Not insulation, pipe installation, etc. And for ducting and piping, we require insulation, not to lose the energy. What is insulation? We have a topic at this level. Just we are talking about in general, just order. So for that we will find a separate contractor, insulation contractor, take care for insulation on duct as well as on pipe. So mostly you'll find 3 types of subcontractor market. So when I get the project as a contracting company, I'll hire the subcontractor people as per the project requirement. Some subcontractor provide a good quality, some will provide a normal quality. So as per the project requirement, I'll hire, and the rate is fixed as per the market. So I'll provide the work to them. I'll provide this detailed drawing, and even the material on site is my responsibility. It means the contracting company responsibility. So the next step is, after hiring this subcontractors or the company own workers, whatever the case, the next step is material. We require material on site. Without material you not think for installation. For ducting, we require sheet metal. For piping, we require pipes on site, fitting, accessories, equipments, lot of things. We'll discuss when we start the project about the system. You'll get the idea about the material. So the HVAC contracting company also purchase all necessary HVAC machines and materials. Comma is missing. Add comma here. Here, comma. To do this, here one more comma. The engineer, not full stop, comma. To do this, the engineers means you are, if you're working as a estimator in a contracting company, estimation engineer. So to do this, their engineers means the contracting company engineers first carry out a takeoff. Suppose if I provide the drawing to you, suppose if I provide the drawing, suppose this is a drawing to you as an engineer and you're working in my company, contracting company as estimator, and if I ask you to go for metal takeoff means I'm asking to find out the metal requirement from this project and make a list with specification. That in short being called takeoff or metal takeoff. Nothing but estimation of what? Material, not cost. So takeoff, that is they list all the machines and metal as shown in the drawing with specification. This is important. For example, why specification is important? Because as a contracting company, in the specification by the client, client means consultant follow the client requirement. Suppose the consultant is asking for a hospital project in one area, aluminum ducting. This is the specification requirement. But you are purchasing the metal, that is GI, for example, and you are completing the work with the GI. At the time of QC, by your own contracting company, first the QC by your own contracting company, then from the consultant, it can be a third party verification also. Depends. They will reject, because if you not follow the specification, what you promise to the client, what the client is looking for specification, if you not follow, the project or the installation will reject. So this is very, very important, specification. So you'll find the specification from the consultant. They will give you the specification, what to follow, what are the requirement, what are the standards. And for big project, the client have their own specification. For example, Aramco is a client, or Reliance in India is a client. They will provide the project to the Blue Star or Carrier people. So they have their own specification, and the specification followed by the air conditioning companies. So you must follow the specification, and based on the specification only you must purchase the material and send on site. This is very, very important. So you must highlight this. Specification of the metal is very, very important, or else the whole area installation will reject by the consultant, whatever the loss. Okay, so be careful. Even sometimes small things with the small parameters they will reject, and this happened in one project. Actually, before insulation, they asked in the specification, they have written black paint on the duct before insulation. But by mistake, the contracting company use red oxide on the duct. Actually, we don't require red oxide or black paint on the duct because we are using GI sheet, so it is already galvanized coating. But it's a it's a consultant requirement. But at the time of QC, at the time of quality check, they remove some insulation and they check. So it was red oxide, and they reject the complete ducting. So insulation, loss of insulation, loss of ducting, loss of material, lot of fabrication cost. It's a matter of lakhs or crores. Okay, so this is very, very important. Okay, so be careful with the specification. So you must follow the specification if you are working as a estimator site, and even as a site engineer. When you're installing, you must follow the specification, you must follow the drawing, etc. Because on site for installation, you are responsible if you're working as a site engineer or project engineer. Okay. Next, this can be a very involving task. Estimation is not easy. It is an involving task. Means if you want to do the estimation, you must know the system, you must know how to read the drawing, you must aware of the specification, you must know the client requirement, standard, etc. Then only can extract the information as per the requirement. That's the reason estimation you'll find at the last in this course. Because why last? Because before estimation will teach you the systems, will teach you how to read the drawing in drafting, and about this calculation, etc., so that you can able to deal with the estimation easily. Okay, estimation is not lengthy, but estimation require all this knowledge. Okay, so at the end you'll find the estimation module in this course. Next, when installation. So now think that drawing is ready, shop drawing is ready. Then contractors, subcontractors on site, metal also we send, for example. Now think that installation is done. How to deal with the installation? We have a separate topic at the time of ducting, piping, etc. This is just an overview. So think that installation is done. So when the installation is complete, the HVAC contracting company test, adjust, and balance the next task. In short, we can call tab work. This also take care by the contracting company. Okay, so generally we used to call balancing, but now the new term in market, tab. Now means from last 5 years the people are dealing with the tab, but still many seniors on site they were used to call balancing. So balancing or tab work both are same. The HV system and call for Q and QC department. QA is quality assurance and QC is quality check, and this Q and QC department from your own contracting company first. Because as a contracting company, when you are taking the project, your company responsibility to verify the work on site. So your contracting company QC team will visit on site after installation and they will submit the report. If any modification, anything, they will write the remarks and you need to complete that one. And final check, suppose it is accepted. Then for big project, the consultant will send a third party verification also on site. It can be from other company or some people. They will visit on site and they will cross check and they will give the approval for big project, not for all the project. So first preparation of drawing, then subcontractors, then material, then installation, then QC, tab work, then QC, and after that maintenance. Okay, so here after completion of tab work and quality check, as built drawing can be prepared. As built after installation only, no? So the modified shop drawing as per site condition or as per actual condition is as built drawing. For what? For final bill and for maintenance purpose. So this is a sequence of installation in HVAC, and the same concept you can follow for other services also. Not only for HVAC, in other services, like if you're dealing with electrical, first preparation of shop drawing, then the subcontractors, but you'll not find number of contractors for electrical. Then again metal takeoff, etc. So the same sequence you can also follow for other services. Because if you talk about any service, the order is same. Okay, so I think you got the idea about the design and installation. Just to set your mind, just to understand what we are going to learn. So now we'll start the course with chapter number 3, from the very basic, physics used in HVAC. So this is very important. Without physics you cannot think for engineering. So in HVAC also we are dealing with the physics concept, and without knowing this it is difficult to understand the concept of HVAC design. No doubt this is very basic, but at the same time very important. In engineering already you learn about this, but today from in this chapter 3 we are going to learn the same, but application side, not just theoretical, application side. Okay. Next, chapter 3, the actual course from chapter 3, physics using HVAC. So we'll start first with the heat. Why heat? Because in first class we learn about air conditioning, and air conditioning, it means what? Maintaining what? Establish and maintaining some parameters. What are those? First, temperature, right? So the first point is temperature. We have other parameter also, but if you talk about temperature, so to maintain temperature, either we are adding the heat or extracting the heat, right? So heat is very important, and you know this. But before this, you see, people have some confusion, so we'll clear in this session about between. For example, if you talk about heat, any one unit of heat, yes, one unit of heat, yes, kilojoules, okay, class, centigrade, kilocalories, Fahrenheit, any more? Calorie, okay, Kelvin, okay, 1 calorie, kilocalorie or calorie, kilo means 1000, Kelvin, any more? Generally we used to in English system we are using BTU. We'll discuss, but here you see this centigrade, this Fahrenheit and Kelvin is not a unit of heat, it's a unit of temperature. Okay, so you must, as an engineer dealing with the HVAC, you must have the clear idea between the temperature and heat, because maximum people have confusion in this. That's the reason I asked this question. So this three, centigrade, Fahrenheit, Kelvin, or even rankings, all belongs to temperature, not the heat. Okay, so what do you think? Heat and temperature both are same or different? Different. How? Is a energy, like mechanical energy, like electrical energy, like chemical energy. Similarly, heat also energy, and temperature is the intensity of that energy. So for example, only this is an interesting example. For example, suppose case 1 and case 2. In case 1, I'm taking one container filled with water, filled with water, and initial temperature say 40 degree Fahrenheit, and final temperature say 170 degree Fahrenheit. And you see, water boiling point is 100 degree centigrade, and in Fahrenheit it is 212. So 170 means it is not boiling. Okay. After adding the heat, the temperature is 170. Now in case 2, and the quantity say 10 pounds. 1 kg is 2.2 pounds, right? So here one more quantity, one more container filled with water, but in this container, the initial temperature same 40 degrees centigrade, but the final temperature say 130, or I'll do one thing, I'll make this as 190 degree Fahrenheit, and this has say 170 degree Fahrenheit. Okay, because both are less than the boiling point, because 212 degree Fahrenheit is a boiling point, and the quantity say 50 pounds. Okay, so now the question is case 1 and case 2, in which case at the final temperature you'll find more heat, 190 degree Fahrenheit and 170 here. So in which case at the final temperature you'll find more heat energy, case 1 or case 2? Correct answer is 2. Why? But you see temperature is less in this container too, compared to this is 190 and this is 170. Then still why this heat energy is more? Because of, yes. Hmm. So you see, to define the heat, no doubt temperature is important, but only temperature is not important. Only with the temperature you cannot judge the heat. First parameter to define the heat, the first parameter is temperature. Second parameter is mass or volume. And the third is specific heat. And in both the container water, so specific heat we can cancel, because specific heat of water in English system as well as, sorry, in English system for water is 1. So 1 means it will cancel because the container, in both the container water. But here mass and temperature. So no doubt temperature is high in this container 1, but in container 2 mass is more. Okay. For example, if you take two container filled with water, one is small one, say 10 liters, and second is 50 liter, and both you put on the stove, which will start boiling early, the small one. So small required less heat energy to reach the boiling temperature compared to the big one, because the quantity is more. So this the 50 pounds container required more heat energy to reach to that boiling temperature, because the quantity is more, right? So to define the heat, we require temperature, mass, and specific heat. And temperature is just the intensity of that heat, or in short, temperature is a degree of hotness or coldness of a given system, and the heat is a energy. I think you got the idea. But don't worry, let me complete this heat first, then we'll talk about temperature. You'll get the clear idea. So what is heat? It's a form of energy which is in transfer due to temperature difference. Whenever temperature difference, this heat energy will transfer, right? And in SI system we are measuring in kilojoules, and in English system BTU. And BTU is very common term in HVAC industry. So we'll learn what is BTU. BT is thermal unit. Like kilojoules, in engineering you already learned, but BTU is a new for you. Okay, so what is BTU? BT is thermal unit. It's a unit of heat, like kilojoules. So if you know 1 BTU, then at the time of load calculation, suppose heat gain through wall, Suppose I got 3000 BTUs. Heat gain through glass, say 2000 BTU. So all these sources of heat gain at the time of load calculation in English system, we are measuring in terms of BTU. So this is very important to discuss. So if you know 1 BTU, then you can understand at the time of calculation about the quantity of heat. You'll get the idea. So today we'll learn what is 1 BTU. Okay, so this is very simple. Suppose if I take this container, ignore this tube, test tube, this container fill with water, say 1 pound quantity. Why pound? Because BTU is English system, so pound is English system, we cannot use kg. And initial temperature say 60 degree Fahrenheit. And after adding the heat, the temperature increased to 61 degree Fahrenheit. Because of how much adding, because of how much quantity of heat? 1 BTU. So it means what? 1 BTU the heat is a heat energy responsible to increase 1 degree Fahrenheit of 1 pound of heat. So we can conclude now the specific heat of water in English system is 1. You can write here. Specific heat, you can write somewhere here. Specific heat of water in English system is equal to 1. Specific heat of water in English system so specific heat of water in English system is 1 because 1 degree to increase 1 degree of 1 pound of water 1 BTU is required. So what do you think? 1 BTU is a small energy, heat energy or big? It's very limited. 1 BTU is responsible to increase 1 degree Fahrenheit of 1 pound. It's not a big amount of energy, no? It's a very limited. But with this, you can understand at the time of load calculation, when you get 500 BTUs, 1000 BTUs, you'll get the idea about the heat energy. So this is important. Now, to understand this or to get more clear idea, one more example, I'll change this parameter. For example, instead of 1 pound, suppose I'm using say 10 pounds. Suppose this is 10 pounds, not 1 pound. Initial temperature is okay, same 60 degree, but final temperature I want to maintain say 75 degree Fahrenheit. So how much BTUs are required? Yes, 15. Next, 150. Next, try for 10 pound increasing 1 degree. How many BTUs are required? 10. Right? So 10. And how much increase? 60 to 70. How much we are increasing? 15. So into 15. Simple. This is 150. So 150 BTUs are required to get this temperature from this 60 to 75. So it means that to get the heat, we required what? We must consider the mass, temperature, and in this case, specific heat is 1. So into 1 is same. So you see, this is specific heat. This is what mass, and this is temperature. And combined is what? Heat, right? So 150 BT is what? Heat energy. So to define the heat energy, we require 3 parameters: temperature, mass, and specific heat, right? Not just with the temperature. Clear? This is important and very basic. Yes? Online? Following this? One more example is given in the in the same page. You see, initially 60, finally 70 for 10 pounds. How many BTUs? 100. Because 10 pounds for 10 degrees. So 10 into 10 into 1. Why 1? Because specific heat is 1, right? Now, for example, if I consider the same case, okay, now we'll calculate. Initially you said case 2 will have more heat, but mathematically we'll check. Anyhow, the answer is correct, but we'll check mathematically. Here, first specific heat 1 into the say temperature 40 to 190. How much? 150 into 10 mass, you'll get 1500 BTU. Means at this temperature on this container, in this container, you'll find 1500 BTUs heat energy, right? Similarly here specifically water is 1 into how much, 40 to 170, 130 into 50. So you'll get around 6000 to 500, right? 500 watt BTU energy. So now we can conclude that you'll find at this temperature is less, 170 compared to 190, but here in this container you'll find more heat energy, right? This is one case. We'll go for one more case. Now think that instead of, I'm not using water in container 1, I'm using oil. Suppose oil with a specific heat, say 10. 10 means for one increasing 1 degree for 1 pound, 10 BTUs are required. So specific heat of oil is 10. So now in which container you'll find more heat? Case 1. So because this will be 10 na? So this will be 15,000. So now in container 1 you'll find more heat, right? Clear? So why we are discussing in detail? Because the first parameter of air conditioning is maintaining temperature, and maintaining temperature either extracting the heat in summer and adding the heat in winter. So heat is very important. Okay. So heat and temperature interrelated na? So instead of this page number 10 topic unit of preparation, directly I'll jump to page number say 13 for temperature, because let me complete the temperature first because both are interrelated. Okay, so now we'll discuss about temperature. So in order to understand this, I'll give you a simple idea, and you know this, you know the molecular structure of what? Solid, liquid and gas. So the molecular structure of solid is what? Closely packed, right? Say like this. Say this is ice. Ice means solid, na? Then I'm adding the heat. The ice convert to water or liquid. So this is water. And in the water, the molecular structure is somewhat loose, right? You know. And further I'm adding the heat. This water convert to vapor, means gas. Solid. This is solid. This is liquid, and this is gas. So in vapor, further it will the distance further increases, na? Why this happen? Because of the heat, temperature increase. Whenever temperature increase, the velocity of molecules will increase. So initially in ice the velocity, in ice the temperature is low compared to the vapor. Vapor means maximum temperature, na? So in ice low temperature is solid, so velocity of molecule is less, so you can expect the closely packed molecular structure because the velocity is low. And as you increase the temperature, it will convert to water, the velocity of molecule increases, so you'll get more distance between the molecules because velocity increases. So for movement more distance is required. Further if you increase the temperature, further you add the heat, the temperature will increase and it will change to vapor, for example. So vapor means higher velocity molecules, so required more distance. So this molecular structure because of velocity of molecules. So as it means that as the temperature increases, the velocity of molecule also what? Increases. So now we can conclude the temperature is a function of velocity of molecules or items. So as the velocity of molecule increases, the temperature increases, and that's the reason when you touch a hot body, quickly you can feel the heat because the molecule movement is, the velocity is high and quickly it can transfer. And you know this, higher the temperature, higher the rate of heat transfer. You know this, higher the temperature, higher the rate of heat transfer. As the temperature increases, the rate of heat transfer also increases because of this velocity of molecules. Okay, so now you'll get the idea. Temperature is a function of velocity of molecules. Just for visualizing, just understanding the nature of temperature. Okay. Next, the same thing. You see, it's a measure of thermal activity, not thermal energy. Thermal energy is enthalpy, means heat, and thermal activity or intensity is the temperature, right? So it's a measure of thermal activity or intensity in a body, or it's a degree of hotness or coldness of a given system, and this activity depends on moments of molecules, nothing but velocity of molecules. Okay, so it not mean that higher the velocity, higher the heat energy. Higher the velocity means higher the temperature. We discuss in this example, higher temperature in the case 1, but not the means higher energy in case 2 in this 117 case 1, right? We'll talk about temperature scale. We have total 4 scales: centigrade, Fahrenheit, degree centigrade, degree Fahrenheit, Kelvin and Rankine. But Kelvin and Rankine we are not using in generally in HVAC. So most commonly we are talking about centigrade, also known as Celsius, and Fahrenheit. So we'll discuss between these two scale, and this is important and this is very basic for an HVAC engineer, especially for conversion from centigrade to Fahrenheit and Fahrenheit to centigrade. And one more important point in this we'll discuss. Let me show you the scale first. Okay. So first Celsius, nothing but centigrade, and second is Fahrenheit. And for both I am taking water as example. H2O. Is this visible? You can follow the notes also. So centigrade, Celsius and Fahrenheit. And here you see for water, in case if you're dealing with the centigrade scale, 0 degree for water is what? Freezing point, right? And 100 degree for water is what? Boiling point at what? Generally 0 degree freezing and 100 degree boiling at atmospheric pressure. If you decrease the pressure, the value may vary. So we are considering this as standard. And in between 0 and 100, how many divisions? 100 divisions, right? 0 and 100, 100 division, and each division is called 1 degree centigrade, right? Simple. Now, if I compare with the Fahrenheit scale, physical distance. So for example, this is 10 centimeter scale, the physical distance. For this also physical distance is same. Physical distance for both the scale is same, right? But here for water, if you talk about Fahrenheit scale, we are considering 32 degree Fahrenheit as freezing point, and boiling point will consider as 212 degree Fahrenheit. And in between how many division? 32 to 212, 180 division. Na? 212 minus 32 is 180, and here 0 to 100, 100 division. But physical distance is same, right? But here 100 division, here 180 division, and each division is called 1 degree Fahrenheit. So we have two difference in the scale. First difference is the starting point. Here this is 0 and this is 32 with respect to water. And the second difference is division. For the same physical distance, here 100 division and here 180 division. If it is only one difference, we can generate one conversion. Like I think all of you know this. 1 feet equal to how many inches? 12 inches. 1 feet equal to 12 inches. You know this. Similarly, if only one difference, we can generate the relation like this. But we have two differences, na? So we require the formula. We cannot generate the conversion, or we cannot do like this. Some people have this confusion. They know this 0 degree centigrade equal to 32 degree Fahrenheit. Accept this? Accept it? Yes. But it not mean that 1 degree centigrade equal to 33 degree Fahrenheit. Is this correct? This 1 degree centigrade, can we write 33 degree Fahrenheit based on this? No. If only if the division is same, suppose 100, this also 100, we can write. But division is 180, na? So we have a formula. The formula is simple. Suppose 90 degree Fahrenheit. This 90 degree Fahrenheit, if you want to convert into centigrade, the formula is C equal to F minus 32. F means here I'll enter 90. This is 90 degree Fahrenheit. I want to convert into centigrade. So C is a centigrade equal to F means 90 degree Fahrenheit minus 32 by 1.8. Why minus 32? Because this 90 degree Fahrenheit means because of the 32 and 180 division. So because of 32 and this is 0. So F minus 32. So we'll reduce this 32 first. And why divided with 1.8? Because here 80 divisions is extra and here 100 division. So if you want to convert into centigrade, we'll divide with 180. Sorry, 1.8. So the division will decrease and minus 32, you'll get the value in centigrade, right? Got this formula. Two difference, na? First difference is starting and starting point, and second is division. So this C equal to F minus 32. So this 90 degree Fahrenheit. If you want to convert into centigrade, first this from this 90 you must reduce this 32, na? Because this is 0, this is 32. So F minus 32, right? And why divided with 1.8? Because this is 100 division, this is 180 division with the same distance. So that's the reason we'll divide with 1.8 to reduce the division. So we'll get the value in centigrade, right? Similarly, if you want 30 degrees centigrade, if you want to convert into Fahrenheit, then the formula is F equal to 1.8. You can take this in bracket, C plus 32. Here we are dividing with 1.8 because to reduce the division, Hmm. Here we multiply with 1.8 to increase the division. And this C means the 30 will enter 30 here. So 30 into 1.8, the division 80% will increase the plus 32 because they start with 32. Here we are subtracting, here we are adding, here we are dividing, here we are multiplying to increase the division and to increase the division and and add 32 because for water the starting freezing point is 32 degree Fahrenheit, right? So simple formula. But this is not the end. We have one more point to discuss. What we discussed just now is for converting temperature to temperature. For example, room temperature is 25 degrees centigrade. If you want to convert into Fahrenheit, we can use the formula. Or a particular body temperature is 10 degrees centigrade. If you want to convert into Fahrenheit, we can use the formula. But if you talk about temperature difference, for example, this is room 1, this is room 2. Room 2 is 30 degrees centigrade and room 1 is 10 degrees centigrade. The delta T is how much? Say 20. This is 30, this is 20. So difference is what? 10 degrees centigrade na? So this 10 degrees centigrade is a temperature of a body or temperature of a room? No, it's a difference of two temperature. So for difference, the starting difference is not applicable because for suppose 20 degrees means I can mark this 20 degree on the scale. But 10 degree temperature difference means it's not like 10 degrees on the scale, right? So for temperature difference, the starting difference is not applicable. So we have a formula C equal to F by 1.8. You see 32 is not applicable in this. Similarly, F equal to 1.8 C. 32 is not applicable. Why? Because for temperature difference, if you are converting temperature difference centigrade to Fahrenheit, this 32 is not applicable because only will check the difference in division because the temperature difference is not a fixed temperature on the scale, right? So this 32 is not applicable in the formula. So this formula for temperature difference and this also for temperature difference, which is given in the notes in the below, right? This is very important. So when you're converting, you must know whether you're converting a temperature or a temperature difference. Okay. Example, first temperature, first point, say 1 degree centigrade, convert into Fahrenheit. Second point, say 110 degree Fahrenheit, convert into centigrade. Third, say 50 degree centigrade, convert into Fahrenheit. Fourth, 10 degree centigrade, convert into Fahrenheit. Fifth, minus 40 degrees centigrade, convert into Fahrenheit. And for delta T, this is temperature difference, 10 degrees centigrade. Yeah, quickly convert this. And I'll give you the formula, already is there in the notes, you can pick from your notes. Centigrade is how much? 33.8 degree Fahrenheit, correct. Next, 110 degree Fahrenheit, 43.3 degrees centigrade. Yes, no. Next, other important point to discuss. Remember, this may ask in interview also. At minus 40, the difference of both the scale is 0. So minus 40 degrees centigrade equal to minus 40 degree Fahrenheit. This is one important point. In many competitive exam, you'll find this question. So at minus 40 degrees centigrade, in Fahrenheit also same, means at minus 40, the difference of both the scale is 0. But again, it will continue with minus 41. Only at minus 40, it is 0. Okay. And what about this delta T 10 degrees centigrade? The difference is there in the notes. Notes mein hai dekhiye. Of the last point, at minus 40, the difference between both the scale is 0. You can highlight this. Now, what about 10 degrees centigrade? 18. Because delta T formula C equal to F by 1.8. 32 is not applicable because the delta T na temperature difference. So F is or F equal to 1.8 C. That's it. So 1.8 into 10 is 18 degree Fahrenheit. And you see the big difference. This is 10 degrees centigrade. The result is 50. This is also 10 degrees centigrade, but the result is 18. The difference is more than double. This is 18 and this is 50. So understand the importance of temperature and temperature difference. By mistake, instead of 18 in the calculation, if you take 50, whole calculation will affect. For example, instead of INR in the fee structure, if I add dollar, the difference is almost 64 to 5 times higher. So I understand the importance of units and conversion. Anyhow, in this chapter 3, we'll talk about more about this units and conversion for other physical characteristics also, like length, area, tonnage, etc. But at this level, what we learn is related to temperature. Okay, so this is the end of today's session. Go through. For example, you are in the showroom to purchase window or split AC, and you can understand what is window and split. Anyhow, in chapter 5, we'll discuss in detail about the window AC and split AC, but you know, in day-to-day life, we are using this window or split. It's common. For example, you are interested to purchase what window AC, and you are in the showroom. So with the sales executive, how you are going to communicate in terms of capacity? Na? Means I'm looking for 1 ton refrigeration, 1 ton capacity window or 1.5 TR. How to get this capacity, we'll learn in load calculation in detail. But this capacity in terms, in English system, we are using ton. So what is exactly? This is simple. For example, if you purchase 1000 kg of ice, 1000 kg, and suppose think that this is a room with a single door, no windows, and suppose this is an insulated room with a single door, and somewhere suppose you purchase 1000 kg of ice and place in this area. Suppose this is 1000 kg of ice, nothing but 1 ton, okay, 1000 kg, and placing in this area, and I'm going to close the room, close the door, and for calculation point of view, we are considering the time as say 24 hours. After 24 hours, again when you enter in this room, first what you will find, this solid will change to liquid, right? Then at the same time, you can feel the cooling effect inside the room, because you know this, whenever ice melt by extracting the heat, right? Without heat, the ice will not melt. So this solid is changing to liquid because of extracting the heat from where? From the room, air, from the room floor, wall, etc. Okay. So when you enter, you can feel the cooling effect. So the cooling effect produced by uniform melting of 1000 kg, nothing but 1 ton of ice, is called 1 TR, nothing but 1 ton. So from this 1000 kg, 1 ton, we are getting the cooling effect. That cooling effect will consider or equal to 1 ton, nothing but the refrigeration effect. So we used to call, or we used to write TR. This is ton weight and this is TR. Okay, ton of refrigeration. So from this ton only we got this ton. So that's the reason pronunciation is same, but the physical characteristics are different. This is weight, this is ton belongs to weight, and this ton for cooling effect, right? Clear? For example, suppose in a room, this is a side view of the room, and I'm installing a split AC and capacity say 2 TR. What it mean? It means that this machine, for example, split machine means you'll get the outdoor unit also, indoor and outdoor, and the outdoor unit. Yeah. So here you see out indoor and outdoor split, and if you weight both the units, means indoor and outdoor, you'll not get the weight more than 200 kg. But this is 2 TR, means this machine can produce the cooling effect equal to when you melt 2000 kg of ice. The cooling effect produced by this machine, that will be equal to the cooling effect produced by melting 2000 kg of ice, right? I think you got the idea. Following. Similarly, now we'll define the same mathematically. Here, okay, before this the theory, and please correct this point. A ton, you please write TR. This ton is weight, but this ton is capacity, cooling capacity. Yes, online. Page number 12. Please update this. This is not ton. This is TR. Means cooling effect. So a ton of refrigeration is defined as the amount of cooling effect produced by uniform melting of 1 ton, nothing but 1000 kg of ice from a net 0 degree. You know this ice melt at 0 degree at atmospheric pressure in 24 hours. 24 hours just for calculation point of view. And here mathematically we know this latent heat of ice is 335 kilojoules per kg. But before this, what is latent heat? We'll discuss about the sensible latent heat in this chapter 3 only, but just at this level, latent heat means the heat which causes change of phase at constant temperature. For example, if you take 1 kg of ice, suppose this is 1 kg of ice, and this 1 kg of ice, if you want to melt completely, so what type of heat is required? Latent heat, because latent heat means change of phase. Suppose solid to liquid, liquid to vapor, again vapor to liquid, and liquid to solid. All this change of phase required addition or subtraction of which heat? Latent heat at constant temperature. Further we'll discuss in detail. So based on experiment, we come to know that for 1 kg of ice, if you want to melt, how much heat is required? 335 kilojoules of what type? Latent heat, so that it will convert into liquid, change of phase. But we are in 1 ton, we are dealing with 1000 kg na? So here you see 1 ton equal to 335 into 1000 kg in 24 hours. But we are looking measurement in minutes. So here 335 into 1000 divided by 24 hours into 60 is minutes, right? So the result is 232.6 kilojoules per minute. But in actual practice, we have some losses, some consideration. So finally, after considering the practical actual conditions, we are considering this as standard, not 232.6. We are considering 210 kilojoules per minute. And if you refer any RNSC book or any refrigeration book, you'll get this conversion. This is a standard. We are considering this as a standard. So 1 ton equal to 210 kilojoules per minute means what? Cooling effect we are utilizing for what? For air conditioning purpose. So in terms of air conditioning, 1 ton equal to 210 kilojoules per minute is what? It means, for example, in this room, suppose this is a room. In this room, if you want to maintain 1 ton of cooling effect, so the rate of extraction should be 210 kilojoules per minute. So if from this room, for example, if you extract the heat at the rate of 210 kilojoules per minute, you can expect 1 ton of cooling effect in this room. So this is the rate of heat extraction to get 1 ton of cooling effect. Okay. Similarly, in this room, after calculation, my requirement is say 2 ton. So what will be the rate of heat extraction? It's going to be double, 420 kilojoules per minute. So we got the rate of heat extraction to get 1 ton of cooling effect. If you want 10 TR, you can multiply. Okay, so this is important. Similarly, we have one more conversion, 1 TR equal to 3.5 kilowatt. So kilowatt is unit of what? 90% or even 99% mechanical people or engineers know this kilowatt is for power. No doubt, this is correct. But kilowatt also used for heat energy, right? Watt is what? Joule per second. Joule per second is a unit of work, and work is related to heat, right? Both are interrelated. Na? So this kilowatt is not power. This is mechanical kilowatt. So here you can write mechanical kilowatt. Electrical kilowatt is power. Mechanical kilowatt is heat. And this will not change. This is standard. Electrical kilowatt as per the efficiency of the machine will change. So this is important. Don't use this conversion to communicate with electrical people. For example, you're installing 5TR machine on site, and 5TR machine required electrical supply, na? And the electrical people ask how much power is required for this unit, and maximum means beginners, they have confusion between this 3.5 kilowatt mechanical and 1.2 kilowatt electrical standard. So if you multiply 5 into 3.5, that value if you provide to the electrical people, that value is totally wrong, because this is not electrical kilowatt, this is mechanical kilowatt, and this is fixed. If you talk about electrical kilowatt, 1 TR as per standard required 1.2 to 1.4 kilowatt of power. to get 1 ton of cooling effect to the machine. And this also vary as per the efficiency and the type of system. Suppose if you're talking about chiller, the requirement is 0.8 kilowatt per ton. So this energy consumption, electrical power, will vary from system to system as per the efficiency of the machine. So this is not fixed. But if you talk about the standard 1.2 to 1.4 kilowatt per ton power is required, but not 3.5. 3.5 is a mechanical kilowatt. So if you use this information to communicate with the electrical people, then the value is going to be totally wrong. You see 1.2 compared with 3.5 is almost triple, right? So be careful. This is not electrical kilowatt, this is mechanical kilowatt, and this will not change. Like 1 TR equal to 10 kilojoules per minute. Similarly 1 feet equal to 12 inches fixed conversion. Similarly 1 TR equal to 3.5 kilowatt fixed, because this is a heat energy, not electrical. So apart from this, we'll discuss some more units related to tonnage in the conversion topic in chapter 3 only. So I think you got what is TR, right? Clear? And this is important because after load calculation, we'll select the machine in terms of ton only in English system, and in terms of kilowatt in metric system. So kilowatt is a metric system and ton is an English system. Okay. And what is metric in English? We'll discuss in the next topic. So this topic we'll discuss in detail at the end. At the end means not today, because this is very, very important. So some more people is going to join tomorrow. So I'll hold this topic, page number 10, because this is very basic and very, very important. Units and conversion. And tomorrow you just bring measurement tape also. After this units and conversion, I'll show you how to take the measurement, how to read the measurement tape. If you don't have today, no problem. Tomorrow you must carry the measurement tape. So hold this topic. Directly I'll jump to this units and conversion as well as thumb rule. All this topic we'll discuss tomorrow. Next, temperature already we discussed yesterday. Next, we'll go for enthalpy. Enthalpy is nothing. This also we'll learn yesterday. So heat is what? Technically heat is enthalpy. Yesterday we learned in order to find out the heat energy, we required what? Temperature, specific heat and volume. And enthalpy also same. So technically heat is enthalpy. So you can read here, it's the sum of internal energy. Internal energy refers to what? Specific heat. As the specific heat increases, the internal energy increases, and for water specific heat is 1. But for a particular oil it can be 10. So internal energy is more for oil compared to water. Next, and the product of pressure. Pressure refers to what? Pardon? No, okay, that's okay. But here in heat energy, pressure related to what? Temperature. Because yesterday we discussed temperature is a function of velocity of molecules, and as the velocity of molecule increases or decreases, the pressure will increase or decrease, right? So this here pressure related to the temperature, because temperature is directly proportional to pressure. You know this. And the volume. Volume refers to what? Mass. Right? So yesterday we learned the same. We learned to define the heat energy. We required specific heat, nothing but internal energy. Pressure, nothing but temperature. And volume is mass. And this sum term as enthalpy. H equal to not mu, U. Let's correct this U. U plus PV. This internal energy we represent with the U, not mu. U plus PV. Or in short, for interview point of view, you can highlight this. Heat content of the body is called enthalpy. Nothing but heat. Heat content of the body, not the heat intensity. Heat intensity is temperature. But heat content, nothing but heat energy, is enthalpy. Right? So you can highlight this point. Heat content of the body is called enthalpy. Okay. Or one more option, heat transfer at constant pressure is also enthalpy. But for interview point of view, this is important. Heat content of the body is called enthalpy. In short. Next, we'll discuss about sensible and latent heat. This is also very important. Why this topic is important? Because when we are dealing with load calculation, the first and lengthy and major design step is load calculation. Okay. So at the time of load calculation, suppose if you are dealing with the cooling load calculation for summer, we'll find out the heat gain through different sources. I'll give the list of sources at the time of learning load calculation. For example, heat gain through wall, heat gain through glass, heat gain through roof, etc. We have a list of external and internal sources. So when we are calculating or when we are analyzing the sources, at that time you must know that source is only sensible heat or sensible plus latent. If it is only sensible, you have only one formula calculation. If it is sensible plus latent, we have two formulas for calculation. So this topic is important, simple but very, very important, because at the time of load calculation, when we are dealing with analyzing all the sources, first we'll find out the source is only sensible or sensible plus latent. According to that, you'll find the calculation. Okay. But what is sensible latent heat? Simple. As a mechanical, you know this, but here we learn on the application side. For example, can you suppose in this container filled with water, and water means the state is liquid, na? Means this is above 0 degree centigrade. Say the temperature of this water, say 1 degree centigrade. 1 degree centigrade means it is in water, right? Now I'm adding the heat. Adding the heat, what happened? Increasing the temperature till 99 degree centigrade. The water is water only. It will not start changing its phase. So adding the heat, or else from 99 to this 1 degree centigrade, adding or removing the heat which causes increase in temperature or decrease in temperature is called what? Sensible heat. You see, a sensible heat change was described as a process where the temperature of a substance change when the heat is added to or removed from it, but there is no change in the state of the substance. Water remain water only. Was 1 to 99 or 99 to 1 if you add or remove. So that type of heat is called sensible heat. Example for load calculation, you see heat gain through wall. When the heat gain through wall, for example this wall, the heat gain from outside to inside, what happened? Only the heat will transfer, na? Is there any change of phase or is there any moisture from outside to inside? No. So this heat from the wall will transfer inside and increase the room temperature. So we can consider it sensible. Similarly, heat gain through glass, no mass transfer. Glass means window, no mass transfer. Similarly, heat gain through roof also is sensible only. There is no change in moisture. Okay, so these are some examples. So adding or removing the heat without change in phase is called sensible, right? Clear? So this example will help you, but at the time of load calculation, for all the sources we'll check. Next, latent heat. You see, further in this container, after 99 degrees centigrade also, I'm adding the heat. So what happened? After some time, this temperature will change to 100 degrees centigrade. And you know, at atmospheric pressure, the boiling point of water is 100 degrees centigrade, right? And after 100 degree, further if you add the heat, what happened? For example, I'm closing this shell. And after 100, it will change or start changing phase from liquid to vapor, right? So we are adding the heat, but there is no change in temperature. So that's the reason this is latent heat, also known as hidden heat, because we are adding the heat, but the temperature will not change. Then where the heat goes, the heat is utilized to change the phase from at this level from liquid to vapor. So remember, latent heat is the heat added to or removed from a substance which causes change of state but without change in temperature. So whenever changing of phase, remember change of phase at constant temperature. The temperature will not change. Means the at 100 degrees centigrade, the change of phase start, and the temperature will be constant till the completion of complete water to vapor. The temperature will not change. And now the water is completely into vapor. And further, if you are adding the heat, then the temperature will increase to 101, 102, etc. Because that is completely into vapor. And again, in the same state, increasing the temperature means that is going to be sensible, right? Suppose solid to liquid is what? Latent. Again, in the liquid, we are increasing the temperature till 99 degrees centigrade is sensible. Again, at 100, the change of phase start from vapor, from liquid to vapor is again latent. Completely vapor, further increasing the temperature is sensible. So whenever change of phase, latent. And remember, at the time of latent, there is no change of temperature at constant temperature. Example, here you see heat gain through ventilation. What is ventilation? the fresh air from outside. So when you take the fresh air from outside into the space, this outside air carry what? Dry air plus the humidity. Hmm. So dry air refers to what? Dry air heat will increase the temperature in the room, na? So it's sensible. And the moisture heat, the moisture also carry the heat, na? Which is transferring inside. So that moisture you must condense on the coil to extract the heat. Change of phase. The moisture is going to be condensed on the coil will change to liquid by extracting the heat. So change of phase. So that we can consider as a latent. Hmm. So heat gain through ventilation. Don't think that only latent. It's sensible plus latent. We have sources only sensible or sensible plus latent. We don't have only latent. Okay. So heat gain through wall, glass, roof, etc. only sensible. But heat gain through ventilation is sensible plus latent. Because in that you'll get the dry air as well as the moisture, the humidity. Similarly, heat gain through human body is sensible plus latent. For example, suppose if you're sleeping on your bed, after some time when you wake up, the bed is warm, right? That refers to sensible heat. But continuously our skin, from our skin, the moisture is generating, more or less depend as per the physical activity, as per the physical activity. So but continuously our body is generating the sweat. So that sweat is hot, and when the air touches to your skin and again sucked back by the air conditioning machine, the moisture is going to be condensed on the coil. So change of phase is required. So heat gain through human body also sensible plus latent. Further, at the time of load calculation in detail we'll discuss, don't worry. But at this level, understand what is sensible heat and what is latent heat. Sensible heat means there is no change of phase, increase or decrease in temperature. And latent heat means there is no change in temperature and change of phase. It can be from liquid to this vapor, or solid to liquid, whatever, or liquid to solid process, forward direction or reverse direction. Okay, following online. Try to understand this, try to visualize this to get the idea so that we can use this concept in load calculation. This line diagram will help you to understand the concept. Here you can update this line diagram. Here see increase in x direction is heat, increase in y direction is temperature. So this inclined line means increase in temperature as well as heat. It means this is sensible. Insensible, the temperature and heat both will increase, na? Solid, it is in solid. Next, this melting point means 0 degree centigrade and this is 100 degree centigrade, right? At 0 degree centigrade, what happened? The solid, the ice start melting, and you see the direction is straight, means only increase in heat, but there is no change in temperature because only in x direction, na? So this is latent. Again, at this point the solid is completely into liquid. Further, if you add the heat, the temperature and heat both will increase. So this is again sensible. And at this point the liquid completely in vapor. Further, if you increase, sorry, liquid, it is in liquid now, melting liquid, and this liquid sensible. Now it is starting change of phase from liquid to vapor. You see, change of phase means straight line. Straight line means only increase in heat, but there is no change in temperature. So this is latent. And at this point, the liquid is completely vapor now. Further, if you increase the heat, the temperature will increase. So this we can consider as sensible. The inclined line refers sensible and straight line refers latent, because straight line there is no change in temperature, only change in phase means change in heat, right? Following. So you can update this sensible, latent, and sensible. And this is heat and this is temperature and 0 degree centigrade and this is 100 degree centigrade. Quickly update this. Update it? No? Next on screen. Refrigerant we'll discuss, but before this we have some more small topics to discuss. Pressure and loss of thermodynamics. Okay, so we'll start with the pressure, and pressure is very important. Why pressure is important? Because at the time of hydraulic calculation, for pump selection, for pipe designing, even for fan selection in duct designing, we are dealing with the pressure. Different types of pressure like static pressure, then velocity pressure, then total head required, etc. So in hydraulic calculation for water side or air side, etc., all the time we'll talk about the pressure. So pressure is very important. So what is pressure? So pressure also a force, but per unit area. If you not consider the unit area, we cannot say pressure. We can say total force or total pressure or total weight, because due to weight you'll get the force na? Or you can apply the force. So if you not measure for a specific area, we cannot call pressure. We can say total pressure. Total pressure and pressure both are different. Pressure means always force per unit area. So we'll discuss in detail because this is important. You must have the practical idea about this. For example, suppose this is a tire, a four-wheeler tire, and now we are getting tubeless tires. Suppose this is the opening and we can fill the air in this tire. So how much air we are going to fill generally? Depend as per the model of the car. Say 30 psi. So what is psi? Pounds per square inch. Pound is a unit of force and square inch is a unit area. In short, we are calling psi. Normally when you fill the air in air station, the unit you can check next time. This is psi. You'll get kg per centimeter square also, but generally what we are filling in terms of 30, 40, etc. This is psi, pounds per square inch, and this belongs to English system. So pound means we are adding lv, is a unit of force, and square inch is a unit area. Square inch, 1 inch. This is 1 square inch, na? See, this is 1 inch and this is 1 inch. This area is 1 square inch. So 30 psi in this tire means if you measure for 1 square inch inside the tire. So this is 1 inch, again this is 1 inch. So this is 1 square inch. So how much force is acting? 30 pounds. 30 pounds of force is acting in an 1 square inch area. So we can say 30 psi. Right? Got this? Clear? Now further in hydraulic calculation, I think all of you know this. Whenever, if you talk about hydraulic calculation, means water side, as the height of the liquid column increases, the pressure at the bottom also increase or decrease. For example, initially the pipe length say 10 feet and filled with water up to the maximum level. And later the pipe length is say 20 feet and this is P1 and this is P2. Which will be higher? P2 is higher, na? So it means this H is directly proportional to P, means height of the liquid column is directly proportional to P. All of you agree with this? पता है ना? Irfan, right? पता है ना आपको? H is directly proportional to P. As the height increases, the pressure at the bottom, and I am talking about static pressure, not dynamic. The water is not moving. The water is at rest. Moving means the case is different. We'll consider the pressure friction pressure drop also. So here, as the height increases, the pressure also increases, means H is directly proportional to P. Clear? Now one question related to pressure. For if you have confusion, you'll get the idea with this example. Suppose this is a base or ground level. One pipe, say 2-inch dia, and the height say 30 feet, filled with water completely, and here acting P1, the pressure. I'm talking about pressure. And next one more pipe, say this is 2-inch dia and this is say 8-inch dia, big pipe, and the height say 25 feet, again filled with water, and here you'll find the pressure P2. So what do you think? Which pressure is higher, P1 or P2? And the correct answer is P1. Here you see, no doubt, in this 8-inch container the volume is more compared to this 2-inch pipe, but still you'll find more pressure in 2-inch. Why? Because the height. So what is pressure? Force per unit area. Force per unit area. So if I measure per unit area for this pipe and for this pipe, this pressure because of 25 feet and this pressure because of 30 feet. So pressure is force per unit area. So we are measuring for a unit area, and in both the pipes water means the density is same, right? So you'll find more pressure in P1 compared to P2. If you talk about total pressure, the case is different. In that case, we'll go for the volume, we'll check the volume or total surface area. According to that, we'll find out the total pressure. But if you talk about pressure, you'll find more pressure in case 1. Okay? One more example, because this pressure is very important. This is interesting. For example, cylindrical container, cylinder shape one container. One container say inverted cone and one say the cone type. And I'm going to mark for this 3 container, and the mark is the same level, means H is same for this 3 container, and I'm filling the water. Means the height of the liquid column in 3 container is same. So here P1, P2 and P3. So in which case you'll find more pressure? Yes, online, 1 minute, online, click on your answer, click. There is nothing here. P1. Okay, class. Okay, you said all are same. Yes, class. P3, P1, P2. Yes, P3, P2. All are same. Same. This is correct answer. Those who said same, they got the concept of pressure. You see, I said, I have given the clue also. The height of the liquid column is same in 3 container. If the height is same and in 3 container water, so density is same. So if you measure for 1 square inch here and one for 1 square inch here and for 1 square inch here, the pressure is going to be same, because pressure is what? Force per unit area. Okay. So density is same. So per square inch, if the height is same, the pressure is going to be same. So pressure is what? Force per unit area. Just unit area is important. So whenever you talk about pressure, consider force per unit area, not go for the total pressure or the total weight or the total force. Okay, just consider the force per unit area is a pressure, right? So the pressure is going to be same in 3 container, whatever the shape. If the height is same, at the bottom the pressure exact is going to be same, right? Clear online? Anyhow, your answer is correct. Yes? No. You see, already I said I'm talking about static. And dynamic, the case is totally different. We cannot merge in this. Next. So here in the notes, find out page number 18. You see, pressure is difference force or unit area, and some units also given. You can just go through this, and this is very important. As an engineer, you must know this pressure in detail. Further, at the time of pump selection, fan selection, etc., we'll talk about different types of pressure, like velocity pressure, static pressure, total pressure, dynamic pressure, etc., or atmospheric pressure, different types of pressure. But pressure is force per unit area. Next, we have some more small topic to discuss: laws of thermodynamics. As a mechanical engineer, you know what is zeroth law. And this is given only for interview point of view, because zeroth law is not used in HVAC except this term thermal equilibrium. So what zeroth law says? Simple. If two body attain thermal equilibrium with the third body, what is thermal equilibrium? Balanced state with respect to temperature, right? If two body attain thermal equilibrium with the third body, it means that all the 3 body will attain the thermal equilibrium. Simple. Here you see this ABC. First A is connected with the B and A is connected with the C. Suppose temperature A is 500 degrees centigrade, temperature B suppose 300 degrees centigrade, temperature C say 200 degrees centigrade. And if you link A to B and A to C, after some time the three body temperature will be same, na? So A and B is physically connected, B and C is physically connected. So as per zeroth law, if two body attain thermal equilibrium in the third body, after some time B and C temperature will be same as A. So it means that B and C temperature also same, na? So in the next drawing, this connection is not physical connection, this is logical connection. This is not physical connection. This A to B and A to C is physical connection. But in the next drawing, this B2 is logical connection. So if B and C attain thermal equilibrium with the A, it means that B and C also have the same temperature. So as per the zeroth law. And this for interview point of view, go through this. Even the first law also for interview point of view, and first law, as per first law, state that heat and work are mutually convertible. This is enough for interview. It means when you add a heat to a system, you'll get the equal mechanical work. Or in reverse, if you add the mechanical work or work to the system, the same amount of heat you'll get as per first law. And you know this is just theoretical. This is only for ideal system. An ideal system, ideal cycle is what? Ideal cycle is what? Corner cycle. Ideal cycle is corner cycle, and corner cycle efficiency is 100%. And corner cycle practically not available. Na? It is only for comparison with the actual systems, right? So this is just theoretical, only for comparing with the actual system, comparing the actual system with the corner system, corner cycle, for comparing the efficiency. So this is only for interview point of view. Just go through this line. But second law is very important as a HVAC engineer. So we'll discuss in detail. And this is simple. And you know the second law. And second law offered by two scientists, right? One is Kelvin Planck's, very good. And second is classes. So Kelvin Planck statement again related to engine and related to the first law. First law says this, there is no losses. And in Kelvin Planck second law, it said that there are some losses. Okay. There is no ideal cycle in actual practice. There is no 100% efficiency cycle in actual practice. But again, that Kelvin Planck statement related to engine, so we are not bothered. We pick classes statement. Classes statement, the classes anti statement is related to what? Related to the heat. So according to classes statement, simple. According to classes statement, it is impossible for a self-acting machine working in a cyclic process to transfer heat from a body at a temperature, at a lower temperature to a higher temperature, lower to higher, without the aid of external agency. In short, it means if you want to transfer heat from low temperature body to high temperature body without any system, it's not possible. It means simple, heat always flow from higher temperature level to lower temperature level without any system by nature. By nature, heat transfer from higher temperature to lower temperature. But if you want to transfer from lower temperature to high temperature, a system is required. And the system is what? Your refrigerator or your refrigeration cycle. In refrigerator, what happens? Inside is cool and outside is hot. And continuously, the system will take the heat from the inside cabinet, which is low temperature, and rejecting to the outside, right? So without the refrigeration system or vapor compression cycle system, for example, you cannot get the transfer of heat from lower temperature to higher temperature. In reverse, by nature, the temperature, the always heat transfer from higher temperature to lower temperature. This is simple. For example, if you take a cup of hot coffee in the room, what happens? After some time, it will match with the room temperature. Means loss of heat from high temperature to low temperature. Or if you take a piece of ice in the room temperature, what happens? It will melt. Means heat transfer from room A to the ice. And coffee means the heat loss from the coffee mug to the atmosphere because higher temperature. And in ice, the ice is low temperature compared to the room temperature. So the heat will transfer from the room A to the ice. So always heat transfer from higher to lower temperature. This is simple. But how it is important for an HVAC engineer, I will discuss. But before this line diagram, hot body and cold body. If you link, the heat will transfer without any system. But if you want reverse procedure, cold to hot, this system is required. Okay. So this is simple to understand. But the importance of the second law for a HVAC engineer, we'll discuss now. For example, suppose you are dealing with, you want to install a machine for summer. So in summer, which system you are going to adopt? Cooling system or heating system? Cooling system. Okay. In winter season, which system? Heating system, na? On what basis? How you know that in summer cooling system is required? Because hmm? Yes. How we know that in summer cooling system is required? Temperature high where? Where? In room? Outside. Hmm. And in room compared to outside, room is less, na? So what happened? Heat transfer or heat transfer from outside to inside or inside to outside in summer? Outside to inside. How we come to know outside to inside? Because with the second law, only, na? Without second law, we'll not get the direction of heat, and without direction of heat, we cannot find out whether cooling system is required or heating system is required as per the season. So no doubt this is simple, but this is the base for selecting the system. If we know that in summer heat gain, because outside is higher temperature, inside is lower temperature, as per second law. Hmm. So with the heat gain, we can conclude that cooling system is required. So without the direction, it is difficult. It's not possible to decide which system is required, right? So I think you got the importance of second law for an HVAC engineer, right? So this is important, and this is important for interview point of view also. Just you can go through this point, these lines. Heat always flow from higher temperature level to lower temperature level without the aid of any external agency. Okay, clear online? Next, we'll complete this mode of heat transfer. Then we'll move to vapor compression cycle. So this also, you know, as a HVAC engineer, sorry, as a mechanical engineer, mode of heat transfer, we have three options: conduction, convection, and radiation. Why this is important? We learn sensible latent heat. We'll use at the time of load calculation when we talk about the sources of heat gain. At the same time, when we are talking about the heat gain or source of heat gain, you must also know whether the source is only sensible or sensible plus latent plus the mode of heat transfer, whether the source is only conduction or conduction plus convection or conduction plus convection plus radiation or only convection or only conduction. So you must know the type or the mode of heat transfer also for calculation. For example, first of all, what is conduction? Heat transfer in solid bodies without any physical movement, but inside molecular movements are there. For example, if you take this as a solid piece, for example, excuse me, you can watch in the video online in the team viewer. For example, this is a solid, and if I apply the heat from this to this side, after some time the heat will transfer to other side. No, suppose a metal bar. So heat transfer in solid without any physical movement is called conduction. Next, convection, heat transfer due to movement of fluids. Fluids means what? Fluids. Only liquid? Okay, you can write in bracket, fluid means liquid plus gases both. Liquid and gases both comes under fluids. So heat transfer due to movement of fluids means what? Convection. One example. For example, if you switch on the air condition machine in the room, from the air condition machine you'll get the cool air, and air is what? Fluid. And with the cool air, the room temperature decreases, so the cool air will extract the heat from the room and suck back to the machine. So heat transfer or heat extraction due to what? Convection. Similarly, in a pipe, suppose hot water is flowing, so the surface of the pipe become hot, no? But surface of the pipe become hot because of conduction, because the heat transfer through the thickness or through the thickness of the metal from inside to outside. But the source is what? Source is convection because the hot water. It's okay. So if the hot water is flowing inside the pipe and the outside surface is hot, means it's a convection plus conduction. Convection because of water, and conduction, heat transfer through the solid surface, this thickness of the pipe. Okay. Next, we'll talk about radiation. Here you see conduction and convection required medium to transfer the heat. Conduction required solid medium and convection required fluid medium, liquid or gas. But radiation don't require any medium to transfer the heat. Radiation can transfer even in vacuum. So what is radiation? The heat gained through electromagnetic waves. The heat gained through electromagnetic waves is called radiation. And this electromagnetic waves can travel even in vacuum also. So from one side to other side in a shell, suppose inside vacuum, this radiation can transfer to other side and fall on the opaque body and convert to conduction. Okay, so don't think that only the radiation from the sun is radiation heat. Only the light through light radiation heat gained through electromagnetic waves, that waves from through sun or through sun rays or through light rays or through human body rays or any food product, that we can consider as radiation. Okay, so and radiation not required any medium, it will fall on the opaque body then convert into conduction. And the best example of conduction, convection and radiation is heat gained through wall. For example, wall means, you know, wall. Suppose this is a side view of the wall and this side is outside and this side is inside. So what happened? The radiation is going to fall on the wall surface is what? Radiation. This sun rays on the wall is radiation. And the hot air touches to this surface of the wall is what? Convection. And this convection and radiation will increase the wall surface temperature, and the heat start transferring from outside to inside through the wall is what? Conduction, right? So here radiation, convection and conduction. And again the inside surface is hot. Again the inside air touches to this surface of the wall, again convection. In the room, the heat transfer, right? So radiation, convection through wall, conduction, and again inside convection, right? So this is a mixed mode, heat gain through wall. Okay. So we'll use this at the time of load calculation. These are some example, and this also very basic for load calculation. Okay. This example also help you. Next, yes, anything to discuss online class? So let me start the session now. So today's topic is vapor compression cycle, and in vapor compression cycle we'll learn how we are getting the cooling effect, and this cooling effect can be used to cool the food products, and that we can call as a refrigerator. And the same cooling effect if you utilize to cool the water, we can call water cooler, or else the same cooling effect can be utilized for or to cool the air. We can consider that as air conditioned machine. No doubt the capacities will different, but the concept or the cycle behind refrigerator, water cooler and air conditioner is same, and the cycle is called vapor compression cycle, also known as basic cycle. So before starting vapor compression cycle, first you must know what is refrigerant. Okay, so but before starting this refrigerant, I'll play one small video clip to get some idea, because this topic, as I said, this is important, because in chapter 5 we are dealing with the different type of systems, and if you want to learn the systems, you must know this vapor compression cycle. So let me play one small video clip. In this video clip you'll get the idea about this cycle, just idea. Detail I'll show you with the line diagram after playing this video. Just have a look.
System activated by a compressor will be described first. It is divided into the high and low pressure sides. The high pressure side is that portion of the system through which the refrigerant travels under high pressure. This side starts at the discharge valve of the compressor and includes a condenser, a receiver or storage tank, and the liquid line. The low pressure side is that part of the system through which the refrigerant moves under low pressure. This side starts at the expansion valve which divides the high and low pressure sides and includes the cooling unit or evaporator, the suction line, and the suction valve of the compressor. The compressor is essentially a cylinder in which a piston works. This is the course of a refrigerant through a typical compression cycle. The refrigerant, in the form of a gas under low pressure, is drawn from the suction line into the compressor. The gas enters the cylinder through the suction valve as the piston moves on its downward stroke. When the piston moves upward, the pressure and temperature of the gas rise. The gas is compressed and is finally pushed through the discharge valve into the condenser. The refrigerant enters the condenser as a high-pressure gas, and its temperature is higher than that of the air or water cooling the condenser. As heat flows from the gas to the cooling agent, the gas condenses, changes to a high-pressure liquid, and passes into the liquid receiver or storage tank. From the receiver, the high-pressure liquid refrigerant passes through the liquid line on its way to the cooling unit. The high-pressure refrigerant must now be reduced to a low-pressure liquid so that it can evaporate at a low temperature. The refrigerant passes through an expansion valve which divides the high and low pressure sides and controls the flow of refrigerant into the cooling unit. The refrigerant enters the cooling unit under a reduced pressure caused by the suction stroke of the compressor. It evaporates, absorbing heat from food in the refrigerator and providing what we know as refrigeration. The refrigerant, now a low-pressure gas, is drawn through the suction line back to the compressor, completing the cycle. This, then, is the cycle of changes of the refrigerant as it moves continuously through the compression system.
I think you got some idea. So let me start with the refrigerant. Okay, so we are dealing with as per the course title, we are dealing with the designing, drafting, installation and estimation. We are not talking about the service and maintenance. But if you involve in service and maintenance, you need to go through detail about the refrigerant, the type of refrigerant, the chemical properties, then chemical formula, all about the refrigerant, because mostly in the breakdown you are dealing with the refrigerant charging. But as per the course title, we are not offering the service and maintenance, but we'll talk about the basic, because as a design engineer or a site engineer, you should know the basic about the refrigerant. Okay, so the some basics of refrigerant is given. So what is refrigerant? You can read here. It's a heat carrying medium during the cycle. It's a heat carrying medium during the cycle. Which cycle? Vapor compression cycle, which we are going to learn. Which rejects heat at condenser and extract heat at evaporator. Both are heat exchangers. One is used to reject the heat, and whenever rejection of heat, the vapor will change to liquid, and whenever extraction of heat, the liquid will change to vapor. Okay. Next, if you refer any RNAC book, you'll find the list of refrigerants. You can go through when you have time, and already as a mechanical you know different types of refrigerant. But what are the types of refrigerants? Classified into three categories. It's given here. First is CFC, second is HCFC, and third is HFC. So if you talk about the history of this refrigeration, before 19th century, the people are using natural refrigeration, like cutting the ice from the polar region and using this solid carbon dioxide, nothing but dry ice and some natural resources. And that was difficult. It's not easy using the natural resources for cooling. So in the beginning of 19th century, many scientists developed many systems, but you know, the scientist called Willis Haviland Carrier, who got the commercial success on his system, and we are calling father of air conditioning. At the time, the CFC, not exactly at the time, after some modification, when the refrigerant is used, the CFC was popular, and CFC was popular last 20 years back also. But after some time, when the scientists come to know this chlorofluorocarbon CFC is affecting the ozone, and you know the function of ozone. Ozone layer is used to filter the UV radiation, and because of that we are safe. The radiation is not directly affecting to our body. But if suppose damage of ozone layer O3, direct radiation from the sun onto your skin, that may cause skin diseases. And in New Zealand, Australia, and some Western countries, it is already affected. So when the scientists come to know this CFC, using CFC will affect the ozone, so what they did, they decided not to use this. And in present market, the CFC is totally in almost all the countries because it will affect the ozone layer. And at the time, the best example was R12, and this code R12, 502, etc. is given by the first company in the refrigerant, means first big company in the refrigerant, called Freons. To avoid confusion in communication, to place the order, to handle, etc. Instead of reading the chemical name, chemical formula to place the order, they have given this code. So R12 means you'll find the chemical name, chemical formula, etc. So this is just for information what we are learning. CFC is now not in market. HCFC, the new option is available. So HCFC, hydrochlorofluorocarbon. This also contain carbon, this also contain chlorine, but compared to CFC, less. It's approximately 8 to 10%. But this also affect to ozone layer. So as per scientists, some say for next 5 years we can use this, or as per some opinion it can use up to 15 years, next 15 years. And some companies in Gulf, in Western countries, they are not using even HCFC. As per my knowledge, the Zamil company, they are not using HCFC, and Train, they are still using. Daikin, they are not using. So HCFC also in future the people will not use, the companies will not use, and still many companies, they are not using this. So the example of HCFC, present people are means in companies they are using R22. Me ask in interview, you can highlight this. Next we have HFC, hydrofluorocarbon. This hydrofluorocarbon is eco-friendly, environmental friendly, no chlorine content. So we have HFC. Then why the use of HCFC? Because handling HFC is not easy. So the initial cost of the system increases with HFC. That's the reason still we are also using HCFC in market. Okay. And the best example of HFC, hydrofluorocarbon, which is used in market, you can highlight R134A and also highlight R410A, which is commonly used in actual practice. Okay. The information is given in the next page. You can go through this for interview point of view, like name, you see tetrafluoroethane, and the properties are also given. And recently this question asked in interview, cylinder color code for this 134A, it's light blue. And similarly information is given for 410A. You can go through this. This is for interview point of view. Next. So the liquid or the gas which is flowing inside the cycle is what? Refrigerant, right? And refrigerant in short we can call heat carrying medium. For what? For vapor compression cycle. So now we are ready to deal with vapor compression cycle. This is interesting and simple. So with this line diagram on screen with the orange and blue color, let me explain this, how we are getting the cooling effect. So what are the major components? The major components are, you can see, start with the compressor in order. First is compressor, and second is condenser, third is expansion device, and fourth is evaporator. Okay, so we start with the compressor. So what happened inside the compressor? Listen on screen, online classroom. Inside the compressor you will find the refrigerant in gas state. Remember, in compressor you'll find the refrigerant gas state. Why? Because the compressor is designed to handle the refrigerant only in gas state. Any liquid in the compressor means compressor will damage. And one more point, gases are compressible, no? Not liquid. Okay, so you'll find the refrigerant in gas state in compressor, and when you switch on the compressor, for example, when I apply the electrical energy or connecting the turbine, whatever, means suppose switch on this compressor. So what happened? The name compressor will give you the idea. Mechanical people know this. So compressor means what? Which is used to compress. So what happened when you switch on the compressor, means refrigerator or AC, you'll find the same components in both. At present, I'm considering this cycle for air conditioning. The same is used for refrigerator and water cooler also. You need one example you can take. So we are learning air conditioning, so I'm taking this cycle for air conditioning, not for refrigerator. But if you are understanding easy with the refrigerator, you can take the example of refrigerator also. So refrigerant in compressor in the liquid form. When you switch on the compressor, what happened? First of all, volume. When you compress something, volume will decrease, right? Volume decreases. And what happened to pressure? Pressure increases. And you know this pressure is directly proportional to temperature, na? Already we defined the temperature. Temperature is a function of molecules. More temperature means more velocity. This temperature is the function of velocity of molecule. Velocity of molecule means pressure, right? So pressure is directly proportional to temperature. So if the temperature increase, pressure increase, temperature also will increase. Actually, our requirement to increase the pressure to run the cycle, but these are both are directly proportional, so temperature also will increase. So with the increased pressure and temperature, the refrigerant will come out from the compressor in this line. You see, high pressure, temperature, vapor means in vapor form, na, means gas form. Say for example, say 55 degrees centigrade. 55 degrees centigrade is a high pressure for refrigerant. Why? Because maximum refrigerant boil at minus temperature only. Just now 134A. 134A start boiling at minus 26 degrees centigrade only. So at positive temperature it is in vapor only, na, with the high pressure. So for example, say 55 degrees, and this is just an example. This temperature will vary from system to system as per the capacity or as per the type of refrigerant. Okay, this is just example. Say 55 degrees centigrade in vapor, and that this refrigerant will allow us to pass to a heat exchanger called evaporator. Condenser. This is called what, heat exchanger in general. But why we are calling condenser? Because the refrigerant is supplying in as vapor, and when it is flowing inside this, what happen? We can use the fan here. You can add this fan with the motor. So force convection, and I'm drawing this line. This is HS, means high side, and this is LS, low side. So this fan will take the air from outside and throw on this coil. Suppose outside temperature, say 45 degrees centigrade, and this refrigerant temperature 55, na? So as per second law, as per second law of thermodynamics, heat transfer from high to low. So what happened? When the air is thrown on the coil, the refrigerant heat will extract by the air, and air come out as a hot air. And this condenser is designed by the manufacturer to pick the heat equal to what? Equal to latent heat. And whenever latent heat means change of phase, right? So what we learn basics we'll use now. So when the refrigerant is flowing, it will reject definitely the heat equal to latent heat. So when it is coming out, it will be in liquid form. So that's the reason this is called condenser, because refrigerant get condensed, na, vapor to liquid, condensation, right? So this is called condenser. But you see, change of phase means at constant temperature. Temperature is still same, 55 degrees centigrade. But this 55 degrees centigrade, vapor to liquid, no doubt, change of phase. But you know this change of phase at same temperature. So this 55 degrees centigrade is not enough to get the cooling effect. So what we'll do, after this compressor condenser, the refrigerant will allow to pass to one more device called expansion valve or expansion device or throttling valve. So here I am writing point 1 and point 2, and I'll draw this. Suppose this is the line. In the video you'll find the spring type coil, na? The same small narrow section, the same here. say this is 20 mm and this cross section say 3 mm. So compared to 20, 3 mm is very small. So that the tube, small narrow cross section tube in the video is an expansion device. And what happened, you see, here is a 0.1, here is a 0.2. You can relate 0.1, 0.2. So 0.1 means refrigerant in liquid, na? And it is flowing with a very small narrow cross section. And here is the suction pressure. Why? Because you see at 0.2 the compressor is running, so suction pressure, because compressor suck, then compress, then supply. So at 0.2 you have suction pressure. So here 0.2. So we have suction pressure here, and when the refrigerant is controlled and supplying with a small narrow cross section, suddenly it will get the big area. Means from 3 mm again the refrigerant getting 20 mm area. So what happened? Expansion process take place. Expand hoga na? The expansion process take place. And whenever expansion process take place, what happened to volume? Volume increases. And what happened to pressure? Drops. And pressure is directly proportional to temperature, so temperature also drop. So at the outlet of this expansion device, means at 0.2, you'll get cool refrigerant, say 15 degrees centigrade, 55 to 15. And 15 degrees centigrade is enough for cooling effect, for air conditioning, not for refrigeration. For refrigeration the case is different. So 15 degrees in liquid, and you see low pressure, low temperature liquid. So low temperature, low pressure. And I think one more point here, but before this, anything to discuss online or classroom? I mean, compressor, condenser, expansion, before moving to next point. Anyhow, in this at this level, chapter 3, you are going to learn how the system works. But the actual components I'll show you in chapter 5. The appearance of actual component, how the compressor, how the condenser, how the fins, and what are the different systems. If you know this, then you can understand, and you can learn chapter 5. Okay, so don't worry, I'll show you all these components in chapter 5. At present, just understand how the system works. That's it. So here at 15 degrees centigrade, after losing the heat because of expansion process. One more law or one more condition. Water boil at what, 100 degrees centigrade, yes. Right? Everyone know this.
Sorry, I have a question.
Can you boil water at 50 degrees centigrade? First of all, yes or no? Can you boil the water at 50 degrees centigrade online? Yes or no? I'll write here yes and no. You can click on your answer. Click on your answer. Can you boil? No. Okay, one no. Other? Quick.
So we can boil.
So you said 2 people centigrade water boil. At what pressure? Yes, very good. At atmospheric pressure. If you decrease the pressure less than the atmosphere, you can decrease the boiling point. Not only for water, for any liquid. Because the boiling point, what we'll get in the chart, is based on the atmospheric condition, atmospheric pressure. So 100 degrees centigrade water, boiling temperature for water at atmospheric pressure. If you decrease the pressure, we can boil the water. In some application in industrial, they are boiling water at 5 degrees centigrade. Very cool water, but boiling. The pressure is so low. So it means that the boiling temperature, the boiling point can modify by controlling the pressure, right? So the same concept we are using. When the refrigerant coming out at 0.2, is the 1 to 2, it is at low pressure and temperature. Na? So low pressure means what? The boiling point also decreases. So means now the refrigerant can boil at low pressure also. Sorry, at low temperature also, right? So this here is a concept. When the cool refrigerant with the low pressure and temperature entering in the evaporator, it is at low pressure means the boiling point also low. And when it is entering here, what we'll do, we'll use one more fan. This time this fan will take the air from the room. This is from the room air. Say 30 degrees centigrade. And throw on this coil, and this is 15 degrees. So again heat transfer as per second law, high to low. Na? So when the air throw on this coil, what happen? The air heat will extract by the refrigerant and air come out as cool and dry air. This dry you underline. I'll explain this dry after learning dew point temperature in psychometry chapter 4. At this level you will get the confusion, so I'll hold this. Anyhow, just write and underline this, but you can understand cool air, right? So you'll get the cool air. Why? Because the refrigerant will extract the heat. And refrigerant, listen, the refrigerant at low pressure, so it can boil at low temperature. So when the heat, when the room air heat is given to refrigerant, the refrigerant start boiling at the low temperature, and when it is boiling, it will extract more and more heat. And when it is coming out from the evaporator, it is in low pressure, low temperature vapor, change of phase. In condenser, liquid to vapor. In evaporator, vapor, liquid. In condenser, vapor to liquid. And evaporator, liquid to vapor by extracting the heat. Extracting the heat means it will cool the air. And again, the low pressure and temperature in the vapor sucked by the compressor, the cycle continues, right? And this cooling effect at present we are utilizing to cool the air. So it's air conditioner. The same cooling effect inside the refrigerator, you'll find that cooling chamber, that is the evaporator, or the same cooling effect can be used to cool the water, that is water cooler. So the source is same, but the applications are different. Right. So in this way, the vapor compression cycle works. Simple but very important. At the time of chapter 5, we'll use this cycle to learn all the systems right from window to chiller. Okay. So if you have any confusion, you must clear at this level. Why? Because if you have confusion in this, then you cannot learn chapter 5. With this, we did chapter number 3. Psychometry, chapter 4. Without psychometry, you cannot think for designing, HVAC designing. So what is psychometry? This term is taken from Greek language, and the meaning of psychometry is, psycho means air, metry means measurement. But air means what? Not just dry air. Air means we are talking about the moisture. For example, in this room, simple experiment, what you do, take the chill water bottle from the refrigerator, and suppose this is chill water bottle from the refrigerator, and this I'm placing, you can watch the video, this I'm placing in the room. After some time, don't open that bottle, suppose the bottle is sealed. So after some time, what happened? On the bottle, you will find what? Droplets, no?
Yes.
So from where you will get the droplets?
Yeah. From here.
From the air, means from the room air, because the bottle is sealed, right? So from the air we'll get that droplets, and that droplet is called dews. Why and how we'll discuss after learning dew per temperature. But with this, we can conclude that the air is a moist air, right? The moisture from the air only, except special cases like in desert areas or in some cases, the air is a moist air. More or less that depends on the humidity level, but generally air is moist air. So when you talk about psychometry, means we are talking about the study of the moist air. So if I say air means by default I'm talking about the moist air. So here you can read in the notes, the psychometric air that surround us is a mixture of dry air and water vapor called moist air. Because this gas mixture is conditioned in air conditioning system, so it is necessary to understand how it behaves. So what is psychometry? Psychometry is a name given to the study of air and water vapor mixture. We'll use the word air to refer to air water vapor mixture, and that is atmosphere. So if I say air means by default I'm talking about the moist air, right? So in psychometry we are going to learn the properties of air, the behavior of air, etc., which is very important for air conditioning, right? So let me read the properties first. Properties of air, you can read here from point 1 to 7. Point 1 is what? Dry bulb. So what you do, highlight 1, 4 and 5. Point number 1, dry bulb temperature, in short DVT, for what? Sensibility. Let me read this, then I'll explain. First is drivable temperature dBT and for sensible heat. Second is beddable temperature WBT. Next is dew point temperature, in short DPT. Next we have humidity ratio, also known as specific humidity, or uh, the specific humidity for what, for latent heat. And next, relative humidity. Already we learned in the first class relative humidity RH for human comfort. So we'll discuss what is relative humidity and what's the difference between the relative humidity and humidity ratio. Next we have saturated air and enthalpy of air. Okay. So first, drivable temperature. This is nothing simple. For example, if I measure, suppose assume, can you see the video online? Can you see my video? Assume this is a thermometer. Actually it's a digital pen, but think that's the thermometer. If I measure the room temperature, or if I measure the outside temperature under shade, not directly sunlight, means under shade, if I measure the outside temperature, means what I am measuring? I am measuring the drivable temperature. So don't confuse drivable temperature or the temperature, both are same with respect to air. Suppose today outside temperature was 40 degrees centigrade, means I'm talking about drivable. Present room temperature, let me check in the remote. Present room temperature is 26 degrees centigrade. Is what? It's a drivable room drivable temperature. So temperature and drivable temperature both are same. So, but the important point is, you see, the temperature of air as sensed by a normal thermometer, the temperature of the word temperature or drivable temperature will be used to mean the same with respect to air. But this point is important. It will measure the sensible heat of air. For example, heat transfer from outside to inside through wall. So what we'll do, we'll take the difference of dry bulb outside temperature minus inside temperature. Outside temperature means outside dry bulb minus inside dry bulb. The delta T we are using in the calculation to find out how much increase in heat. So remember, this is important. Directly we'll use this drivable temperature in calculation to find out the sensible heat of air. This is important. So for all the sensible calculation, we'll use this drivable temperature. How to use is the next level. At the time of calculation, you will understand how to use this. But remember, at present, drivable temperature is used to measure the sensible heat of air. Next. So I think you got this. This is important. You just highlight this. So later at the time of calculation, you'll get the idea. Next we have wet bulb. Any idea about wet bulb? Wet bulb, first of all, is not a natural or direct property of air. Like dry bulb is a direct property of air, but wet bulb is not direct property of air. Is a property or is a value based on experiment. So simple experiment, you already know this. I'll do show you the procedure, then we'll discuss why we are finding this wet bulb. Okay, first of all, how to find out the wet bulb, then the purpose. Okay, because it's not a direct property, then why we are finding, but before this, how we are finding. Simple. What we'll do with the same thermometer, first I'll measure the dry bulb. Suppose room dry bulb I'm measuring, I got 30 degrees centigrade. After that, what I'll do, I'll take a wet cloth. Can you see this online cloth? Suppose it's a wet cloth. I'm going to dip with water and I'm going to place on the thermometer bulb and tie. But before this, what I did, I measured the room dry bulb. It is really showing 30. Then after that, I'm closing this and tying this the wet cloth, and I'm supplying the heat, say 3 to 5 meter per second velocity, for example. So after some time, what happened? This cloth will become dry after some time. So how this cloth will become dry? Because of evaporation. And evaporation required what? Heat. Without heat, no evaporation. So what happened? When the evaporation take place, it will take the heat from the supplier, and at the same time when the evaporation take place, it will take the heat from the thermometer bulb, result in decrease in temperature, say 26, previously 30 now say 26. So 26 degrees centigrade is what? Wet bulb. This is a procedure to record the wet bulb. Okay, clear? This is a procedure. And remember, always wet bulb is less than dry bulb, right? It will reduce only. This is a procedure. But now the question is why we are finding this, the use of this. So remember, after learning these properties, we have a topic called psychometric chart. Psychometric chart. So using psychometric chart, sitting in the office without any experiment, we can find the properties of air. But the condition of using the psychometric chart is you must know two properties of air. So dry bulb we can measure, wet bulb also measurable. Using these two, other properties we can find out without any experiment using psychometric chart. So for that reason we are finding wet bulbs, because this wet bulb directly not used in the calculation. This wet bulb with the dry bulb, two properties. If you know two properties, then only you can get the point. With the point, if you go in different direction, then you can find out the different properties. How, I'll show you after this properties. But the reason why wet bulb, to find the other properties using psychometric chart. Clear online? Dew point temperature. This is also interesting. You see, the temperature at which the water vapor in the air began to condense if the air if the air were cooled at constant pressure. Or in simple words, it's given here. It's the temperature at which moisture leaves the air and condense on object, as dew forms on grass and plant leaves. In which season? For example, as I said at the beginning, if you take the bottle, listen online, if you take the bottle, chill bottle from the refrigerator, after some time without opening, you'll find the dews at the surface. Because of what? Because of dew point temperature. Remember, whenever dew point temperature attain on the surface, and when the air touches to the surface, the air moisture loses the heat and the water condense and change that vapor to liquid. Because of what? Because of dew point temperature. And dew point temperature is not fixed like boiling or boiling point or freezing point. This dew point temperature will change based on the other temperatures like dry bulb, wet bulb, etc. So we don't have a fix. We'll find out using the psychometric chart. But dew point temperature is what? The temperature at which the condensation start. So in which season you'll find more dew point temperature? Summer or winter? Winter. So normally in winter, in early morning, you can see the fog. Fog is what? The air is separating the moisture from the the air is separating the moisture because of getting the temperature equal to or less than or equal to dew point temperature. So remember, whenever a body attain the temperature less than equal to dew point temperature, when the air touches to that body, the moisture from that air loses the heat and condense on the object. That droplet is called dews. So fog is what? Fog means the separation of moisture from the air, because in winter season temperature drops na. In early morning the temperature is low, and you'll get the temperature less than equal to dew point temperature. So the air is the moisture is separating from the air because of dew point temperature. Or you'll find the droplets of water on the plant leaves or in your vehicle seat or in glass in winter season. Because of what? Because of dew point temperature, right? Means the temperature at what the condensation start is a dew point temperature. Following. But how is it related to the HVAC? So go back to page number 16. So in page number 16 we learn, I think you have written here, you get the cool and dry air na. Dry air because the refrigerant is low temperature and flowing inside. So at the surface of this evaporative coil, you'll find the temperature less than equal to dew point temperature. And when the air touches to this coil, what happen? The air will have the moisture, the room air. So the moisture is going to be condensed on the coil. So the moisture is going to be separated on the coil, and that's the reason you'll get the cool and dry air. You see, condensation of refrigerant inside the coil, this is called condenser. But evaporation of refrigerant inside the evaporator, this is called evaporator. But at the outside of the evaporator, at the surface, when the air is through, this coil have the temperature less than equal to dew point temperature. So the moisture from the air is condensed on the object, on the surface of this pipe, and you'll get the cool and dry air because the moisture is separating na. Another thing you notice, you'll get the water from window and split AC. So the water from where? From the room only, because of dew point temperature. and this is latent cooling. Change of phase na high air because of what? Because of dew point temperature. So I hold the dry air because after learning dew point temperature you can understand, right? Clear? Now one interesting question. So in which season you'll find more dry bulb? More wet bulb? In winter season, right? Now one question here. So my question is, in which season you'll find more humidity? Means more moisture, more humidity. Summer or winter? The correct answer is summer. Why summer? Because you see, in summer temperature is more, and more temperature means more evaporation. More evaporation means more moisture in the air. I'm not talking about the desert area. Desert area is special case. In general, if you speak, you'll find more humidity in summer. So remember, summers are dry, summers are wet. Because देखो समर में गर्मी ज़्यादा है तो गर्मी में इवापोरेशन ज़्यादा होगा, इवापोरेशन ज़्यादा होगा तो जो वाटर है मोर इवापोरेट होगा ना, and more evaporation means more moisture in the air, right? So in summer humidity is more, right? And that's the reason we'll get more sweat in summer, because our body generating the sweat continuously. If the moisture in the air is less means the air will touch to, whenever the air touches to our body to extract the moisture, but air already have maximum moisture content. When the air touches to your body it will not extract the heat. That's the reason in summer we'll feel more moisture, more sweat, right? And in winter the humidity is less. Why? Because of dew point temperature. Just now we learned na, you'll find more dew point temperature more in winter, and whenever dew point temperature means moisture from the air leave and condense on the object. We are talking about the moisture in the air, not outside the air. So in winter what happened? Because of low temperature, because of more dew point temperature or less than equal to dew point temperature, the moisture loses from the air and condense on the object. So the moisture in the air is less na. So what happen in winter? You'll find dryness of skin, because the moisture is less in the air. Whenever air touches to your skin, the moisture is less in the air, so it will extract more and more the sweat from our skin and we'll feel dryness. So we are using moisturizer so that we can create the layer between the air and the skin, so that it can not extract the more moisture. So it means winters are dry and summers are wet. In general, in desert area case is different, or snow falling area the case is different, but in general winters are dry and summers are wet. And winters are dry means we require heating and humidification. The process of adding the moisture is called humidification. And in summer we require cooling and dehumidification. Dehumidification means the process of extracting the moisture. And if you go back to that same page number 16, you see the evaporative coil extract the heat as well as extract the moisture which is required in summer, right? So this same one coil evaporator, remember this is important, again we'll use this point at the time of machine selection, classification of machine, etc. So in evaporator what happened? The moisture, the air loses the heat as well as lose the moisture, so you'll get the cool and dry air, means cooling and dehumidification which is required in summer, right? But not completely. For human comfort we require some amount of sweat, but how much amount we'll discuss in the next topic. Humidity ratio and relative humidity. What is humidity? Moisture present in the air na? And humidity ratio means the moisture per unit volume. Suppose if I measure the moisture of the complete room is that we can call humidity, but if I measure the moisture per kg of air or per pound of air, we can call humidity ratio. Simple. So it is also called as specific humidity. Specific means per unit volume na? Or moisture content. It's the mass of water vapor present in 1 kg of dry air and generally expressed in terms of not grains, it's a grams. Please update grams per kg of dry air in metric system, and grains is okay, grains per pound of dry air English system, and 1 pound equal to 7,000 grains. But the important point is here, highlight this, it is used to find the latent heat. Remember, for sensible heat dry bulb we are using. For latent heat We are using humidity ratio, because with the humidity ratio per unit volume we are getting the moisture, no? We'll multiply with the total volume, so we'll get the total moisture. With total moisture multiply with the specific heat of moisture, we'll get the latent heat in the calculation. Next level. Okay, so remember, triable for sensible, for latent heat we are using humidity ratio. This is important. We'll use this value also directly in the calculation. Point 1 and 4 directly in the calculation. Next we have one more important property, relative humidity. This is interesting and important too, and I think remember in first class we learned for air conditioning. For air conditioning we required comfort, temperature and the moisture, and the moisture means RH, relative humidity, and we learn it should be 30 to 60, and for calculation point of view we are taking 50 as a standard. So what it mean? Humidity you know, but what is relative humidity? And humidity you know, and you also know humidity ratio. Humidity ratio means moisture present per unit volume, and humidity means total moisture. But what is relative humidity? We'll discuss now. Relative humidity means we are relating, we are comparing with what? I'll show you. I'll give you a simple example and try to understand the concept. Simple. For example, day 1. Suppose this is a top view of the classroom. Day 1. I am maintaining 76 degree Fahrenheit, and by using a steamer or humidifier I am adding the moisture. After 3 hours when I measure, I got 10 pounds. After 4 hours, 5 hours continuously I measure, I got 10 pounds only. It means at this temperature the maximum possible moisture content is 10 pounds. Means RH is how much? 100%. Means air is saturated. Maximum no moisture, air is saturated, right? This is the maximum case. This is the saturated case. 2. Same classroom, but this time I am not adding any moisture. I am maintaining only 76 degree Fahrenheit, but when I measure the moisture level, I come to know 5 pounds. So how much will be the RH? 50%. So on what basis 50%? Because we know that 10 pounds is 100%. So what we did just now, we compare, this is the actual condition and this is saturated condition. So what we did just now, we compared actual with the saturated. So this comparison, this relative or this relation is nothing but relative humidity. Means how much will be the maximum possible moisture at compared with the present moisture at the same temperature. You cannot change the temperature. You cannot compare with the different temperature. Why? Because if you increase the temperature 76 to say 90 degree Fahrenheit, increasing the temperature, RH also increases. Why? Because increasing the temperature, the evaporation also increases. The holding of moisture by the air will increase by increasing temperature. So you cannot compare it with the different temperature. With the same temperature, at the same temperature, how much will be the maximum possible? Compare with present. That relation or that comparison is nothing but relative humidity. And remember, for human comfort, what temperature you are maintaining in as per that temperature, what will be the possible maximum. Compared to that, if you maintain 30 to 60%, means for calculation we are taking 50% is a standard for human comfort. Means what temperature you are maintaining for human comfort, in that what will be the maximum possible of moisture. Compare with that, if you maintain 30 to 60 in between or say 50 for calculation is okay for comfort, because above 60% you'll feel sweat, below 30% you'll feel dryness of skin. Moisture, I'm talking about moisture, not air, not temperature. 30%, not 30 degrees centigrade. Below 30% moisture you'll find dryness of skin. Above 60% you'll find sweat. So 30 to 60 is a comfort range. So whatever the possible, compared to the possible, if you maintain in between 30 to 60, means you are maintaining comfort with respect to with respect to moisture for human comfort, right? Because this moisture also will directly affect to the human comfort. More also not accepted, less also not accepted. Following online. So this comparison is nothing but RH, relative humidity. And the same comparison we can do theoretically in terms of pressure. As the moisture increases, the pressure increases. As the moisture decreases, the pressure decreases. The same thing. So the ratio of actual water vapor pressure, not present, please update this. The ratio of actual water vapor pressure in the air to the vapor pressure in the air if the air is saturated at that dryable temperature. Means actual vapor pressure compared with the vapor pressure when the air is saturated at the same dryable temperature. So that comparison is nothing but RH. We are expressing in terms of percentage. Example, if the RH of air is 50%, it means it contains half the amount of moisture possible at the existing dryable temperature. Air, just now we discussed, when the RH is 100%, air is saturated. Apart from this, when the air is saturated, dry bulb, wet bulb and dew point temperature will be same. This is also one condition of saturation. When the air is saturated, when you still if you are adding the moisture, the old moisture replaced with the new, but the total quantity will be same here. So it's a saturated air. Enthalpy already we learned. Enthalpy is what? Heat content of the body. But again, why we are learning enthalpy? Because in the air we have a dry air as well as moisture. So we have drier heat, air heat as well as moisture heat. So the enthalpy of atmospheric air is the sum of individual enthalpies of dry air and water vapor. So the summation of both the enthalpy is the total enthalpy of air. Enthalpy is heat content, but heat content of dry air plus heat content of the vapor is the total enthalpy of air. Next we'll learn how to use the psychometric chart. So what you do, first of all I'll show you these properties, because in psychometric chart all this line together you'll get the confusion. So first of all, with this simple line diagram, in psychometric chart, dry bulb means represent with the what? Vertical lines. You see vertical lines. And wet bulb with the inclined lines. And wet bulb as well as one more, enthalpy with the inclined lines but with the different scales. I'll show you. Similarly, you see dew point temperature on screen is horizontal line, humidity ratio also horizontal line but different scales, and this curved line represent what? RH, relative humidity. Now the same thing I'll show you in psychometric chart. This is psychometric chart, and it's a train from the train company, but psychometric chart we have a standard. With the train company we have advantage, you'll get the separate scale for dew point temperature, not in the other psychometric chart. So if I zoom this, you see this 30, 40, 50, 60, this vertical lines, but increase in x direction is what? Variable, right? And if I zoom, can you see this 40 online, green color? Inclined lines towards left. 40, 45, 50 is what? Wet bulb temperature. Here you can see wet bulb temperature, this scale for wet bulb. And with the same inclination, if I go above 50, I can read 20. 20 is what? 20 is enthalpy. It means wet bulb and enthalpy both with the same angle, same direction, but different scale, right? Next, for example, if I go straight horizontal and if I stop up to here, this 80 is what? Humidity ratio. It's horizontal. Humidity ratio. Unit is what? Grains per pound of dry air. English system. Then if I continue horizontal and if I stop up to this point, for example 60 is what? Dew point temperature. So humidity ratio, dew point temperature both with what? Horizontal direction but different scales. Similarly, wet bulb temperature, enthalpy both with same direction but different scales. And at the bottom this is dry bulb. Now if you talk about this curved lines, can you see the curved line? You see this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These all represent RH, relative humidity. And this last curve is what? For RH 100%. Na? So this curve you can write page number 16 in data book. You'll find the same chart. And you can write this as saturated curve. Saturated curve RH equal to 100%. How to use this? Very simple. Don't confuse with this dense chart. This is very simple to use. If you know any two properties of air, you can find any other property using the psychometric chart without any experiment. And how to get the two properties at the time of load calculation, dry bulb and wet bulb of different cities you'll find in the data book will use at the time of calculation. But at present I'll assume some values to learn how to use this. So we'll do example 1. Example 1 I'll show you. Example 2 you can try. So start writing. Maintain separate notes for calculation, because all the calculation will do in the class. Maintain a separate book for the calculation, because these are simple calculation, but when we start load calculation we'll go for all the load calculation, the different sources. Theory you can follow from the printed notes, but calculation will do in the class. So start writing. Yeah. So start writing online in classroom. Example 1. For example, let me find out the condition of this classroom. Okay. You can write classroom dry bulb temperature. Yes, start writing online. Classroom dry bulb temperature 26 degree centigrade. You see at present in the remote it is showing 26 degree centigrade, so I am using the same. So 26 degrees centigrade. And relative humidity. And relative humidity is, at present we are not feeling more sweat or less sweat, means in between 30 to 60. So for I can take 55 because slightly more humidity, but if I take 55 you'll get the confusion in the first example to use the chart. So that's the reason I'm using 50, so that 50 directly we have the line. So you can write relative humidity 50%. Relative humidity 50%. Full stop. Next you can write find other properties of air using psychometric chart. So first example I'll show you. Second example you can try. So on screen, online in classroom. Very simple. If you know two properties, with the two properties find out the point. When you get the point, go in different direction, you'll get the properties. So on screen, online in classroom, 27 degrees centigrade, sorry 26 degrees centigrade na. But you see this chart is belongs to English system, so Fahrenheit. So quickly convert 26 degrees centigrade into Fahrenheit. Do it now. Convert 26 degrees centigrade into Fahrenheit. Yeah, 78.8 is correct online. So I am rounding off to 79. You know round off is applicable. Now online and classroom, on screen. Don't try. Let me show you this first. So 79 is here. You see, this is 70, this is 75, this is 80 na. So 75 to 80 means 5 division, means each division 1 unit. So this I can mark as 79, right? This 79 and 50% RH is here on screen. On screen 79 50% RH. This both will meet what at this point, right? Straight up, then curve, slide. So this is a point. When I get the point, if I go in this direction, I get very close. I'll take the rough value, because in software you can get the accuracy, but here I can take the rough value. So when I go straight here, 65 70, so this is 66 na. So WBT is how much? 66 degree Fahrenheit. Now if I go beyond this, if I mark here 30 31, enthalpy is what? 31 BTU, right? With this point, if I go straight right, if I mark here, this is 70 80, so 10 units but 5 division. So 74 70, this is 72 74 na, because 5 division 5 division and 10 units, so each division is 2 units. So this is 72 74. 74 is what? W, means humidity ratio, 74 grains per pound of dry air. Next if I go beyond this, if I mark 55 56 57, round off to 58. 58 is what? DPT is 58 degree Fahrenheit. That's it. Simple. Quickly copy this. I'll give you one more example. You can try. Quickly take one more example. Write city, CITY, city weather report reads. City weather report reads. Following online. Second example 2. City weather report reads 60 degree Fahrenheit you can copy from screen. 60° Fahrenheit dry bulb dB and 55° Fahrenheit wet bulb WB. Full stop. Find other properties of air using psychometric chart. Find other properties of air using psychometric chart. You can find now or else you can complete in home, but you must verify both. Okay. And verify the result from your notes, page number 23. The same example is given. You can verify the value with your calculation from the notes, but you try this in home and verify this from the beginning. Here first what you do, select IP or SI, which system you want to use. Very simple. And as of now, for example, I'm using IP. Anyhow, you know the measurement system, you also know the conversion. In chapter 3 already we learned. And if you know the concept, you can try with any system. But your responsibility try in both the system, because at present you don't know in which company you're going to get the job, at which system they are going to use. And many consultants, they are dealing with the mixed units. For example, for flow rate they are using CFM, for ducting they are using MM. So MM is metric and CFM is English. So you must know both. Okay. So once you understand the concept, you must try in other system also. So this is simple. So click IP at present. Next, can you see this icon online? Can you see this line with this dots, this icon here? And this icon is state. You see, state, point and process. Click this, you'll get the window. In this window, we'll add a new point. So go for add a point and we'll go for example 1. Example 1 was classroom condition. Na? So I'm writing CR, means classroom. And classroom, we know dry bulb, right? 79. Yesterday example, same example. And we consider RH as 50%. Na? So what you do? First parameter enter here dry bulb, because default dry bulb is required. Second parameter can be any other property. So we consider RH, right? And RH 50%. When you enter 50%, you'll get all the values. We can verify now. Wet bulb 65.8. What we got yesterday? Yesterday. Here you see wet bulb 65.8. How much? 16, 50%. Then we are using Fahrenheit. 79 with 50, right? What was the wet bulb online? Yesterday, how much we got? 60. Here you see 60. 60. Dry bulb 78.8 na, so 79, right? And here 50% RH. Wet bulb, I'm talking about wet bulb, not W. You are talking about W means humidity ratio. Wet bulb was wet bulb. Yes, online. Wet bulb, how much yesterday? Find out that yesterday example. Give me that notes. Give me your notes. 26 what degree centigrade? We convert into Fahrenheit now. Why you are so confused? You see, example 1, WBT is 60. There is a difference, 65 here. And again, we need to check in manual, because you'll not get this much of difference. Okay. WBT online, how much? WBT, wet bulb, number 16 in data book. Okay, I'm again in the software. First decide the system. Next go for state, point and process. Online on screen. Add a point. The point name says CR. Dry bulb 79 and RH we are getting 50. Once again. $79 here, 50%. The point is here. Yes. So right side this 75 is what? W. What? Humidity ratio. But WB is inclined na? Here. So nearly 66. Nearly 66. Right? Not exactly, nearly 66. Right? Now, so you update in the notes. Yesterday I've given 60 WBT. It's not 60, it's 66 degree Fahrenheit. Please update online and classroom in the notes. Degree Fahrenheit. What? Wet bulb. Hmm? Yeah, enthalpy is here. This is 31. That is correct. And what about W? Humidity ratio. How much you got yesterday? Correct. 74 is correct. Okay. And dew point. Please verify dew point. 58 is correct. Okay. So now you have all the values now. We'll check, we'll verify with the software, because in software and manual you'll not get much difference. One or two max. Okay. So here the same on screen online. We are starting now only. IP, select this point, then go for add a point, then point name for your reference CR, dry bulb 79 degree Fahrenheit and RH 50%. Now WB 65.8 means 66, right? So run up to 66. Now in manual also we got the same. RH 50%. Okay, W is omega. Now W is omega means humidity ratio. How much you got? 74. Here also 74.3 means 74 only, because round off to 74. And what about enthalpy? Yesterday you got 31, right? Here you see 30.5. So round off to 31 only, right? And what about dew point DP online? 58.7. So we'll take 59.7, na? Right? So after verifying, simply click on screen. Simply click apply. When you click apply, what happened? The point will be available on the chart. Can you see the point? And when you take the cursor near to the point, you can read all the values instantly at the left column. Means here. Take the cursor near to the point, you can read the same values approximately in the left column. Again, if you want to get the information correctly, click the same point. You'll get the point here. Okay. This was example 1. And we did example 2 now. So for one more point, same procedure, add a point. This time what? City. City weather report means the point name is city. Okay. And in this case we have dry bulb 60, I think remember, and what? WB 55, right? So when you enter this 55, you can verify now. RH, how much you got yesterday? Not completed, not done. Okay, you can copy this. RH is 73.28 means 73%. You can verify, you'll get very close. And enthalpy 23 BTU and dew point 51.4 means 51 degree Fahrenheit. Okay. So in this way you can find out this values from this psychometric software if you are dealing with manual load calculation. But if you are using HAB software, automatically you'll get all this information by software if you enter the city elevation, this latitude, longitude, etc. Okay. This is more accurate compared to the manual chart. Yes. You see, if minimum 2 parameters required to use this psychometric chart or the manual. Without this, you cannot use any of this option. Yes. Even in manual also we require dry bulb plus any other property. In software also dry bulb with any one property. Then only you can use, or else you cannot use. Don't install this. With any one property means to use psychometric chart, 2 properties are required. And dry bulb is a basic availability, because dry bulb we can measure with a thermometer. But I got your question. Your question is from where to get this, right? From where to get this dry bulb. For the data is available. We'll use at the time of calculation. For all the cities, dry bulb for the hottest day, for summer, for the minimum temperature in winter for winter, and maximum temperature for summer. Both the dry bulb is available almost for all the cities in data book. at the time of calculation we'll use. And with that dry bulb, you'll get the wet bulb, because wet bulb also we can measure, na? So this two property by default you'll get from the data book at the time of calculation for any city. At this level, simply we are learning how to use this, right? We are not using this in the project. When I start the project, we'll pick this dry bulb, wet bulb. If you want, you can refer page number 22 data book just for your reference. Anyhow, we'll use that one at the time of chapter 6. Instant at present, just open data book page number 22. You can check the values for different cities, and you can find out at present for Hyderabad, because the first sample project is Hyderabad. Then we'll go for US project, then one Gulf project, Villa project, data extraction. So in data book page number 22, for Hyderabad you can find out the dry bulb and wet bulb. Okay, for reference, but don't worry, we'll discuss that table in detail in chapter 6, building survey. At present we are learning the basics for what? For load calculation. Next, clear? Don't worry, what you are learning, you learn these steps thoroughly. All this will use at the time of load calculation. Then you can understand why we are learning this one. So at present, just don't think that this is not used or something is not required. Everything what we are learning will use at the time of load calculation. Okay, and this is simple. And with this we did chapter 4. And apart from this, in psychometry we have some more points to discuss, like sensible heat ratio, humidification, dehumidification, that, and this one more option, contact factor, bypass factor. All these topics we'll discuss at the time of load calculation. We have very important topic, units and conversion. And as a mechanical engineer, as an electrical engineer, as a civil, whatever, if you're working as a design side, installation side, drafting side, estimation side, this topic is very important. It's a very basic for an engineer. If you don't know the different system of units, and if you don't know the conversions, all the time you'll find the difficulty. If you're working in design or on estimation, especially in estimation means you're dealing with the quantities. And if you have confusion in the conversions, and if you order the wrong quantity, if you place the order for double quantity, or if you place the order for half quantity, that definitely it will be a problem on site. And many times the metal we are placing order from other countries, the special type equipment, etc. And at that time, if the quantity is not correct, it will be a problem. So it will become a very big issue. So these units and conversions are very important for a beginner as well as for experienced people. Okay, so in detail we'll discuss. We'll spend some extra time on this topic, because this units and conversion is common for all the services, even for all the areas, even as a HVAC also. In any area, this is important. Okay, so in detail we'll discuss. So first of all, we'll understand the importance of this units and conversion. For example, in first class, okay, so in class 1 already we learned the human comfort temperature is what? 76 degree what? Fahrenheit. But by mistake, if I write 76 degree, 76 degree Fahrenheit is the standard, na? Or 25 degrees centigrade. But by mistake, if I write 76 degrees centigrade, then people will die. You see, for example, if you use the hot water from the heater, suppose you are in the bathroom and you are taking the hot water from the heater directly without mixing. So the hot water temperature, standard temperature is 60 degrees centigrade, and you cannot reach that direct. Mixing is required. Okay, so 60 degree you cannot handle. 76 degrees centigrade is what? Very high. People will die. Similarly, suppose you are writing an exam and you're supposed to pay 10,000 Indian rupees, but by mistake you paid $10,000. Quantity increased to 70 times. If amount is there in your account, means again it will be a big problem for you. So this is the importance of units, quantities. So I think you got the idea. Next, so let me start. Here units, concepts such as length, area, volume, temperature, flow rate, electrical energy, the list will continue, are called physical characteristics. How these are physical characteristics? For example, length, physically we can measure. Volume, we can measure physically. Area, temperature we can sense physically. Even electrical current also, all physical, what have physical characteristics. And physical characteristics are measured by a standard quantity called units. For example, if I write 25, this 25 is what? This is number. But if I write 25 meter now, so you got the physical characteristics of this number, na? It's a distance. Similarly, if I write 25, this is a number. But if I write dollar, it's a currency, right? So this unit, with the unit, we can find out the physical characteristics of that number. Okay, you know this, but as I said, the syllabus is from basic to advanced. And this basic is very important to reach the advanced level. Many people have confusion in the basics only, and they're finding difficulty at the time of designing. So don't underestimate these topics. This topic is not just for information. This is for designing. So you must involve in this. You must read this thoroughly, and you must by heart all the conversions, at least which is given in the notes. And the detailed conversion is given completely in the data book. The list, almost 100 to 100 conversions, 100 to 120 conversions, but at least which is given in the notes, some 10 to 12 that you need to by heart. So for example, meter is used to measure length. Similarly, square meter for area, degree centigrade for temperature, etc. So we have number of measurement system. So we'll not talk about all the system. We'll talk about the system which is used in the construction industry, including the services, including this MEP services. So if you talk about the construction industry, we are using mostly two systems. One is SI metric and second is English. Okay, so first we'll talk about SI metric. And SI metric is not one system. SI metric is a combine. Actually SI is different, metric is different, but both are interrelated. But how? I'll show you. So first we'll talk about SI metric, then we'll talk about English, because English is straightforward directly. So there are two system of units used in HVAC industry. Why is given HVAC industry? Because at present we are talking about HVAC, but not only HVAC, complete construction industry, including all the services. One is called inch pound, in short IP, US, Imperial or English. All are same, different name. English means Imperial, IP, US, etc. And the other is called SI system, nothing but international system of units. But where is metric? I'll explain about metric. So from metric only, we got this SI. How exactly? Before SI, we have only metric with English. So we'll talk about metric first. Metric system. In metric system, if you want to measure length, one can use millimeter, centimeter, meter, kilometer. And if you want to measure area, again, square, meter square, etc. If you want to measure time, you can use hour, minute, second, etc. So before SI, we have metric only, and companies are using this, but they are finding difficulty. How? For example, if I consider company A, B, and C, suppose this is A, this is B, and this is C. Suppose this is car manufacturing company. So car manufacturing company will not manufacture the tires, na? They will take the tires from other company. Suppose this is Michelin tires, or this is a tire company, and say this is some other like brake liners company. Even brake liners also, they will means many components the manufacturing company take from the other companies. So at the time of car manufacturing company dealing with a new model, what they will do, they will exchange the information from other multiple companies to get the other parts. So at the time of exchange the data, if all people are using metric, so metric means suppose they are using mm, metric. Suppose they are using centimeter, this also metric. Suppose they are using metric, meter, this is also metric. So whenever exchange of data, the first problem is conversion is required. So waste of time. And if any problem in the conversion, that will affect to the whole system, whole process. And this problem is not only between these three companies, it's a global issue. So in 90s, many companies held the meeting and they decided to use only one option in this. So what they did, they pick meter in metric, they pick square meter for area, they pick second for time. For flow rate, for flow rate means discharge, they use meter cube per second. For temperature, they are using centigrade, etc. Okay, and all this set is nothing but SI. So SI is not a new, it's a part of metric only. Okay, now if all the people are using SI, the problem can solve. So SI is not a new system, it's a part of metric only. Okay, so if all the companies are using SI, the problem can solve. But still the problem is not completely solved, because for small component, if you use metric meter, for example, a small engine component, if I use meter, the value is going to be 0.0000 something. Na? It is difficult for in communication, it is difficult to handle. So now in market, wherever applicable, we'll use SI or else we'll use metric. So that's the reason we are using the combined option. We are calling SI metric. So in construction industry, wherever possibility is there, we can go for SI or else metric. For example, if I talk about duct, a duct is a passage used to convey the air. We will discuss in module 2 for air side. So many companies, almost all the companies, those who are dealing with SI system, the duct, for example, this is a passage. This is the duct through which air is flowing. So this here is a width and here is a height and length. So length is lengthy, so we can measure in meters. But height and width, if you measure in meter, the value is going to be 0.5 into 0.3 something. So it is difficult even for workers on site. So we are using, say, height 300 mm, width 500 mm. So we are using mm. Mm is metric, and here is meter is SI. So it's SI metric, right? Following, online. So we are dealing with the SI metric in actual practice. But apart from this, we have one more unit to discuss, because SI metric is not globally used. Some majority people are using SI metric, but if you talk about US, they are using English system. In Gulf, many companies they are using English system. Even India also they are using English system, because English system is very easy to understand. Feet and inches, we very commonly use. Okay, so the next option in market is English system. So English system also known as IP, US or Imperial. So some examples are given here. You see English system, distance. This is just few examples. The detailed information for different units you'll find when we're dealing with the design. So distance for English system, feet or inches, area square feet or square inch, flow rate. In short, we are calling CFM. You can highlight this, because most commonly in actual practice, if you're dealing with English system, the flow rate we are calling CFM. Actually, it's a cubic feet per minute. But in general, in short, we are calling CFM. CFM, remember, which is very commonly for ducting side, like 5,000 CFM, 200 CFM, etc. at the time of dealing with air site after finding the tonnage and selecting the machine. We'll discuss this in module 2. At present, just you understand CFM is cubic feet per minute. Next is what? Temperature, degree Fahrenheit. These are few examples for English system. Example of SI system. Distance, meter, not centimeter or millimeter. If you talk about strictly SI. Area, square meter. Flow rate means discharge, cubic meter per second. In case of metric, we can use liter per second. In case of strictly SI, meter cube per second. Temperature, degree centigrade. These are few examples for units. Next, same theory what I explained. SI unit are part of a unit which is commonly used, called metric. The SI system of units uses only one unit of measurement for each physical characteristic. For example, length means we are using only meter. Strictly SI. SI metric means you can combine, but strictly SI means only meter. But however, occasionally we may use metric unit, which is not standard SI unit, because this is in common practice in not only HVAC, in the construction industry. Okay, so it's not a fixed rule you must use SI. As per the requirement, we can mix metric also. That's the reason we are calling SI metric. Okay, even in HAB software, at the time of selecting the system, selecting the units, we have two options: SI metric or English. Okay, Next, conversions or equivalents. This also very important. Conversions. This also very important. As I said at the beginning, if you fail at the time of conversion, that will directly affect to the quantities at the time of design, at the time of drafting, or especially at the time of metal takeoff, steamation. Okay. So what is conversion? The unit have fixed numerical relationship to each other called equivalents or conversion factor. Some conversions, maximum conversions are fixed, but some conversions are variable. For example, currency. $1 in terms of Indian rupees. It will change. It's not fixed all the time. But in terms of measurement in length, area, etc., we have a fixed quantities, fixed values. So first we'll talk about length or distance conversion. So in the list, first you can read 1 meter in terms of feet is 3.28 feet. But before dealing with this, we'll do a small activity and we'll confirm. Anyhow, maximum people already know this, but this is just for confirmation. What do you do? I'm writing some units on screen. In your notes, arrange this in ascending order, small to big. Do it individually, don't disclose, and we'll confirm. So first I'm writing meter, then millimeter, then inch, then feet, then kilometer and centimeter. So all of you do one thing, arrange this in ascending order, small to big. This millimeter. Agree with this online? Second from online, you can click. Good. Next, fourth online, feet is correct. Then meter, then kilometer. Fine. So all of you have. So can you visualize all these quantities? Start with mm. I think mm can visualize anyone. All these people can visualize. Mm is small. You know, everyone know. No need to discuss. And what about centimeter? You also know the centimeter. When you close your eyes, can you visualize centimeter? Fine. Because visualization is very important. Simply theoretically, if you learn means there is no use. If you visualize at the time of using these quantities, you can see the picture and you're not going to do the mistake. You can understand, this is a big unit, this is a small unit, this is a very big, etc. Okay. So centimeters and millimeter, centimeter, you can understand. What about inch? This also you know. This also you have in your mind the image. Then what about feet? Take out the measurement tape. Anyone have measurement tape? Purchase measurement tape, 3 meters, metallic type, 1 feet. Okay, I'll show you with the tape, but before this, some rough idea. Don't think that I'm making ready for fighting. Just I'm showing this how much is 1 feet. So what do you do? From this point, consider this is 0.1 and this is 0.2. Take a half, and from this half till the last. This is how much? Approximately 1 feet. This is approximately 1 feet. You should have that idea in mind, especially for beginners. Experienced people already know about this. But if you don't know, you must create the picture in your mind. This is 1 feet. Okay. Because when you are on site, all the time you cannot say that I want measurement tape, I'll measure that, then only I'll get back to you. Roughly you should have some idea. The height of the wall, the height of the door, the width of the wall, etc. The area of that floor. So you must develop this. You must develop this experience. So this is 1 feet. Okay, exactly with the measurement tape. I'll show you. I'm just calling him. Next, what about 1 meter? 1 meter is from, suppose if I start from my left shoulder and if I stretch my hand till the end, till the last, till the fingertip, here when I extend this, we can consider approximately 1 meter. Exactly, you can check with the measurement tape, you'll get almost same. So you must visualize, this is how much? This is 1 meter. Can you switch off second? Okay. So following. Similarly, how much is 1 kilometer? You should, I think you some have idea. When you drive your 2-wheeler or 4-wheeler, you know how much is 1 kilometer or how much is 2 kilometer. Okay, all of you know about this. So if you develop the practical idea, if you visualize, the work will be easy for you, because when you write any quantity, we can visualize what you're writing. Especially for beginner, you must develop this experience. But how to develop? By doing some measurement with the measurement tape. Okay. Next, so back to the topic, page number we are talking about length and distance. So here 1 meter is how much? 3.28 feet. So in 1 meter you'll find 3.28 times of feet, right? Next, 1 meter in terms of centimeter or mm, you already know. 100 centimeter, nothing but 1000 mm. Next, excuse me, 1 meter in terms of inches. But before this, 1 feet in terms of inch. Here you see this double dash represent inches and single dash means feet. So here 1 feet in terms of inches is 12 inches. If 1 feet is 12 inches and 1 meter is 3.28 feet, 1 meter in terms of inch is what? 3.28 into 12. Na? So quickly verify 3.28 into 12. Do it now. And you must involve in the class. Don't depend on other answer. You must involve and you must involve because try to make this training like hands-on training. Hands-on training means at the time of training only you try to learn maximum things. Don't wait. I'll go to home, I'll open the book, I'll plan for next week, then I'll start my revision. No. Try to learn maximum in the class and immediately you must practice on the same day because as per scientists, as per research, we have this theory. If you revise anything within 24 hours, 90 plus chances it can convert into permanent memory. If you revise anything in 24 hours, because when you learn something, first of all, it will be in your temporary memory, conscious mind. So if you want to convert into or push into the unconscious mind means permanent memory, you must revise within 24 hours. So 90% data you can transfer easily. Or after 24 hours, if you revise, the chances is only 4%. Thank you. The chances is only 4%. So you can decide. And that's the reason in the first class, I inform you to go for daily revision, daily updation. So you can make this course very simple if you revise on the daily basis. Because we cannot learn everything in one day. It's a daily process. Okay. So revise on daily basis, that will add advantage. So here, so you must involve. So 3.28 into 39 is 12 is how much? 39.36. But here I have taken, you see exactly 39.36 inches. And I have taken 39. Why? Because remember we are dealing with system designing, not component designing. Already we discussed in the first class, system and component designing. In component designing we require accuracy in mm or even microns. But in system designing we don't require this much high accuracy. For example, if the duct length increased to 5 mm, nothing will happen. If the duct width increased to 2 mm, nothing will happen. But again, if the engine piston increased to 2 mm size, the total engine performance will change. So we are not talking about the component designing, we are talking about system designing. So in system designing, round off is applicable. If you get the value less than 0.5, take it the lower value. If you get the value more than 0.5, take the higher value. Suppose if I'm getting 39.56, I'll go for 40. But I'm getting less than 0.5 now, that's the reason 39. So remember, in system designing, not only in HVAC, in any service, round off is applicable. Okay, next. 1 feet in terms of inches, 12 inches, not 10 inches. Maximum, some people have confusion. And 1 inch exactly is 25.4, but round off to 25 mm for system designing, right? Similarly, 1 feet in terms of mm is 304.8 exactly, but round off to 300 because 12 into 25, 300. Because 1 feet in 1 feet 12 inches and in 1 inch 25 mm. So 12 into 25, 300. Okay. Next, similarly, 1 yard. Yard means how what? Generally, people used to people think yard means gaz. No, gaz is not yard. Square yard is gaz. Normally, when you purchase land, we are measuring as 100 gaz. Gaz means square yard, but yard is khadam. In local language, khadam. So 1 yard is how much? 3 feet. 1 square yard is different. That is area. But here 1 yard equal to 3 feet. Okay. So this is about length, nothing but distance conversion. Next we have area. This is also very important. If you know the area, you can use the thumb rule for tonnage at the very initial stage of project. So this is also important. First, mathematically 1 square meter equal to 10.76 square feet. So what is area? Before this, length means what? Length or distance is 1d. one dimension, na? And area is what? 2D, right? And volume is 3D. So we have 4D, 5D, 6D up to 7D in BIM concept. If you talk about Revit, that is totally different. But in actual practice, we have 0D. 0D means point. 1D, 2D and 3D practically. But we have 4D to 7D concept in BIM, building information modeling, that related to the Revit side. So here 2D, area is 2D. So 1 square meter equal to 10.76 square feet. Suppose if I draw here 1 meter, this also 1 meter. So this surface area, suppose I'm writing 1 meter here, 1 meter. So the surface area is 1 square meter, na? 1 into 1, 1 meter into meter square meter, equal to what? 10.76 square feet. So how? In 1 meter, how many feet? 1, 2, 3.8. 3.8 feet, na? Here 1 feet, 2 feet, 3 feet, 0.8. If I take 1 feet, 1 feet, this is 1 square feet, 2 square feet, 3 square feet, 4, 5, 6, 7, 8, 9. And this area, suppose 1 and 2, this complete area, if you calculate, it is 1.76 square feet. So total how much? 9 plus 1.76, 10.76 square feet. It means in 1 square meter area, you'll get 10.76 times of square feet area. Practically. Theoretically simple. Mathematically, if you square this squaring both sides, you'll get this result. 1 into 1, 1, meter into meter, meter square, 3.2 into 3.2, 10.76, square in feet into feet, square feet. Theoretically simple, but practically 1 square meter, in 1 square meter, you'll find 10.76 times of square feet area. Right? Clear? Next. Second point, reverse. 1 square feet in terms of square meter. So can we write 10.76 square feet equal to 1 square meter? We can write, na? So if 10.76 square feet equal to 1 square meter, 1 square feet equal to how much? So how we'll do? 1 divided by 10.76. So 1 divided by 10.76 will get 0.03 square meter, theoretically. But how we can understand this in a practical way? 1 square feet equal to 0.093 square meter means what? How to understand this? For example, 1 means what? 100%. Right? Similarly, 0.1 is how much? 10%. Right? So in the same way, if I write 0.09 means what? 9%, na? Right? Sorry, 0.1 is 10%. 0.0, this is 9.93. 0.093 is how much we can consider. Okay, I'll write like this. Similarly, say 0.5 is how much? 50%. 50%. So 0.1 is 10%. So 0.093 is how much? 9.3%, na? Less than 10%. This is 0.093 is close to 0.1. Means I can write 9.3%. Understanding? And it's mathematical also, right? So 0.093 means 9.3%, right? Of what? So it means that 1 square feet is 9.3% of square meter area. For example, this is a total 1 square meter, na? And this is 1 square feet, this box. So this box is how much? This is 9.3% of the total. So it means that 1 square feet in terms of square meter is approximately, we can say 9%, for understanding, right? Theoretically 0.093, but practically it's a 9, approximately say 9%, means 1 square feet is 9% of square meter area. Okay, clear online? Next. Anything you can discuss, because this is very basic and very important. Till the end, you're going to use this conversion in all the areas, in all the modules. Okay. So next we have 1 square feet equal to 145 square inch, because 1 feet equal to 12 inches, na, squaring both sides. So 1 square feet equal to 145 square inch. It means in 1 square feet area, you'll get 144 times of square inch area, means 144 small boxes of 1 inch. of 1 square inch. Next, similarly, 1 square yard equal to 9 square feet, because 1 yard equal to 3 feet. So 1 into 1, 1, yard into yard, square yard. 3 into 3, 9 square feet, feet into feet, square feet. Means this is very simple to understand. You see, 1 yard, 1 yard. This is 1 yard, this is 1 yard, this is 1 square yard, right? So in 1 yard, how many feet? 3 feet, na? Here also 3 feet. So if I just draw this, how many boxes? Total 9, na? So 1 square yard equal to 9 square feet. Simple. Next, tonnage conversion, which is very important for a HVAC engineer. This length area is common for all the services, but tonnage specifically for HVAC. So 1 TR equal to how much? 210 kilojoules, you know, per minute. Similarly, 1 TR equal to 3.5 kilowatt mechanical kilowatt. Apart from this, some more conversion which is important for interview point of view, and we'll use in the calculation also. 1 TR equal to 12,000 BTU per hour. Next, 1 TR in terms of CFM. So for standard machine, we are considering 400 cubic feet per minute. It's not direct conversion of it. It means if you want 1 ton of cooling effect in this room, and if you install the standard machine will supply 400 cubic feet per minute, the flow rate, the cool air, and based on that cool air, the 1 ton heat can be extracted. So it's not direct heat conversion. It's a flow rate required or supplied by standard machine to get 1 ton of cooling effect as per standard, as per ARI. Okay. Next, anyhow, we'll use this in module 2. At present, just you by heart this. Next, 1 TR equal to 2.4 GPM. GPM is what? Gallons per minute. And which gallon we are using? We are using US as a standard. US gallons as standard, and it's a small mistake. You please update this. This is not 3.75. This is 3.78. Update this in the notes online. Those who don't have notes, you write page number 11 and you write here. Later when you get the notes, you can update. So 1 US gallon equal to 3.78 liters. So we are taking in India and in Gulf, we are using US as a standard, not UK. For UK, we can use 4.5, but this 3.4 GPM based on US gallon, not UK. So what it means, 1 ton equal to 2.4 GPM. We have a system called chill water system, the big system in chapter 5. And we have chill water piping, pump selection, fittings, accessories, number of topics related to chill water piping, and the major system, the big system. So if you talk about chill water piping, inside the coil, when the water is flowing at the rate of 2.4 gallons per minute, you can expect 1 ton of cooling effect on the coil. This is the again requirement for machine. And for standard machine, this may vary also, but for standard machine, we are considering 2.4 GPM. Yes, online. So in module 3 we'll use this GPM, and in module 2 we'll use the CFM for air side, and for water side GPM. I'll give you the formula also. For standard machine 2.4 GPM when the delta T is 10. But what is delta T at all? At present you don't know. After learning the chill water system, we can discuss in module 3. Okay. Next, 1 ton equal to 3000 kilocalories per hour. And US gallon, UK gallon, and one more, 1 CFM equal to 1.7 CMH. CMH means you can write cubic meter per hour. You see, CFM is what? Cubic feet per minute, na? Similarly, CMH means cubic meter per hour. Okay. Page number 2 in data book. 2 data book. You'll get 2 booklet. One is note and one is data book. The same what I'm using on screen. So here in page number 2 data book, this page is taken from Ashtray, chapter 38, units and conversion. You see, units and conversion means is not, it's a physics. But we are dealing with HVAC, so we have picked from Ashtray handbook 2009. So here, can you see the list of conversions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Complete list of conversion with the 2 columns, right? Starting with the Ecker, then atmosphere bar, BTU, then EDR, feet per minute, FPM. So by next class, you must by heart all this. Can you do this? Can you do this class? Before next class, can you memorize all this? what I'll do, I'll reduce this task. Instead of page number 2 in data book, can you memorize this page number 11 in the notes? I'm happy. You see, this is the psychology. If you think for big, and if suppose initially if I say to by heart this page number 11, people will think okay, will. But now after showing the big, this is look like very simple. Now you are very happy. This is a technique which you can use in the life also. If you want to do anything, think 10 times harder. The present task will become easy. You can use this technique in any area. Okay, so this is nothing for you now. You can memorize this very easily. Just 10 to 12 conversion. Okay, this is very easy compared to that one. Even if you think you can memorize that also, page number 2, but at least page number 11 you memorize, which is commonly used till the end. Apart from that, you'll find some more conversions at the time of designing. At the time you can use, but this is very basic. But now the question is, after memorizing also people find difficulty using this conversion. We'll go for a small activity. For example, quick answer. I'm expecting quick answer from all. For example, if I want to convert, first of all, 1 meter equal to 3.28 feet. Now 90 feet. I'm interested to convert into meter. Quick, 3.28. You are going to multiply or divide. How many people want to multiply and divide to get the result? Quick answer. Online people can click on your answer. To get the result in meter, you are going to multiply or divide. Click on your answer. 1 divide, 2 divide. Online class. Divide 1, multiply, 1 divide. Yes. Divide. Yes. Divide. Other people online? I think all answer. No. Okay. So the correct answer is divide. Why? The reason? You see, out of in online 4 classes, in classroom 3 people, out of means in 7 people we have some different answer. Out of 7 people we have different answer. It means there is a chance of confusion, and it's normal. There is a chance of confusion. So how to avoid this confusion at the time of using this conversion? I'll give you a simple technique. Why we are dividing? First of all, the answer is correct. Why we are dividing? 1 meter is equal to 3.28. Right. So we can follow the simple rule. Unit and value. So what happened in this? Feet to meter. Unit what increases na? Because meter is more than meter is bigger the unit compared to feet. So unit increases. Whenever unit increase, value must decrease na? So what we'll do? We'll divide. To divide, when you divide, the value will decrease. Simple rule. Or whenever, for example, if I give 30 meter and if you want to convert into feet, what happened? Meter to feet. So unit decreases. Unit decrease means value must increase. You are going to multiply. Simple rule. But be careful. This rule is applicable only if the conversion value greater than 1. If the conversion value less than 1, we cannot use this. Means you need to reverse. For example, we have 2 conversion. 1 meter equal to 3.28 feet and 1 feet equal to 0.3 meters. Both are same conversion. If I use this conversion, 1 meter equal to 3.28 feet, this rule is accepted. Means when unit increases, value decrease, divide. When unit decreases, value increase, multiply. But for example, if I use this conversion, then if I multiply any value with 0.3, the value will increase or decrease? Decrease, na? Suppose 100 into 0.3, we are multiplying. With common sense, people say it will increase, but no, it will decrease. It will be 30. 100 into 0.3 is 30. So when you're using the conversion less than 0.1, this divide will become multiply and this will become divide. Okay, so be careful. When you're using the conversion more than 1, this rule is applicable, or else reverse. So whenever you get the confusion, just wait for 2 seconds and find out whether you are increasing the unit or decreasing. Increasing the unit means value should reduce, and if the conversion is greater than 1, you can divide. Okay, simple rule. Following online. Next, so be careful with the conversions because conversions are important. Suppose somebody is filling form. Suppose you are traveling to some place for holiday, and your agent is filling the form to get the ticket. Instead of M, if you write F, then will you tolerate? Will you tolerate? No. So think. This is the importance of conversion. You are going to change the gender. So these are importance of conversion. So be careful. Be careful with the conversions at in all the areas. Next. So the same rule is given here. Only if conversion is greater than 1. If less than 1, reverse. Okay. Next, thumb rule for tonnage. This is also important for interview point of view. Thumb rule. What is thumb rule first of all? Thumb rule means what? Remember the value. The value. I think someone is disconnected. Thumb rule means the value based on the previous experience. A rough value based on the previous experience. For example, first day when you arrive to this office from your home or from your hostel, suppose you come to know that half an hour is a time. So second day what you'll do? You'll start 35 minutes before, right? Because already you got the idea, na? From my hostel to this office, it will take 30 minutes. So you'll start 35 minutes before. So what you did? You apply the thumb rule. So thumb rule is what? The value based on the previous experience. So we are learning the thumb rule for tonnage, and this is just a rough value at the initial stage of project to get the idea, to prepare the quotation for sales and for a small project directly you can apply also. Small project means very small, like 100, 200, 300 up to 500 square feet. And India maximum small project the people are using tonnage only, this thumb rule only, but it's not recommended. And thumb rule is generally over tonnage, but not for all the application. And this thumb rule is applicable only for commercial and residential, not for industrial. And this thumb rule is based on 3 meter space height. Okay. So this is simple. 1 TR as per thumb rule, 1 TR will cover 100 square feet area, floor area. With the height, we are considering standard 3 meter. Nothing but 9 point something 1 square meter, round off to 9 square meter. Okay. But we have a condition. This 1 TR will cover 100 square feet if you have exposure more than 2 sides. Suppose this is exposed, the roof exposed, and other side also exposed. But we have multiple room inside the building which is not exposed. Only the corner rooms or the perimeter rooms are exposed. Or the top floor we have the roof, but other rooms are not exposed. So in that case, you see, 1 ton will cover up to 130 square feet area. You see, for room exposed to 1 or no exposure. Okay. So this is thumb rule. And this thumb rule is for standard project. But now we have a green building also in market. So for green building, the option is given here. Thumb rule for green building is 150 to 300 square feet per ton. Higher coverage, because green building means the wall metal, the construction metal with insulation is must. Anyhow, in standard construction also in Gulf and in Western countries you'll find with the insulation. But this thumb rule, first thumb rule is for general means common construction, and the second thumb rule is for green building. So both are important. Now previous the people are asking only thumb rule in for a standard project, but now in market or now at the time of interview they are asking for as per the green building also. So for green building, 1 ton will cover up to 300 square feet, higher area, because the heat transfer is less in the green building area, because we are designing the construction with all insulation, with good insulation. Okay. And this is important for interview point of view. And we'll do one simple example. Thumb rule is simple. If you know the floor area, then divide with floor area with 100. If it is exposure, you'll get the tonnage. Or divide with 130. If it is not exposed, you'll get the tonnage. Right? Simple. So here you see a simple example. A supermarket measure area 2000 square feet. 3 side exposed. Find the tonnage using thumb rule. 3 side exposed means this rule is applicable. Na? So similarly, 2000 divided by 100, 20 TR is required. Simple. So this is for rough calculation, rough estimation at the initial stage of project. Especially sales people are using this one, and even technical people for small project can use this one. So done for today's session. And now we are ready to deal with chapter 5, and chapter 5 is classification of systems. Which systems? Air conditioning systems. And remember, in chapter 5 we are learning the different types of system. You see, right from window to chill water system. We'll not deal with the selection. Selection will do in chapter number 8 after load calculation. Okay, why? Because for selection we required the capacity, how much capacity or the tonnage for to select the machine. So this can be done only after completing load calculation. So chapter 5 and chapter 8 are interrelated. In chapter 5 we are learning the different type of system, how the system works, the cycle involved, the advantages, disadvantages, appearance, size, capacity, etc. Okay, so if you know all this, then we'll deal with the load calculation. After completing load calculation with the selector system, will complete machine selection of the selector system. So if you know the system, then only you can go for machine selection. So for example, if you miss chapter 5, it is difficult to deal with chapter 8. Okay, so that is also one reason you must attend this in sequence. You cannot miss the class. If you miss quickly, you must update, because we are dealing with the design means, as I said, it's like a chain. You cannot miss a single link. If you miss a link, you cannot complete the chain. Okay, so just I'm explaining the importance of this topic. So we'll start with this. So first, window. Just let me read this. The very small is window. Next, split also is small, limited capacity. Ductable split is for medium projects like a supermarket, is limited, not big supermarket, or a office, etc. Then we have package. Package we have higher capacity compared to ductable, and it's a single unit like window. Then VRF. VRF also medium category, means similar capacity like package, but not like chiller. Just I'm giving the idea. In detail we'll discuss, don't worry. Then finally, the most important topic for high-rise building for big project is chill water system. Okay, and remember, point 1 to 5 you can update this, put in the floor bracket and write this as DX system. DX system is what? In bracket you can write direct expansion. Okay, 5 is a DX system. DX system is in bracket you write direct expansion system. And this point number 6, under point number 6 you can write chill water system. Chill water system. And in detail we'll discuss what is DX and what is chill water. Let me start first with the window. So before starting any of this, I'll play one small video clip. First of all, I'll show you the different components. Under different components, we'll deal with the system. Let me play a video, because in vapor compression cycle, just we'll learn the concept how we are getting the cooling effect. And the same cycle you'll find in all the systems. With the video, I'll show you the components and how this component will assemble and how it will connect. Okay, so this is interesting, and this video belongs to Zamil, like Voltas in India. Voltas belongs to Tata, local brand, India. Similarly, Zamil belongs to Saudi, the local Saudi brand. So this video belongs to Zamil. Zamil manufacturing site visit.
Motor. Air conditioners have two assemblies.
You see, most commonly in India we used to call window AC, but in other location, commonly this is known as room AC or single AC. Okay, and remember, window and split comes under unitary system, not central system. Unitary means one room, one machine. Okay, so
lines producing over 12.
Can you see the base online here? This is a window AC base, and on this base
100 RACs per day.
Here you'll find the partition. Okay, this side you will find inside the room, and other side will place outside the building, means outside the means wall. Why we'll discuss. And this black color is called blower type of fan. Okay, and this blower is connected to a fan motor. I'll show you.
The process
So here you see, here is a fan motor. One shaft is connected to the blower, which is used to circulate the room air, and the other shaft will connect to an axial fan, which is used to suck the air from outside and throw on condenser to cool the condenser. And you know, vapor compression cycle, we are learning the same. Okay, in vapor compression cycle, you know the components: compressor, condenser, expansion, and evaporator. We are dealing with the same. Additionally is a fan motor. But here we are talking about the application side. In vapor compression cycle, we learn the concept, how we'll get the cooling effect. The same cycle used in this. Okay, next.
begins with the assembly of the mechanical components.
What about this? Yes, you know compressor, right? And you see compressor with this rubber. This is used, this is called isolator. This is used to reduce the vibration from the compressor to the unit.
Starting with the base pan, compressor, condenser coil, evaporator fan shroud.
You see, this is condenser fan. So one motor, two shafts. One is to circulate the water inside and circulate the air inside, and other is used to circulate the water from air from outside to outside only to cool the condenser. How exactly? I'll show you.
Evaporator coil.
You see, these are heat exchangers. And 1 minute, I'll show you this image.
One essential component in air conditioners must be the heat exchanger in its dual application.
Here you see, this is heat exchanger. Can be used for condenser or for evaporator. The size is different, but the component is same. Both are heat exchanger. And here you can find out the copper tubes. And what about this? These are all fins. So the default or the common configuration for this heat exchanger for condenser or for evaporator is copper tube, aluminum fins. But in market you'll find aluminum tube, aluminum fins, or copper tube, blue fins, copper tube, red fin, or with a different coating. But the default configuration is copper tube, aluminum fins. So you know why this tube? Tube is a heat exchanger to reject the heat to means at condenser and to extract the heat at evaporator. Then why these fins are required? It is used to increase the rate of heat transfer. You see, when the refrigerant is flowing, if it is a condenser, the hot refrigerant is flowing now. And when the hot refrigerant is flowing, what will happen? The heat will quickly transfer to the fins, and this can be easily transferred with the air to outside. Okay, so with this fins we are increasing the surface area. And you know, as a mechanical, you know, fins are used to increase the surface area to increase the rate of heat transfer. So the same concept. Okay, so next directly I'll jump to the same 955. And can you see these tubes? These are capillary tube. Expansion device. This process is called brazing, you know.
After the brazing comes the air pressure leak test.
So with this image you'll get 4 components. I'll start from the left. So this is what? Condenser. This is outside. And here it's not visible, but okay. So next is what? Inside. It's not visible, but you can assume here compressor na inside. And this is a fan motor. One shaft is connected to axial fan, which is covered with this. Other inside blower. And here is a expansion device, capillary tube, and this is evaporator. Okay. So the 4 components, and you know the cycle. So this, if I draw the line, this part will be outside the building, and this will be inside the building. And this part will suck the air from the room, and this fan will suck the air from outside and throw on this condenser to cool the condenser to get the refrigerant in liquid state. Okay. And after that liquid state, you know, through this expansion device, we'll get the cool refrigerant with a low temperature pressure and flow in evaporator. and evaporator will get the cool refrigerant, and when the air suck from the room, it will pass through this evaporator, loses the heat and what? Moisture. So you'll get the cool, at the other side you'll get the cool and dry air, means cooling and dehumidification, the same concept. Okay, next, but one more important point, let me play this. Dehydration means extracting the air from the heat exchangers, and refrigerant charging. And remember, refrigerant charging always in compressor in gas state by the manufacturer or on site as per by the service team.
And refrigerant charging.
Means in window means by the manufacturer.
Following electrical component assembly, complete unit testing is performed in addition to a functional test and one final refrigerant leak test.
So here you'll find one interesting and important point. Yes, online and class, can you see this sensor? See, this is a temperature sensor, and point 1 to point 2, this is written from the room, and point 2 to point 3, this is supply from the room. And you know, the front panel, a window, left side you'll find some grills, right side you'll find some openings. So right side is supply and left side is suction. So this is for return air and this is for supply air. Okay, means the same air circulate within the room, and when the air suck, first it will monitor the temperature, it will sense the temperature, then it will passes through the coils and fin, loses the heat and temperature, and you know, the blower will suck the air from the center and supply to the periphery. Okay, and the blower will suck the air from the center and supply to the side, and you'll get the cool and dry air from this outlet. And you can see this return is area is more and supply is small. Okay, and you see same air volume is circulating now. So if the area decreases, what will happen to volume? And I think you know, Q equal to AV, continuous equation. So here area is less, means velocity is more. Here area is more, so velocity is less. Okay, so return with the low velocity because area is more, and supply with the higher velocity to avoid the short circuit of air. Because both are very close now. If I maintain the same velocity, it can, the cooler directly may suck in the return. Okay, anyhow, this is not completely follow the standard of as per air conditioning, but commonly this is used in market, so we need to learn. So supply with a higher velocity, return with the low to avoid the short circuit. Apart from this point is important. So whenever air suck continuously, the return air temperature sensor will monitor the return air temperature. Okay, then why it is required? For example, I think you know, in window also you'll get the remote. Suppose with the remote, if I set say 23 degrees centigrade, my required temperature in the space, in the room, I switch on the AC and I set 23 degrees centigrade, but present room temperature say 30 degrees centigrade. I think you know, in the display you'll find room temperature and the required temperature. Required temperature, for example, if I set here 30 and room temperature is showing 23 is the required temperature, room temperature is showing 30. Okay, in the remote also you can find out that how much you set and how much is present. So what happened if I set 23, present 33, after some time what happened? From 30 to 28 and 26. So after some time this temperature will attain, and after attaining the temperature, the machine should control the cooling. If not, what will happen? If the load is less in the room, then continuously it will extract the heat and the temperature will be less than 23. It can be 20 or 15. If the very load is less, if it is starting somewhere, then it can reach to 15 or 10 also. So that will get discomfort. So means some controlling is required. So remember, controlling is done always based on the return air temperature. Okay, so whenever the return temperature same as what you set, say 23 I set, and in the return also sometime cooling is attained, in the return also same 23, means the machine will switch off the compressor, because this sensor will continuously monitor what you said. If you get the same, this sensor will give the signal to thermostat and thermostat will control or switch off the compressor. But the fan will run continuously to maintain the air movement. After some time, if the load increases, if the temperature increases, because it is monitoring continuously, then again suppose after some time the temperature is now say 24 or 25,
quickly it will, the sensor, with the sensor, the compressor will switch on. Like this, the machine controls. And remember, this controlling is not only for window, this controlling for all the air conditioning system. Okay. In split, in ductable split package, even in chill water AHUs. What is AHUs we'll discuss. So remember, the retained temperature is responsible to control the room temperature. But in chill water system, we'll talk about the retained water to control the chiller. But again, the chiller is connected to the air side unit called AHU. But in AHU, the concept is same. Or in FCU, the concept is same. But if you don't know AHU and FCU, don't worry. We have a topic in this chapter 3 only. In detail, we'll discuss because this AHU and FCU also one very important topic to discuss. Okay. So I think got the idea how this window air conditioning system works. So quickly we'll complete this today with the theory. Okay, tomorrow I'll play the same video. So first I'll show you the part for split AC, then we'll complete the split AC. So let me complete the window here first. So window AC, also known as single or room AC, capacity common in most commonly 0.75 to 3 TR is available. But remember, this capacity may vary as per manufacturer and even as per location. So in some location you'll find up to 70 TR this window. But most commonly for interview point of view, 0.7 to 3 TR. Even 3 TR also directly not available in India. If you want, you need to place a special order. This 0.75, 1 TR, 1.5, 2 TR is commonly available. Okay. Next, application can be used for small room, shops, small offices, etc. Means it's a unitary, so room AC, one room, one machine. Okay. Or if the room is big, we require 2 machines in 1 room. Okay. But in case of central air conditioning system, 1 unit can cover multiple spaces. That case is different, we'll discuss later. But this system is for 1 space or multiple unit for 1 space. So it's a unitary system. Okay. Next, advantages, low initial cost. You can purchase this with the starting, say 25,000 for 1 ton starting range. So initial cost is limited. Compact in size, very small, with limited space is required. Easy to install because it's like a plug and play. No need to fill the refrigerant, no need to do the commissioning on site. Simply like plug and play. We required 1 frame can prepare by carpenter and 1 rated electrical supply. Just that's it. We can easily install this. Next, low maintenance. Once in a season, if you do the servicing cleaning, it can run minimum 3 to 5 years or more than that as per the usage, as per the location also. But the disadvantage here, you see, ventilation is not as per ASHRAE or as per standard. Why? I'll show you one more image to get this idea. Here, you see the same air suck and supply. Is there any supply of outside air? This side is outside and this is inside, right? So you see inside air suck and supply to inside only. And this arrow is showing some air is entering inside. But don't think that this air is entering inside. You'll find the complete partition. It is a section view. But in the video, you know, complete section. So this direction is not mean that air is entering inside. This direction of air means this air is used to cool the compressor to maintain the efficiency. So outside air is from outside to outside only, which is used to cool the compressor, and the major task is to cool the condenser. Okay, and inside air is inside only. But in some models, you'll find some option here, some opening with the knob from inside. We can open or close to introduce some amount of fresh air. But again, that amount of air which is added is not as per standard, just a limited amount. It's not calculated. Okay, so in few models you'll find some fresh air option, but still the fresh air is not as per standard. Why? Because this window AC available with the limited capacity. If you provide the fresh air as per standard, what will happen? The fresh air in summer is hot and humid, will directly affect to the load on the coil. The cooling will reduce. Okay, so it is available with the limited capacity, so it's difficult to deal with the required or standard fresh air. Okay, so the first major disadvantage is not having ventilation as per standard. We are following ASHRAE standards, so it is written ASHRAE. If you're dealing with any other standard, so it's difficult. Next, noisy type of machine. Why? Because the compressor is close to the conditioner space, na? And you know this, it will create a lot of noise. Next, comparatively high energy use. Compared with what? Chillers. You see, you cannot compare this window with the chiller in terms of capacity. Chiller capacity start with 15 TR up to 3,500 one unit with air cooled, and for water cooled up to 6,000 TR one unit. But here, window is available limited to 3 or max 5, max 7 TR. Okay, so I'm not comparing this window in with respect to the capacity. Just I'm comparing the energy use. So how much energy, electrical energy consumed by window for 1 ton. If I compare with the chill water system, the chill water system power consumption is less. But how? After learning the chill water system only you can understand. So remember this point you'll find for all the DX system compared with the chill water system. Means all the DX system running cost is higher compared to chill water system. So after learning chill water system only we can compare. So at this level remember this point. See, look ugly in building elevation. And in Dubai or in UK, the municipal will not allow you to install this unit or at the elevation side. If it is visible means they will not allow, or they will put challan. So anyhow, even in India also, if I use this will affect to the building elevation, like boxes at the elevation side. Okay. Next, no uniform distribution of air. This is also one major disadvantage. And we already learned air conditioning means motion and distribution is fourth parameter na, in air conditioning. So this machine cannot provide the uniform distribution of air because we are installing at one side or in between the room, not on the ceiling. Na? So it will supply the air in one direction. So you cannot expect the uniform distribution of air. For uniform distribution, either we can use a ceiling fan or a separate wall mounted fan for distribution of air. So this is also one major drawback. Next, exposed wall is required. Can we install window in between the two rooms? For example, this is room 1, this is room 2. Can we install, suppose this room 1 is non-AC. AC. So can we install in between these two rooms, non-AC and AC? Why? We cannot install. Why? Because what will happen, this side the rejection of hot air from means it will continuously reject the heat from the condenser. So if it is a non-AC room also, after some time the room temperature increases because continuously we are throwing the heat out, and after some time the suction air temperature and the throw air temperature will be same. If the temperature means this refrigerant temperature and the air temperature is same, if there is no difference, means there is no rejection of heat. Initially it can work for 15 minutes or half an hour, but after this the room temperature increases, and when the room temperature same as the refrigerant temperature, there is no rejection. No rejection of heat means no cooling. Okay. And if this is outside means what? Continuously moving air, na? So whenever hot air throw means it will suck, it will replace with the fresh air, with the new air. It's like a source. Continuously we can reject the heat to outside because it's a moving air. Okay, so exposed wall is required to install this. Okay. So these are the disadvantages. Next, one more point, drain. Here you see, we already learned when the air passes through this evaporative coil, you'll get the cool and dry air. Cool and dry air means the condensation on the coil. Na? So the condensation on the coil means the water droplets. So this water droplet is collected at the bottom and reject with the drain point. So at the time of installation, slightly inclination towards the drain point so that the water can reject easily. And I think you know, from the windows you'll get the water. This water from the room air, not from the machine, not from the unit. Okay, so continuously condensation. So as per standard, 1 ton can extract 1.2 liters per hour as per standard. This dehumidification capacity. This is standard, but as per the requirement also we can design. Okay, so remember this point, dehumidification, water droplets on the coil. Okay, and why this water droplets? Because on the coil you can expect temperature less than equal to dew point temperature, right? Clear? So these are all about the window AC. So done for today's session. Tomorrow I'll continue with the split. Okay. Okay, so here you see why we are calling split means we have separate unit for indoor and separate for outdoor. For example, you see in this image, this unit is indoor and this unit is outdoor. And remember this indoor unit also known as FCU, fan coil unit. And this type of FCU which we can install on the wall, we can call as high wall. This is high wall. You know this type of, you'll find on the wall. So this FCU, only indoor unit, we can call FCU, and this type of FCU is high wall. And why we are calling FCU? FCU means fan coil unit. Inside you'll find the fan and coil. Which coil? Evaporative coil, because it's an indoor unit. And you see this indoor unit is connected with the pipe, copper pipe to the outdoor unit. So you know the four components: compressor, condenser, expansion, and evaporator. The four components now is divided into two units. One is a high side and second is a low side. High side means outdoor unit, low side means indoor unit. In high side means outdoor unit, you'll find compressor and condenser, and in indoor expansion and evaporator. Okay, with the fan motor, with the control, electrical control box, etc. Okay, but the major component is divided into two machine, and these two units is connected with the copper pipe. And with this copper pipe, one is liquid line and second is suction line. I'll explain this, don't worry. And the refrigerant will flow in this unit, or in this pipe. Okay, so concept is same. In window AC, all the components in one unit, so it's interconnected, so refrigerant is flowing. But here is four components divided into two machine, so we are connecting the lengthy copper pipe to flow the refrigerant. That's it, the major difference. We have some more options we'll discuss now. Let me play the video. In this video, first you'll find outdoor unit, then indoor unit. Mini split or split.
All previous processes feed into the mini split assembly line, where
You see this is a base of outdoor unit.
indoor and outdoor units are assembled and tested
Next,
before.
fan motor, and this fan motor to connect what, or to cool what, condenser. So this is condenser fan motor. You can call this a condenser fan motor.
Packing. Starting with the base
You know compressor,
condenser fan with support, compressor, condenser coil, and interconnecting.
you see this L shape is what, condenser. It can be L shape, it can be U shape, it can be round, depend as per the model. And you can find the fins also. So this is condenser. So compressor and condenser, the major components in outdoor unit.
Copper tubes and coil guards are added.
Can you find the valve? You see this valve made of a brass, and one valve is to supply the refrigerant from outdoor to indoor. One valve is for suction. Okay. But now you see the same refrigerant will flow out from the outdoor, and the same refrigerant will suck back by the outdoor. No? But why this difference in dia in valves? You see one valve is a smaller dia and another is a somewhat big in size, means dia. Why this difference? When the refrigerant is flowing out from the outdoor, what will be the state of refrigerant? Liquid or vapor? Liquid, because after condensation. After condensation, the refrigerant will come out. So the the state of refrigerant which is coming out from the outdoor is liquid state. Then it will supply to the indoor expansion, then evaporator, and change from liquid to vapor, and suction back to the outdoor is in vapor, right? So it means one is a liquid line and one is a gas line. Technically we used to call gas line as suction line. So remember, always suction line diameter is bigger than the liquid line. The smaller one is a liquid line, means outdoor to indoor direction of flow, and this is a bigger line means indoor to out. Why this difference? Because when the refrigerant changes phase from liquid to vapor, You know, whenever a substance change means phase from liquid to vapor, the volume increases, na? So for that reason, the diameter is bigger. So remember, and you can update this point in the notes also. After page number 25, you'll find the detailed drawing for split. I'm going to rotate this. I'll use as a landscape. So here, so you know, this is actually SPU is written, but you can update this as FCU, and the type is high wall. We have a separate topic for FCU and AHU. We'll discuss in detail. At present, remember, this is a high wall FCU, fan coil unit, and this is what CU means, condensing unit, outdoor unit. Okay. So you see indoor to outdoor, this pipe, which look like a single pipe. But if you see the section, and you see detail F is given in the left side in large view, you'll find pipe 1, pipe 2, and both the pipe with insulation, because insulation is required not to lose the energy. Okay, because the refrigerant is flowing means it may lose or it may gain the heat, na? Okay, so we require insulation on both the pipe. And all this pipe with the cable. Why cable is required? If electrical people give the supply to the outdoor, the indoor receive the supply from the outdoor. Or else if the electric, as per the model, if the electrical people give the supply to the indoor, the outdoor will receive the power from indoor. So this cable is your means this cable, this running a cable from indoor to outdoor comes under mechanical scope, but giving the supply to the unit comes under electrical. Okay, so you'll find this cable also. So this 2 pipe with insulation cable all will run with a 3-inch PVC conduit, just to protect that all this insulation, copper pipe, etc. as per standard. But in actual practice in India, you'll not find this PVC conduit. But as per standard, all pipes should run with the 3-inch PVC conduit or more than that as per the requirement. So here you see this is a bigger diameter, so you can write this as what? Suction line. And this is what? Liquid line. Suction line, and next is a liquid line. And you know the metal is copper most commonly. You know this brazing. Brazing and dehydration means vacuumizing, extracting the air from the heat exchangers, then refrigerant charging in compressor in gas state.
After brazing, units are pressurized for air leaks and dehydrated. Final assembly, including electrical control box and wiring, permits one last functional test prior to packaging and stocking in the finished goods warehouse.
Can you see the nameplate online? You get some more technical information from this nameplate. You see, first is the power, volt, phase and hertz, and here this will vary as per location also. So in India, mostly we're dealing with the 50 hertz, but in Saudi 60 hertz, in US also 60 hertz, in Dubai 50 hertz, Qatar also 50, depend. And this volts also will vary. In India, we are dealing with the 3-phase means 440 volts, but in Saudi 380 volts, and single phase 220, but in Saudi 110. So this power voltage definition, this will also vary as per location. And FLA is what? Full load ampere. An ampere is a unit of current. You see, all this unit belongs to electrical side, but ampere is current, volt is for voltage, and watt is for power, etc. So FLA is a full load ampere. This means when the machine is running at full load, how much current is required. It's not visible, but you can read here. 15. Is this visible? Next you see LRA. LRA is what? It's a locked rotor ampere. Locked rotor ampere means when the machine is off, the compressor is in lock state, na? Means in stationary. So when you switch on the compressor, we required some extra energy to start that. I'll give you a simple example. When you run a bicycle, when you start a bicycle, we required more force on first pedal. And when you start, then in the running, you can run easily. So similarly, LR is we can call as starting current. Starting current is more is required. And I think you can notice this whenever you switch on the refrigerator or AC, you'll find some fluctuation when you start, because starting current is more. When it start, then it will be normal. So usually starting current is 19.2. So LRA is more than FLA. Then HP is a power. Similarly, some more information which is given in the notes. Like you see all this point, you can find in page number 26. FLA, LRA, HS and LS. HS is a high side pressure, and high side pressure as per standard for split 270 to 300 psi. It may vary as per make also. LS low side is 150 to 170 psi. For additional information, generally this information will take care by the service people. But as an engineer dealing with the installation or design, you should have the basic of the service also. Types of compressor is also given. If you don't know this type, just find out in YouTube how this reciprocating works, how this this rotary scroll centrifugal. So as a mechanical, I think you know this. If you don't know, please type in YouTube and find out how this will work. Okay. So in present market, most commonly you'll find scroll and screw for split, for ductable split, even in chiller. But if the capacity is very high, then we can go for centrifugal. Okay. And reciprocating is, you see, reciprocating means moving parts are more and the efficiency is limited. So generally you'll not find this reciprocating compressor in commercial and residential equipments. But for industrial, still many in industrial application equipments you'll find reciprocatory. Why? Because the maintenance is easy if you use reciprocating compressor. Maintainability is easy. We can repair even on site also. So for that reason, you'll find reciprocating in industrial equipments, air conditioned equipments. Okay, next, one more important point, the length between the copper pipe. You see, suppose this is an indoor, somewhere here is outdoor. We require the copper pipe connection, indoor, outdoor. So generally, when you purchase this split unit, split machine, you'll get 3 boxes. One is for indoor, one is for outdoor, and one more box. In this, you'll find the copper pipe. So maximum manufacturer will provide 10 feet copper pipe with the machine. But if the distance between indoor and outdoor is more than 10 feet, we need to go for additional pipe. So generally up to maximum manufacturer is offering up to 30 feet limit. Going beyond that, then you must contact the manufacturer so that they can increase the capacity of compressor. Or else you'll not get the required cooling. Okay. So anyhow, when you purchase with the manufacturer catalog also, you'll get the maximum limit. And if the copper pipe increases, they need to go for additional refrigerant also. The service will go for additional refrigerant, and for that also some simple calculation by service people, and according to that, they will charge the refrigerant as per the length of the pipe. Okay, within 10 feet means directly there will no additional refrigerant is required. More than 10 feet, again simple calculation, based on that they can add. So these are some additional information related to the split. But I think you got the idea how this will work. And what we learn, you see, this is the first type in a split, that is high wall type. We have 2 more types in a split. And 2 more types means in the other 2 types, this indoor unit will change. But the mechanism is same. Technically, you see, this is high wall split. Second, we have a cassette type. And third, we have freestand or tower type. Technically, all are same, but the change in the shape of indoor and the indoor installation location also different, and with that we'll get some additional advantages. So that we'll discuss. But the mechanism is same: indoor, outdoor, same refrigerants flowing, same components, etc. But the shape is different. So this conclude the first type, high wall split. Okay, high wall split system. So what we learn. So generally the default split means the high wall. Generally, if I talk about the split system, means I'm talking about high wall type. Means with a high wall FCU. Okay, but in some condition or as per the interior, if this type is not applicable, we have other 2 options. Let me open the same. You see, the second type is cassette. You see, here is outdoor, indoor, and indoor is a ceiling suspended type, not wall type. High wall is a wall type, but this cassette is the ceiling suspended type. So how it will install? Anyhow, I'll play one small video clip. You will get the complete idea. So here you can find only the panel, and the remaining unit is above this one, this unit is above the false ceiling. So this type of unit we can also call as recess type units. But technically this indoor unit is a cassette type FCU. This because again this is FCU, but which type? Cassette. But the system is what? We are connecting to outdoor unit with a limited capacity. So this FCU, cassette type FCU, we are using to connect to the outdoor unit, and in that refrigerant is flowing. So the system is again split. Why I'm explaining this? Because this cassette unit is common for other systems also. Like this cassette FCU, we can connect with the VRF also. We have a topic. Even this cassette we can connect with the chill water system also. Okay. So at this level we are connecting to outdoor, and refrigerant flowing means this system is split and this unit is cassette FCU. Okay. So don't get confused. So this indoor unit is common for other systems also. Okay. But at present we are talking about split. And in this split, cassette type. So the advantage of this, for the first advantage is interior point of view, it's good. You see, if I go for the high wall, the box on the wall, na, but here you see the unit is above the false ceiling, only the panel is visible. So maximum time the interior demand this. In generally in conference room, in meeting room, or in manager's room, in high class areas, the interior asks for this cassette. Mainly the reason is as per the interior point of view, as per the client requirement. Okay, but it can be other reason also. Sometime you'll not get the clearance on the wall to install high wall. In that case also we can use this. So let me play the one video clip so you'll get the complete idea about this high wall type split. Before this, quickly the advantage and disadvantage of high wall, then we'll talk about cassette. You see, window is done. I split type high wall just now we did. We'll discuss cassette and freestand. Capacity for all this 0.75 to 3 TR in general. It may vary as per make and location. In general, for interview point of view. Next, you see the advantages of high wall type. No exposed wall is required. Like window, because outdoor we are placing completely outside. Na? Only we required to run the copper pipe through the wall or through the slab as per the clearance available, and we can connect to the indoor. So we can install the FCU, high wall type FCU, on any wall, even on partition wall also. Next, noise is less because the compressor is completely outside. Na? Look nice in interior. Compare with what? Compare with the window. The high wall interior point of view is good. But again, if you talk about high wall, the cassette will have more advantage. Okay. Next, low maintenance and low initial cost. Low initial cost again compare with the higher the central air conditioning system, not with the window. Compare with the window, the cost is more. But overall, the costing is limited. Okay, it's available with around 30,000 or up to 50,000, 1.5 to 2 TR with even 5-star rating. 55,000, 1.5 TR recently someone purchased. 55,000, 1.5 TR, 5-star rating. So as the rating increases, the cost also increases. 3-star rating around 33,000. Okay, general market, it may vary as per location also and as per the brand. If you go for Daikin, the costing is high. LG, Carrier also somewhat expensive. We can normal range is a Samsung, LG, etc. Okay, next. So back to the topic. Disadvantages. Ventilation is not as per ASHRAE or as per standard. Why? Because if you talk about this high wall here, the same air circulate. So let me complete this video quickly first. Then we'll talk about this what cassette. So I'll show you the circulation. So this is about the outdoor. Next, indoor. The indoor unit assembly starts with. You see, this is high wall indoor, and here's the base. And can you find the blower? Okay, this is a type of fan blower. And remember, if you talk about FCU, the blower will directly connect to the fan motor shaft.
The back panel, followed by the blower fan motor.
You see, this fan motor shaft is directly connected to the blower. No? So this is also one major difference between FCU and AHU. AHU will discuss later, but at that time, remember this, we'll discuss this point. Okay, FCUs are direct driven, AHUs are belt driven. At present, FCUs. Next, See, I'm mixing some points, so don't get confused. In the next future classes, we'll discuss about, we'll discuss about AHU and we'll compare with the FCU, etc. Next.
Evaporator coil, dehydrator.
Next, this is what evaporator coil, and somewhere on that side you'll find the expansion device also.
Electrical control box, wiring harness, functional testing.
And you see in this expansion, in this evaporator coil, in between you'll find the sensor also, return air temperature sensor, which will continuously monitor the return air temperature and control the compressor, like yesterday we discussed. Okay, so the mechanism is same for controlling the compressor, is same for all the units. Next.
And front panel fixing. It then moves to packaging.
You'll find the different models. So on screen in this model, you see point 1 to point 2 is what? Suction grill, return air grill. In some model, the suction from the top. In some model, when you switch on, you'll find some mechanism, the panel will push to front side to get some space for suction. So depend. So in this model, 1 to 2 is a return grill and 2 to 3 is supply. And at present, this outlet is off, means it's closed. When you switch on, the blade will open and it will swing if you switch on the swing option. So this is outlet and this is means this is supply and this is return, right? And you see supply return means within the room only, na? So is there any option for fresh air? No, so there is no option for fresh air in this. Okay, so if you want fresh air, you need to go with the separate unit that we can call FAHU, that we'll discuss later. So whenever suction take place, in the panel you'll find the filter, and you'll find the filter in the this window panel also. Normally plastic screens, because plastic screen is not a standard filter, but in Windows split you'll find generally plastic screens. If you talk about ductable, from ductable unit you'll find the standard fibrous filter. Okay, but at present this normal plastic screen. So filter, after that filter, cooling coil, and in the cooling coil you'll find the temperature sensor, which will continuously monitor the return air temperature. And return air temperature is responsible to control the unit. Then it will loses the heat, means when it pass through this evaporator coil, loses the heat and moisture and come out as cool and dry air. Same concept. Okay, but same air circulate, so there is no question of fresh air ventilation. Okay. Apart from this, one more important point, you see running cost is more compared than chiller. This point is common for all DX system, and after learning chiller we can compare. Next, skilled technician is required for installation on site. Window means is like a plug and play, but for split on site, installation of indoor, outdoor, then copper pipe brazing, then extracting the moisture and air from that pipes, then refrigerant releasing. So all this thing required a skilled technician. No doubt this also not a lengthy task, but means electrical or electrician or anyone cannot do this. It is a technician is required who know all this. Okay. Next, apart from this, one more important point, the drain pipe. So remember, so we discussed this two pipes, na? But you'll find one more pipe, and this point is important. May ask in interview. At present, we are talking about FCU. We have AHU also, that we'll discuss later. We have a separate topic in this chapter only. So if you talk about AHU or FCU, you'll find three pipes. Two pipes you already know. One is liquid line and second is suction line. The third pipe is drain pipe from the FCU and will not connect to the outdoor. Okay, so three pipes from the indoor, two pipe will connect to the outdoor copper pipe, and the third pipe is a drain pipe. You see here in this you'll find suction plus liquid line and with the PVC. So it's two pipes is looking like one only, but the third pipe is here, drain pipe, and drain pipe generally PVC pipe. Okay, and why drain pipe is required? Because when the machine is running on the evaporator coil, condensation of what? Room air moisture, this. So at the bottom the water will collect, and this water must reject, or else after some time what happens, the level increases and it will leak from the indoor unit, or else it may suck by the air and throw like air cooler, or the wall will damage. Okay, so you must drain this condensed water. So for that we require the third pipe called drain pipe. Okay, and the drain pipe you'll find in the detailed drawing also. You see this suction line, liquid line, and one more pipe which is going down. You see condenser drain pipe. Okay. But condenser drain pipe, when you're connecting, example, you can update in your notes, side view of the wall, and this is the floor level. And on the wall, generally above 6 feet, we'll install high wall. Suppose this is the indoor unit. So here liquid line, suction line, which will connect to outdoor, will not discuss because that is already there in the notes. But the third pipe here I'm taking from the right side. You can take from right side or left side or directly take out from the center through wall to out as per the option. But for example, I'm taking right side, and right side straight, and this is concealed in the wall. Wall concealed, not visible. We'll go for chipping like PVC pipe in the cable pipes, na? Like concealed. So this pipe we are taking straight down, then taking out. And remember, always this pipe level should be lower than that. The level should be lower than that unit. Why? Because generally, except few systems, except a few units, the drain of water with the gravity only. In some model, you will find the inbuilt pump also. That we'll discuss later with the split. But generally, high wall means without drain pump, the water will come out with the gravity. So this pipe level always with some inclination, with some slope, and with the lower level compared to the unit, so that the water can reject out. And this is what? This is PVC. Yes, Rahman, PVC drain pipe. So PVC drain pipe, and you see this drain pipe we can connect to where? Generally to the nearest toilet flow drain. Suppose here is somewhere is a toilet. Okay. So toilet door, and we'll take this pipe, and suppose here is a flow drain. Flow drain pata hai na? So we'll take this pipe, and will not connect directly here. We'll leave near to the flow drain. But one more important point to discuss, directly will not connect like this. Use a drain pipe. Sorry, we'll use a U-trap. Before connecting, we'll use a U-trap like this. And U-trap, I'll draw the detail here. U-trap is simple. A loop like this. This single line is a double line, and always water present in this. And this is called U-trap. So U-trap for what? To create water seal. Whenever pressure increases from this side, the water flow. And always some water will be available in this, and this will create a partition between this point 1 and 2. So there is no chances of suction of bad smell from that toilet or where you connect this pipe, and there is no chance of means even the insects also may travel, na? So there is no chance of insects also. If you not use this U-trap, what will happen? Here the fan is running inside. The fan may suck the bad smell, and that may affect to the quality of air. So U-trap is must. So when you are installing, you must take care of this U-trap. Okay. So you can write U-trap is used. Write the point. U-trap is used to create water seal. And this is not only for high wall. This is not only for high wall. For all the FCUs and AHUs, we require drain pipe with U-trap. Okay. Later when we talk about the AHUs also, we require the same PVC drain pipe with U-trap. So with this we did high wall. Let me play video for cassette. Cassette is simple. See, in this video you'll find the cassette type FCU with some additional advancement or some new options which is done by Daikin. So you just verify the new option, but at the same time follow the basic components. see, this middle one is a suction grill, return grill, and here 1, 2, 3, 4 is a supply outlet. In this model, even in the corner also, you will find the supply. So it's a round flow by Daikin. But generally with other manufacturer, you'll find four-way flow, not in the corner. So these are some new options. You see this picture is below false ceiling, right? You can find only the panel. And this is written, and these are 4 outlets. This is what? This is above false ceiling, right? Means this unit is above the false ceiling, recess type, concealed, which not visible. Only the panel is visible. Next, if you remove this cover, the middle one is the blower, right? And this is what the round shape is what? Which coil? Evaporative coil. The same. Only the shape is different. But the concept, the mechanism is same. So when you switch on this unit, the blower will suck the air from the center, from the room, and supply to side. And the air will come out through this cooling coil, loses the heat and moisture, and come out as cool and dry air from this outlet. Okay. And on this coil, condensation will take place. So at the bottom, you'll find the passage, drain tray. So the water will collect. But remember, this unit we are installing in the false ceiling. So we cannot take the PVC pipe below the false ceiling level. It's not allowed. Okay, because below the false ceiling, if you run the PVC pipe, means the client or the interior will not accept. So you must take the pipe above the level or with the same level of unit. So above the level or same level of unit, if you connect the drain pipe, will not drain with the gravity. So we require drain pump. So remember, in all cassette type FCU, you'll find the inbuilt drain pump. So to drain the condensed water, I'll show you. You'll find filter also here. You see copper pipe. Again, this will connect to the outer unit. The same, because this is a type of split. Split system. So you'll find the outer unit. Same concept. Only the shape of window is the FCU type is cassette. Next, quickly I'll jump to this flow drain. Sheet drain mechanism. The above is a cooling coil, below is a passage, means drain tray. The water will condense on this. Drain pump. You see, for this model, we can connect the pipe above 850 mm. This may vary as per the capacity or unit of the drain pump, and connect to the drain pipe. In this case, U-trap is not must, but if you add, that will add advantage. And if you find multiple units, you'll find the circuit of a drain pipe. Unit 1, unit 2, unit 3 all will connect to one pipe, and we can run one pipe to the flow drain or near the flow drain. Okay, so this is about cassette. Capacity is same like high wall, but installation is a ceiling suspended. So we have some advantages. What are those advantages? You'll find in the notes. You see, the first advantage is interior. Look nice in interior. And second is what? Uniform distribution of air. Because you see, we are installing, it's a ceiling suspended type, and it's like a diffuser. It will supply the air to 4 sides. Compared with the high wall, in high wall, the distribution of air is poor. Only one side flow. But here, uniform distribution of air. The remaining same as high wall. Next, with internal drain pump. One more advantage you can add here. Point number 4. Fresh air can be added. Means we can provide the ventilation. Fresh air can be added. Means, you see, this panel is below the false ceiling. The unit is above the false ceiling. Na? So above the false ceiling, we can run the fresh air duct and we can connect to the suction site. Okay. So here, you see, above the false ceiling, I can run, for example, this is a fresh air. I can run the fresh air and a branch I can connect to the suction side. So we can add the fresh air also. Disadvantage, the initial cost is high compared with the high wall. High wall means 25 to 40% max, and the remaining same as the high wall. Okay, next. You see application office, restaurant, showrooms, or big areas like halls. You can strike this auditoriums because generally not used in auditoriums because it's a double height. Please strike this. Big open areas we can use because in big open areas, if you go for high wall, it will not cover the middle area. Okay, so we can go for cassette for uniform distribution of air. Selection as per the client requirement. As per client means interior. Again, the interior requirement based on the client requirement, or as per site condition. Sometimes not get the clearance to install high wall. In that case, we can go for the cassette. Next, one more type we have, that is freestand, also known as floor stand or tower type. Freestand means, you can find the image here, and freestand means don't think that it's a single unit and we can move like air cooler. No, freestand we are calling because we can install anywhere on the floor. But once you install this indoor unit and this also FCU, this tower type FCU, again this will connect to the outdoor with the copper pipe, two copper pipe with the drain pipe. So once you install, we cannot move. Okay, so don't think that it can move freely. No, with the name. No, package is different. Okay, in pack, you see, in case of tower type FCU, you'll find only evaporator and what? Fan with the filter. Means evaporator means cooling coil, fan, filter, etc. You'll not find compressor and condenser. No? So you cannot compare this with the package. In package, we'll discuss. We have a topic. In package is like a window. All the components in one. That we'll discuss later. So this is a indoor unit again, and this indoor unit with the copper pipe will connect to the outdoor unit. Suction line, liquid line, and one drain pipe with the U-trap. Same mechanism. Only the shape of indoor is the floor, this tower type. Okay. So if sometime what happen, you'll not find the clearance on the wall. You'll not find even clearance on the false to install the this cassette on the false ceiling. I'll show you one image. In that case, we can use this, or else many times the interior demand as per their interior requirement. And remember, maximum time, if you're dealing with the split system, you need to follow the interior requirement because interior will decide complete interior design. So according to that, which type of unit will fit as per the requirement, as per the client requirement, which suits the interior requirement, which suits the type of space. So they will demand. Okay, so you must follow this. If technically not accept, then you can discuss with them. For example, they are asking for this cassette, but about the false ceiling, the clearance is very less. We cannot go for cassette. Minimum 1 feet is required, or at least 10 inches, so that we can install. If there is only 6 inches gap between the false ceiling and the slab, then we cannot run. We cannot go for cassette. Technically, it's not accepted. In that case, we can discuss, but initially follow the interior requirement. So sometime what happen, as per the site condition, here you see, in this case, in this image, you see the wall is covered with all interior LCD, etc. And false ceiling also with some designs. So there is no option for high wall. There is no option even for cassette. So the option is freestand. Or else, as per the arrangement of furniture layout, etc., the interior is demanding for this freestand. Depend. Okay, so in this freestand, suction from this side and supplies here. But if you talk about this, the suction from the front and supplies here. Depend. Okay, but the same cycle: suction, supply, cooling coil, filter, then condensation, this copper pipe connected to outdoor. options are same. Okay, the shape is different. So it can be installed after interior work also, because one opening is required to run the copper pipe. Okay, but in case of cassette, after interior means the false ceiling will damage. In case of high wall, the wall will damage. But here one opening is required just to run the copper pipe. It can be used without means false ceiling. Without false ceiling, we can if I go for cassette, it's not accepted. So we can go for this. Disadvantage: the cost is high because a big tall tower body. So the initial cost is more even than cassette. Then it will take capture some area in the floor. No? In some limited space, it is difficult. Selection as per client, as per site condition, or if you decide to go for air conditioning at the after completing the interior, then we can go suggest this one. So it will go for the minimum damage. This is a central air conditioning system, and in the central air conditioning system, the first option is ductable split. And ductable split is a bigger version of split, and this we'll discuss in the next session. Okay. Next we have ductable split. But before moving to ductable split, if you talk about window and split, both comes under unitary, means single AC, right? But if you talk about ductable or package or chill water system, VRF case is different. We'll discuss later. All comes under central air conditioning system, because window and split is unitary, means single ACs. But ductable, package and chillers comes under central air conditioning system. So first of all, we'll learn what is central air conditioning system. Any idea online class? Concept of central air conditioning system is the machine is placed somewhere in the building or somewhere in the floor, and we are supplying the air to different spaces by using the circuit called ducting. With the help of ducts, means air passages or air conveyors, metal boxes, we are supplying the air to different places or different means not places, different spaces in the floor or in the building. Means machine is centralized somewhere. But in case of unitary system, means number of spaces equal to number of units. But in case of central air conditioning system, unit is limited. It can be only one big unit or two unit will cover the complete floor as per the capacity by using the ducts. Okay, so this is the concept of central air conditioning system. But in this we have different types. So first let me start with ductable split air conditioning system. So already we talked about the split, right? So the bigger version of split is ductable split, right? So the first difference between the split and ductable split, here I can read, ductable machine can be considered as the bigger version of split. The first difference means the split system already we learn 0.75 to 3 TR, and it can increase up to 7 TR as per the location or make, but in general 0.75 to 3 TR. But in case of ductable, start from 3 TR up to 25 TR, or it can increase also as per the make and location, but in general 3 to 25 TR. So the first difference is the capacity. So we can consider the bigger version of split. And why we are considering bigger version of split? Because in this also we are dealing with two units. One is outdoor and one is indoor. And the second difference is with option to attach duct. So how exactly? I'll show you. So first of all, in this image, you see this is outdoor unit and this is the indoor unit. The indoor unit is not the wall type or ceiling type. This is concealed above the false ceiling and ceiling suspended, or it can be floor mounted in the AHU room, separate room. Okay, so I'll show you one image here. This unit is called AHU, air handling unit, because capacity is higher. FCU means up to 5 TR. Above 5 TR we are calling AHU. So this unit is AHU, and this unit, if you connect with the outdoor with the refrigerant system, we can call as ductable split, because this unit is common for chill water system even with VRF. So this AHU. So this AHU, if you're connecting with the outdoor unit and we are supplying the refrigerant with the same vapor compression cycle, so this system we can consider as ductable split. So split because of outdoor and indoor, And why we are calling ductable? Because here you'll find the open mouth and both this mouth for supply only. Suction from backside. Backside you'll find the filter, then the blower, then cooling coil, then the cool air will supply, or else first cooling coil then blower. We have a draw through and blow through configuration, we'll discuss later. So suction from backside and the cool air will supply from this mouth, and this with this mouth we can connect the duct. The duct can be round, the duct can be oval, the duct can be rectangle with a connector as per the requirement. At present in this image you can see the round duct, means we can connect the duct. So the first is higher capacity compared to split. The second option is we can connect the ducts, right? So what is duct? The duct which is used to convey the air or which is used to supply the air. But detail about the duct we'll discuss in module 2. At present, in order to learn this ductable system, I'm going to introduce this ducting. But for ducting, we have a separate module. In detail we'll discuss. Okay. So here we can attach the duct, and the third option is we can also provide the ventilation, means fresh air as per standard. So how to provide the fresh air? Here you can see this in this image. Suppose this is the exposed wall, and we can cut this exposed wall and we can add a piece of duct, design as per the requirement of fresh air. So for example, as per thumb rule, because fresh air will calculate at the time of load calculation with the standard, Ashtray standard 62 or 62.1 or carrier standard. We have list of standards we'll discuss at the time of load calculation. But at present, just to understand the concept of this ductable system, for example, fresh air I'm using say 30% of the total air, and remember this, or we can say 10 to 30%, and this 10 to 30% is as per thumb rule. So when you are using this fresh air 10 to 30% at the time of interview, you must add as per what? Thumb rule. As per thumb rule, not standard. We have a standard we'll discuss at the time of load calculation, but this is just as per thumb rule. So say 30% I'm introducing the fresh air by using this piece of duct, and this piece of duct is just bent down like this. Why? Because in case of rainwater, the water will not enter inside. So for that reason the piece is bent down, and that's the reason we are calling cowl piece, COWL. Cowl piece with bird net and VCD. Bird net means a mesh, because here you'll find the suction pressure, because when this unit, this is what AHU, air handling unit, and ceiling suspended type, right? It's going to be hang on the ceiling and above the false ceiling. This is what? This is the false ceiling level, and this is above the false ceiling, right? So this machine will suck the air, and here you'll find the filter. You can add this online in classroom. You can add here filter, and return air from this return diffusers, the return diffuser, the return air, and the fresh air. Both will suck by this machine, and this cooling coil, with the cooling coil, the temperature and moisture will leave on the coil, and this blower will supply the air to the duct. So a part of fresh air will introduce with this piece of duct, but coil because it is bent, and will design it as per the requirement of fresh air. So fresh air can be introduced in this. So this machine can provide the temperature, can maintain the RH, can maintain the noise, because outdoor is completely outdoor, and in the indoor also conceal above the false ceiling, and it's not must to place in the conditioned space. We can place away from the conditioned space, like in the pantry area, above the false ceiling or somewhere. So the noise point of view also is less, and we are using the ducts to supply the air uniformly, so motion and distribution. So this will satisfy the requirement of air conditioning. So it's fully approved by the standard society, because window and split will not provide the fresh air, and even distribution of air also not proper. But here in this ductable, it can provide the requirement, or it can satisfy the requirement of air conditioning. So this is fully approved by the standard society. So here for information, this AHU will have the connection, and this connection we can call, you can write FC, nothing but flexible connection. We'll discuss about flexible connection at the time of ducting. This flexible connection means a cloth between the duct and the unit to cut the vibration.
It's a canvas cloth. Then this is a connector. Then we'll run the duct, and this duct will have the branches before supplying the air to the air terminals. But branches is not visible here because at present we are not talking about the duct. We are talking about the ductable unit. That's the reason we are talking about little about the duct. But detail about the ducting, we have a separate module. So next, apart from this, this duct can run through this wall to, you can write, to other spaces. Here I'm writing this duct to other spaces. Why? Because this capacity is higher. This is not only for one space, it can be for multiple space. So this duct will run through the wall to the different spaces and supply the air, and the return air completely back from the space and sucked by the machine. So here the supply diffuser will supply the air and the return diffuser will suck. Say 70% is return, say 30% fresh air. So here 100%, but we are supplying 100%, but return is 70%. So you'll get the positive pressure. So there should be exhaust of 30%. So generally in case of residential or in case of office, at least in 1 hour, one time the door will open. So exhaust through the door. But in case of closed rooms, we require a separate exhaust duct also with a fan, so that how much we are taking the fresh air, that can be exhaust, right? So anyhow, that balancing of air we'll discuss at the time of ducting. At present, just you understand how this ductable system works. That's it. Even as I said, chapter 8 is related to chapter 5. At present, we are at chapter 5. So after learning this, after load calculation, we'll go for machine selection of what? Of the same system. So at that time, we'll discuss the technical part of this machine. At present, we are learning how the system works, the capacity, the arrangement, etc., the appearance. Okay. So online classroom, anything to discuss? Did you update this? AHU, FC. FC is important. Even the filter also important. And here, if you talk about this lines, you see the direction. The arrow is going up now. So this is what? From outdoor to indoor is liquid line, and return is what? This is suction line, nothing but gas line. Return back to the outdoor unit. And one more point is missing. The drain pipe is missing here. So I'm going to add the drain pipe, because drain pipe is required with what? With the U-trap. So you add here drain pipe. You can write PVC drain with what? With U-trap. Okay. So remember, FC or AHU, we require drain pipe to drain the condensed water from the room air. The water from the room air only, na? But don't worry, as I said, na, we have a separate topic about all these ducting air terminals in module 2. At present, just to understand the system, we are talking about this ducting, diffuser, etc. But we have types of air terminals, duct designing, etc. in module 2. Okay, and here the return air diffuser without any duct. So this is called free return. But in some cases you will find the return with the duct also, with the return air duct. Why when return air duct is required, when we are dealing with the free return, all this we'll discuss in module 2. At present, just learn how the system works. That's it. Yes, online.
Could you repeat the capacity of cassette type and shower type?
You see, for split, mini split, the capacity up to 3 TR for mini split. But for ductable split, start from 3 TR up to 25 TR in general. And it is higher also available with some brand in some location, but in general 3 to 25 TR. Okay, for ductable. And it's a ceiling suspended type and conceal, which is not visible in the conditioner space, so will not affect to the interior also. Okay, so we have some more theory to discuss in the next page. So here you see advantages. Ventilation is possible as per standard. If you are following ASHRAE or SIPSI, whatever, we can follow the ventilation standard. Next, central air conditioning system, and it is concealed type, will not affect to the interior. Means what? Concealed type? AHU. The indoor unit is concealed. Outdoor is outdoor only, but indoor also not visible. It's above the false ceiling. Okay. Next, low noise. Why? Because outdoor is outside and inside also above the false ceiling, and even inside the ducting we are using a lining called acoustic lining to reduce the noise. And how to deal with acoustic lining we'll discuss at the time of duct insulation. Next, uniform distribution with the help of ducts. So these are the advantages, and disadvantages same. Compared to chiller, the running cost is high. This disadvantage you'll find in all the system except chiller. So compared to chiller, the running cost is high. So still this point is pending, because after learning chiller only you can understand how this systems having more running cost compared to chiller. So after learning chiller, you'll get the idea. Don't worry. Next, capacity 3 to 25 TR. For example, as per Carrier brand, the range configuration is given 3 TR, 4 TR, 5, then 5.5, 11, sorry, 7.5, 8.5, 11 TR, and directly 17 TR is the maximum available in Carrier. But in Blue Star, it's available up to 22, in Daikin 25, etc. So depends. So in general, 3 to 25 TR. Okay. Next, application, restaurants, villas, hospital, and if you go to any supermarket in India, most commonly this system is used. In Gulf, most commonly we are using package. Similarly, in India, most commonly we are using this ductable. So if you go to any Reliance Fresh, Big Bazaar, D-Mart, or Reliance Digital, or Vishal Mega Mart, and this this brand factory, in all this area, you'll find the ductable split only. Ductable is most commonly used in India. For medium, even for big projects, and the people are big project means I'm not talking about high-rise building like Big Bazaar. Big Bazaar is a big area, not very big. Or else you can consider a small or medium type of project. We can use this ductable. So very commonly in India. Because the initial cost is less. Because in chill water system, the initial cost is high. So chill water system generally you use for big high-rise building or the big project like a laboratory or a hospital or a high-rise building, etc. We'll discuss at the end. Next requirement, hard copper pipe is required. Hard copper pipe means we have two types of copper pipe. One is soft run and second is hard run. Soft run means this is soft copper pipe. And if you want to, suppose we are taking the pipe straight, then if you want to turn to 90 degrees, so we have a tool called bender. With the bender we can press and it can bend to 90 degrees. We don't require a separate fitting in case of soft. So generally the soft copper is used for split, mini split with the limited capacity. But for ductable the capacity is higher now, so we cannot use this. We require the hard copper pipe like this. And for hard copper pipe, if you want to take 90 degrees turn, we require separate elbow or fittings like this. These are all fittings with the bracing on site. Okay, T, elbow, etc. Okay, so hard copper pipe because the capacity is higher. So soft copper pipe if you use, it will burst. So we require hard copper pipe for ductable split. So this is about the ductable split. Next we have package. Okay, just now we discussed about ductable split, and ductable split we consider as a bigger version of split, right? Similarly, the package you can consider as bigger version of window. Package means what? All the components in one unit. Even the window also we can say a small package, but we are not calling a small package. Window is window, but technically if you speak, the window also is small package, because in window you'll find all the components in one unit, na? So in package also same, but the capacity is higher. Here you see, it can be considered as the bigger version of window. In window you'll find compressor, condenser, expansion, evaporator in one unit only, right? Here in package also all these components in one unit, but it's a bigger version. Means capacity for window is up to 3 TR, but package start with 3 TR up to 125 TR, very big. Compared to ductable also it's big unit, but not compared with the chiller. Chiller is a 3500 TR one unit. That's very big for high-rise building. But compared to window split, ductable split, this package offer higher capacity up to 125 TR, and with the special order it can increase also. You see the right side is compressor and condenser, this unit, and the left side you'll find expansion, which is not visible, and here you can see the evaporative coil. The four components are same, but in two sections, but one unit. And here you will find supply duct to the area where we require the cool air, and from the other side you'll find the return. But how exactly? Here, this image will help you. So here you see this unit. Don't think that this duct is coming out from this side. This side is a compressor and condenser. This duct is connecting from this side. Okay, so the cool air through this duct will supply to the space and return from the same space back to the unit in this compartment, not this compartment. In this area you'll find compressor and condenser, and this area expansion in evaporator. So supply duct and return duct to this side only. Okay, don't think that it's connecting from right side, because here is a condenser fan to cool the condenser. Okay, so two sections, and the left side section with the evaporator will have the double skin. Double skin means one unit, case, two cases in between insulation, or we can say with insulation. This side with insulation. Why? Because this is placed outside now. So if you not provide the insulation for this side, the cooling will lose, right? But there is no insulation on the right section, because this is a compressor and condenser, right? So simple concept. We are using a single unit like a window, but the capacity is higher. So because I have higher capacity, this is not for a single space. This can be used for multiple space, and by using the ducts to supply the air to different areas. So it's because it's a higher capacity, right? So one more point to discuss. First, you see, it can be considered as bigger version of window, and is used for capacity beyond the capacity of window AC, right? Having option to attach the duct, with ventilation option. So how to provide the ventilation? This other image, package rooftop unit, working of package air conditioning system, or this unit. So that side you'll find compressor and condenser. It's not visible, but you can see the evaporator side on the top. This is supply duct, right? You see the supply duct, one branch is connected to ground floor also. This is supply. Okay, I'll mark this one. Not clearly visible, but you can understand what this is. Supply air duct. This also supply air duct. This supply duct is for first floor. This is for ground floor, right? The supply is going down now. So when this duct coming out, think that one branch parallelly going to ground floor, right? And this is return air duct. This is return air. This one, return air duct from the ground floor as well as return air from first floor. Back to what? Back again to the package. So at the time of return, what we can do the opening, and we can go for say 30% as per thumb rule. 30% I'm going to exhaust air, say 30%. Okay. And from here or in the duct, I can provide the fresh air 30%, because this unit is completely outside now. So easily we can provide the fresh air. But how much we are providing the fresh air? That much is going to exhaust to maintain the, say 30% exhaust. So I'll go for 30% exhaust, remaining 70% return, 30% exhaust, again the 100% supplied to these two floors. So we can provide the fresh air also, right? So first, it's a bigger version of window, because like window we have all the components in one unit. Second, the capacity is higher, means bigger version means the capacity is higher. And the second option is we can attach the duct, and the third option is we can provide the fresh air, right? And distribution point of view, noise point of view, we have advantage. There is no noise because the unit is completely outside, and air distribution is proper because we are using the ducts, and we can provide the fresh air. So this is also fully accepted by the standard societies, because this will provide this will satisfy the requirement of air conditioning. Yes.
Air operator and expansion side पे we have double skin.
Yes.
Double skin means we have to give the insulation to
All right.
so
For
that
example,
heat exchange cannot exist.
all right. You see, double skin is one cup cabinet, one more covering, in between insulation. Because here you'll find the evaporative coil, na? If you not provide with the insulation, the cooling will lose because this is placed outside completely. And even this duct, this supply duct, return duct also with insulation. Because this is also outside. Even as per standard, the duct which is running above the false ceiling also with insulation. We have a topic. I mean, module 2 we'll discuss about the duct insulation. Clear? Understand the system, how the system works. The technical points we'll discuss in machine selection after load calculation. Okay. Next. Theory. You see option to attach the duct and the available capacity is 3 to 125 TR and types of package. What we learned just now is air cooled. Why air cooled? Because the condenser, you see, the condenser is cooled by outside air. Na? So what we learn is air cooled. We have water cooled also, but not in all the mix. So we'll not discuss about this because this is not commonly used in market. Mostly package means air cooled. Okay. But for interview point of view, the difference is given. Air cooled package means the condensing unit is cooled by air. And the water cooled package, the condensing unit is cooled by water by using shell and tube. But don't worry, how this shell and tube and how this water cooled system at the time of learning water cooled chiller. After learning water cooled chiller, you can understand this water cooled package easily. So that's the reason let me hold this one. Anyhow, for package most commonly we are using air cooled. And the detail about the shell and tube condenser and how to cool the condenser by using water, we'll discuss in detail at the time of water cooled chiller. Because in chiller we have two options, air cooled as well as water cooled, which is used as per the project requirement. Okay. So for interview point of view, just go through this point. And as I said, double skin means with insulation at the evaporative site. Next, advantages, ventilation as per standard. It can be mounted on the rooftop of the building or any open space away from the building or backyard. We can place anywhere this machine. But from that point, we are connecting the duct to the conditioning space. So if unnecessary, if you increase the length of the duct, the fan capacity will increase. So try to decrease the length of the duct. Next, will not affect to the building elevation because this is placed on the rooftop or outside the building. Somewhere it will not affect to the building elevation like window. Next, the technician can work easily in case of breakdown because the unit is completely somewhere outside. They are not disturbing the internal inside space above the false ceiling. Next, the duct have acoustic lining to reduce noise. So what is acoustic lining? At present, just remember acoustic lining means acoustic related to sound, noise. Okay, so inside the duct we are using acoustic lining to reduce the noise because this with the higher capacity, so higher capacity fan, so it may create the noise because when the air blow in the duct. So we are using the acoustic lining, some lining inside the duct to extract the noise from the air. But how to deal with acoustic lining you'll find at the time of duct insulation in module 2. Okay. Next, disadvantages. High capacity fan is required because from where you are installing, from that point we are supplying the air to the conditioning space till the last terminal, like this. You see, this fan should supply the air till this point in the ground floor. So it required higher capacity fan, higher static pressure. But what is static pressure also we'll discuss. We have a separate topic for fan selection. We cannot learn all the things at a time. So that's the reason I'm just giving the reference of that options. We have a topic. Fan selection you'll find in module 3. Next. Outside ducts should be completely insulated. Insulation is required even as per standard. Inside duct also insulated with insulation. Next, high running cost. Why high running cost? Because of high fan operating cost. Running cost means energy, monthly bills, energy consumption. So running cost is high in this because in case of ductable, suppose for example for this ground floor and first floor, if you're using ductable, I'll use one indoor here, one outdoor outside. I'll use one indoor here outside.
one outdoor. So this indoor will use to supply the air from the indoor to the last terminal, and this indoor from here to the last terminal. So fan capacity is limited, na? But in case of package, this unit which is on the roof is used to supply the air till the last air terminal in the ground floor. So the fan capacity is higher. So because of higher fan capacity, the running cost also increases. So now if you compare ductable with a package, which is the best option? Ductable. Online. Compare ductable with package, which is the best option? Package and ductable. At this level, we cannot say ductable is best or package is best. Depend as per the site condition. As per the condition, as per the requirement. So at this level, don't do any conclusion. Simply learn. Don't think that package is best or ductable is best. For example, in commercial space. Commercial space is very limited and expensive. So suppose the client, or as per the interior, the false ceiling height is 9 feet or 10 feet, and the slab height is 12 feet. Above the false ceiling, only 2 feet clearance. For 2 feet clearance, the ductable indoor, suppose 15 TR capacity, it is difficult to install. In that case, package is the best option, because you don't have clearance to place the split ductable split indoor inside. In that case, we can go for ductable. Okay, or else if you have the space inside the building as well as outside, go for the ductable split. So depend as per the site condition, as per the interior requirement, as per the space available, as per the client requirement, as per the budget, lot of things. All these points we'll discuss at the time of machine selection. So at this level, don't do the conclusion, just learn. Okay, we'll decide which option is best as per the site condition. For one project, the ductable is the best option. In other project, the package will be the best, right? So we have multiple options. So after learning all this, then at the time of machine selection, as per the project requirement, we'll decide based on these conditions. These conditions also we'll discuss at the time of what? At the time of machine selection, chapter 8. Okay. Next, back to the topic. Some benefits, limitation, you can go through this. Some more comparison is given. Next we have very important topic, DX in chill water system and FC and AHU. DX in chill water is important for interview point of view, even FC and AHU topic. So both the topics are important. So first we'll talk about the difference between DX and chill water system. Till now we discuss window, split, ductable split, package. And we have one more option, VRF. So all the systems except chiller comes under DX. Means direct expansion, right? And chill water system is a separate chiller system. This chiller is a separate chill water system. So if you talk about the list of the system which is given in page number starting of the page number 24, here you see. So 1 to 5, you can see the flower bracket. Point 1 to 5 is what? DX system, and point number 6 is what? Chill water system. Right, if you can update this page number 24, take this system 1 to 5 and write DX system, and chiller is a chill water system. We'll discuss the difference between this system. What is the major difference between DX and chill water? Suppose if you recall window, in window you see the refrigerant in the evaporative coil directly used to cool the air. In case of split, ductable split or package, even in next VRF, the refrigerant in the evaporative coil is used to cool the air directly, right? So when the refrigerant directly used to cool the air with this evaporator, the system is called direct expansion system. In short, we are calling DX. So right from window to VRF, all the systems comes under DX. because directly refrigerant in the evaporative coil used to cool the air. That's it. But in case of chill water system, what we'll do first, the refrigerant is responsible to cool the water. Then the chill water we are using to cool the air. Means in between the refrigerant and the air, we are using water as a mediator or water as a secondary refrigerant in chill water system. So this is the major difference. But why? So you know about direct system already we discussed, except VRF we'll discuss now. But in case of chill water system, why we are doing this? Why we are using water as a secondary refrigerant? What advantage will get with this, and how this is possible? All this we'll discuss at the time of learning chillers in this chapter 5 only. But after learning FCU and AHU and VRF. Okay. But I think you got the difference in these two systems. Next, you can highlight this FCU and AHU. This is important for interview point of view. FC is what? Fan coil unit, and AHU is air handling unit. This is FCO and AHU, fan coil unit and air handling unit, and important at the time of interview and on-site also, because many architects for all the indoor machine they are calling AHU because they don't know the detailed difference between this unit. But as a mechanical, as a HVAC engineer, you must know this. And people have a lot of confusion. Even mechanical people also have confusion because both are, for example, take example of a scooter and a bike. Both comes under two-wheeler, na? But we have a difference. Scooter means the tires are small. The bike means the the wheel is bigger size. So we have a difference now, but both comes under two-wheeler category. Similarly, FC and AHU both belongs to air side unit. Both are air side unit. Both is used to cool, both is used to handle the air. But one is a small capacity, one is a higher capacity. Like this, we have a difference. We'll discuss now in this table. So here FCO, you can write a fan coil unit, AHU, air handling unit. First difference, step by step, we'll discuss this. First is capacity of AHU up to 2000 CFM. Nothing but in bracket you can write 5 TR because as per standard 1 TR equal to how many CFM? Quick. Yes. 400. Online. So 2000 CFM means how much TR? 5 TR. You can write in bracket 5 TR. But remember, this 1 TR equal to 400 CFM only for standard machine. At the time of calculation, it may vary also. It's not fixed all the time. As per standard condition, as for standard machine, as per ARI, we are using this 1 TR equal to 400 CFM. But in calculation, it may vary. We'll discuss that at the time of load calculation. Next, for AHU, the capacity is about 2000 CFM. About 2000, you can write up to 1 lakh CFM. You can update here. About 2000, up to 1 lakh CFM with a special order. Means 250 TR big AHU also available with a special order in market. Okay. Next, types of FCU. Decorative FCU. Decorative FCU means which is visible in the conditioning space. Any example of decorative FCU? Any example of decorative FCU? Cassette. Yes, good. One example. Any more? High wall, tower. These are all decorative, na? Which is visible in the conditioning space with the glossy finish panel. This high wall is visible. Cassette also partly visible. The tower also visible. So here decorative FCU means in bracket left side you can write high wall, cassette and freestand. These are all comes under decorative FCU. And you see, I'm not talking about split system. People have a lot of confusion in between split system and FCU. FCU is a part of split system. FCU, this decorative FCU is one unit of split. If you combine with the outer unit, then we can call split system. And remember, this FCU can be used for split, can be used for VRF, and can be used for chiller also. This is common for these three systems. So don't think that this cassette, freestand and high wall FCU is only a part of split system. It can be used for VRF system as well as for chill water system. So at present we are talking about FCU means only the unit which supply the air. Don't combine with the outdoor unit. Don't confuse. Okay, it's clear. We're not talking about split system. We are talking about only the FCU unit, which is common for different system. So first is decorative FCU. Next, decorative. Just now we got. What about concealed FCU?
in some project, the interior will not accept the decorate FCO. The interior is looking for conceal, which is not visible, like ceiling suspended AHU. The AHU is above the false ceiling. Na? Similarly, you'll find the conceal FCO. I'll show you this. Unit is conceal FCO without any glossy finish panel with the open mouth. But how to install this? First of all, you have a look. Then I'll show you how to install this. This will don't have any glossy finish panel, directly open mouth. And suction from backside like AHU. But capacity is limited, so we are not connecting with the ducting, just a connector with the grill. But how exactly? One. And here is the door of the hotel room entrance. Okay. And false ceiling. Suppose this is lower false ceiling, then upper false ceiling. Then you'll find the different level of false ceiling, the gypsum in the gypsum boards. So here we'll hang the unit like this. But small capacity and only a connector. This is not a duct, only a connector, and this connector directly attached with the grill, and we'll get the supply. And for return we'll add one grill here for return suction. And if you want, you can add the fresher also in this. So this is conceal FCO. But AHU means the capacity is big and we are running the ducts. But here conceal FCO, one room, one unit. Okay. Generally in hotel rooms you'll find this, because in hotel rooms interior they're looking for good interior. Okay. So as per the client or as per the interior requirement, you'll find or you can select this conceal FCO. Next, if you talk about AHU, here we have ceiling types of AHU, ceiling suspended AHU, already we discussed. Okay, once again, and this is ceiling suspended AHU, na? Only this unit. It can connect with the outdoor refrigerant system is ductable, or it can connect with the VRF system or chiller. As I said, this unit is common for 3 systems. Okay, so this is ceiling suspended AHU, and ceiling suspended AHU generally up to 15 TR in actual practice, but available up to 25 TR. You see, ceiling suspended up to 25 TR, but in actual practice, mostly we are preferring up to 15 TR. Okay, and above this capacity, we have floor mounted AHU. So in floor mounted, we have 2 types here, and in the point 2, you can add the sub options. I'm writing here A and B. This point sub option A is what? Single skin, and B is double skin. Single skin means you can write without insulation, indoor type. Single skin, in single skin you can write without insulation, indoor type. And for double skin you can write with insulation, outdoor type. Single skin means single cabinet, no insulation. Double skin means 2 cabinets with in between insulation, because we are placing outside. Suppose if the place is not available inside, we can place the unit outside with the redundant duct like package. But in package we have compressor and condenser also. But in AHU will not find compressor and condenser. This AHU will connect to the chill water system or the VRF or the ductable. But the case is same. So I'll show you the images, and it's a floor mounted means a higher capacity. You see about 25 TR. And up to 250 TR means 1 lakh CFM, right? 1 lakh CFM is 250 TR. So I'll show you some images for this AHU. First indoor type. Here you can see the indoor type. Image number mounted indoor type AHU. This is supply duct, and here return duct back to the machine. In between you'll find what? Same. Cooling coil, blower, filter, etc. This is indoor type. Similarly, you'll find the double skin outdoor type. Okay, so we'll discuss about the components, don't worry. First, let me show you the double skin outdoor type. Double skin outdoor type is, now you see, this is double skin type, AHU outdoor type. So we'll discuss the different components in the AHU, which is important as a HVAC engineer and even for interview. So I'll start from the first section. The first section is here. Here you see image number 00.
Yeah.
So the first section is here. This is mixing chamber. You see fresh air from here, and here you'll find the return air duct. At present it's not connected because it is outside. It will connect. So return air duct and supply duct to this site. I'll show you. So this is supply where you are supplying the air, means in the floor, because it's placed outside now. And return air duct connect to this. Return air duct and fresh air duct, this is mixing chamber. Fresh air and returner will mix. After that, this chamber is for filter. I'll show you. Then this chamber is for cooling coil. Refrigerant in, refrigerant out, or chill water in, chill water out. If it is a refrigerant DX system, is refrigerant in out. If it is a chill water system, chill water in out. The size, the model will be different, but the concept is same. Then finally, this chamber is for fan motor, blower casing, etc. Okay, so these are the different chambers of AHU. So step by step, I'll show you. So first mixing chamber, second in the second image. Can you see the filter? This is filter. After mixing chamber filter, then here you see chill water flow and chill water return. Means this AHU belongs to chill water system. Or else we can go for refrigerant AHU also. Refrigerant in, refrigerant out. Depend. If it is DX system, refrigerant. If it is chill water system, chill water. So both for both is common, but the medium of the fluid will change. Next, after that, after cooling coil, or else I'll show you the cooling coil image. You see this cooling coil with the fins also copper, tubes also copper, but most commonly copper tube, aluminum fins. But here copper tubes, copper fins, as per the area where you are using. If you are using with high humidity area, even the fins also copper. We'll discuss. Next, we have this fan motor. This belt pulley, and this is a blower casing inside blower. You know blower. Blower pata hai na? Already in the Zamir video. And here between this blower casing and the unit, this is canvas cloth, flexible connection to cut the vibration. And here you'll find the spring. This spring also to reduce the vibration from the fan motor. These are all isolators. This is isolator, spring isolator, and this is canvas cloth, nothing but flexible connection for each side. So now we have one more difference between AHU and FCU. At the time of Zamil video, we learn the fan motor is directly connected to the blower in case of FCU. So remember, in FCU, the fan motor directly connected to the shaft of the blower. But in case of AHU, with the belt and pulley mechanism, because capacity is higher, and on side we can increase or decrease the pulley size to increase or decrease the RPM of the blower to adjust the requirement. Because you know this, increasing the size of the pulley decrease the RPM na? N1 by N2 equal to D2 by D1. Increasing the dia will decrease the RPM. Pata hai na? Anyhow, this is for adjustment. So this is also one major difference. Here this is about the floor mounted AHU. So here in FCU, direct throw, no use of duct. Means direct driven. The motor is shaft connected to blower directly. But in case of in case of AHU, fan motor is directly connected to the blower, direct driven. Next, the blower is connected to the motor with the help of belt and pulley. In case of AHU, this is also one major difference. FCU, direct throw, no use of duct, because this is for limited capacity area na? Direct throw, like FCUs, decorative or concealed. But in case of AHU, we are using duct because this is higher capacity for multiple spaces. Next, FCU is generally smaller than AHU. Means you know this, space is small, and AHU is what? Is a bigger size unit. Then FCU is simple, and AHU is more complex. Means you will find the different options. And FCU basically recycle or recirculate the air. Means no fresh air. But in case of AHU, treat fresh air means treat outside air means fresh air. Next, FCU will not have any section for reheating or humidification, but AHU will have the option for heating coil, for humidification, etc. In the notes you'll find this. The image is given for detail. You see, in AHU you'll find the gap so that we can add the heating coil, we can add some additional option also in case of AHU. Okay, but in case of AHU we cannot do the modification. And finally, low noise in FCU and high noise in AHU. So for AHU we are using acoustic lining. So these are the major differences, and you must go through this. Important for interview as well as a HVAC engineer. You must know the difference between FC and AHU. To VRF, we'll start now. So VRF, yesterday we'll learn some basics. So let me read the theory first. So this is interesting, and yesterday I think we discussed the types. First is only cooling, second is heat pump, cooling plus heating, only one at a time. Third is recovery type, cooling plus heating, any simultaneously. These are the three models.
20 or 30 years, heat pump technology has continued to evolve. And today, homeowners can choose from a variety of systems that best fit their needs. The VRF, or Variable Refrigerant Flow Heat Pump, is a heating and cooling system that does not have ductwork as a component of the overall system. They serve as a great application for homes and living spaces where installing ductwork is not possible or desired. Commonly known as a mini-split heat pump or ductless heat pump, the VRF system uses a single outdoor condensing unit to connect with one or more indoor air handlers. Refrigerant is cycled through the lines from the outdoor condensing unit to the air handlers, where the heat or cool air is distributed. Typically, the indoor air handlers can be mounted on the wall or ceiling and come in a variety of styles. Each zone has its own thermostat, and when needed, multiple air handlers can be controlled as separate zones, providing the right amount of heat or conditioned air for that zone. In addition, both heating and cooling can occur at the same time. So if the bedrooms in the back of the house need cool air, while the front of the house requires heat, the system can handle it. As with other heat pumps, there are significant energy savings, but the VRF system provides some added efficiencies. There is minimal energy loss compared to 30 to 40% energy loss with traditional forced air systems that use ductwork in unconditioned places, such as attics. And, in most circumstances, VRF heat pumps do not require a backup heat source. Whether it's a new sunroom or retrofitting an entire house, if ductwork is not an option, a VRF heat pump is the perfect option. Smart energy. Smart choices.
And most commonly in India, cooling only. In Western countries, heat pump. In a special case, recovery as per the project requirement. Like generally in hotel projects, you'll find recovery as per the client customer requirement. They can go for heating or cooling. But recovery type you'll not find in all the projects. So what is exactly? And you know this VRV is patented by Daikin and VRF by other manufacturers. So only difference in this name, but publication point of view both are same. So VRF air conditioning system is a particular type of heat pump air conditioning system in which one outdoor unit can connect to multiple indoor units. One outdoor, multiple indoors. Each indoor unit is individually controlled by its user, and a variety of unit style can be mix and match. Means any type of indoor, means FCO or AHU, we can connect as per the requirement to suit the individual tendency requirement, means as per interior, like high wall cassette, ducted unit, etc. The system consists of number of AHU or FCO, you can add here, or FCO. You see possible up to 48, but now in market with the Daikin 60 numbers also model available as per the outdoor capacity. 44 is given in the notes. You can make this as 60 connected to the modular external condensing unit. So how exactly this work we'll discuss, but before this you must know how the system controls, and already we discussed at the starting of this chapter 5 how the unit control the temperature in the space. For example, if you talk about window or split, already we discussed how the temperature control by the system. For example, in this room, if I set 25 degrees centigrade with the window AC, how the window AC control the temperature by means of dash air. Very good. Return air. By means of return air. And when return air continuously monitor by the return air, temperature will continuously monitor by the temperature sensor. And if the return also same as per the requirement, say 25, then the sensor will give the thermostat, give signal to thermostat, and thermostat will switch off the compressor. But fan will run continuously. And after some time, if the temperature in the space increases, again the same sensor with the help of thermostat will switch on the compressor, right? This mechanism for all the system, even in VRF also. But in VRF we have one outdoor, multiple indoor. Na? Suppose in one outdoor higher capacity compressor, one compressor for example, it can be multiple compressor also. But at present to understand the concept, say 20 TR outdoor connected to multiple indoor. 20 TR outdoor with one compressor of 20 TR capacity, for example, connected to multiple indoor, and indoor capacity is, for example, all FCU of 2 TR. So 20 TR means 10 indoor we can connect. Na? 20 TR is outdoor capacity. An indoor requirement as per calculation, for example, each room 2 TR, say cassette. Remember, most commonly VRF, with the VRF outdoor we are using cassette FCU commonly. Why? Because we have advantage with the cassette, the uniform distribution of air, look nice in interior, as well as we can also add the fresh air. Very good. So, and you know the importance of fresh air. So most commonly in actual practice in market, VRF system means will connect with the cassette, say default. If the interior demands different, that case that we can consider as a special case. But most commonly cassette because of these advantages. So one outdoor of 20 TR capacity with the 10 indoor, say 2 TR capacity. It can be different also, just example. All connected with the one outdoor means one compressor. If you consider the same case like window, in one room, if the temperature is attained, the cassette FCU in the return, you'll find the sensor. Na? Again, this will sense the temperature if the same as set, what you set. For example, I set 22 degrees centigrade in this room. In return also 22. And if the thermostat, the sensor will, with sensor and thermostat, if provide the signal directly to the compressor, if the compressor is off, then it will affect to the other indoors, na? Because it's connected to multiple indoors. So how the controlling is done in this? So concept is same what I explained just now, but compressor will not switch off. The compressor will decrease the speed, because remember in VRF or VRV system, the compressor is, you see, inverter type, inverter control variable speed compressor. You can highlight this, inverter control variable speed compressor. And with what you can also highlight this VFD drive. This is important. VFD drive, variable frequency drive. So it means the outdoor compressor is a very inverter type, means it can increase or decrease the speed of the, means the compressor can increase or decrease the speed, and increasing or decreasing the speed means will change the capacity. Na? Change the capacity means changing the supply of refrigerant, not air. The compressor will supply the refrigerant. If the variation in the supply of refrigerant to the as per the indoor requirement, we can call VRF or VRV, variable refrigerant flow or variable refrigerant volume, right? Because the flow of refrigerant, flow if vary means volume also vary, na? So VRF or VRV, both are same, right? But how it is possible, we'll discuss. Here is building online. See, this is rooftop of the building, and on the rooftop you'll find number of outdoors, 1 2 3 4 5 6 7 8, and again here you see 1 2 3 means total almost 24 outdoors. So don't think that number of outdoor equal to number of indoor. Consider one outdoor for complete one floor with multiple indoors. Okay, because here is building na, so one outdoor will connect to multiple indoor of one floor. Like this, multiple floor, so multiple outdoors. Here, so it's a DX system, so you'll find copper piping. One is liquid line, one is suction line. In case only cooling model. In case of the heat pump or recovery, you'll find 3 pipes. So at present this is 2 pipe, but one more pipe will add. If 2 pipe only means it's a cooling model, or heat recovery or this heat pump means 3 pipes. You see one outdoor is connected to, you can notice here, these are all FCUs. What? Cassette type FCUs. Blue color represent cooling. Remember, in HVAC, blue or shade of blue represent cooling. Red or shade of red will consider as heating. So in this room, suppose it's a hotel project, in this room, cooling, another room, heating, hot, red color. So it means which model? Which model? VRF only. Which model? Recovery type. Because at the time cooling plus heating both. The third pipe is introduced because it's a recovery model. Now it will split. This is called rough net. REFNET. The name of this fitting. Rough net. Further we will discuss about this system. Not only this VRF, other system also at the time of machine selection. At this level, just we are learning how this system works. The concept. We are not dealing with selection. Selection you'll find in chapter 8 after load calculation. Okay. So at this level, just try to understand the concept, how the system works. This is called rough net, the name of the fitting. Here you see, the pipe is split into further pipes. Suppose this is 1 inch dia. And as per the indoor requirement, this will split. And further it will split as per the indoor capacity requirement. You see, further it's splitting as per the requirement. So this pipe sizing we'll learn at the time of machine selection in chapter 8 and connected to automatic expansion device. So remember, in VRF system, you'll find automatic expansion device. You know what is expansion, but here you'll find automatic expansion device. And in other system like Windows, split or ductable, the return temperature sensor with the thermostat directly control the compressor, right? But in this VRF, the return temperature sensor will control this automatic expansion device. How exactly you see? This is for heating. This is for cooling. You see, this automatic expansion device can open or close the. And this is connected to the room. This is connected to the indoor temperature sensor, right? So for example, in this room, if I set 23 degrees centigrade, and after some time 23 is attained, so return temperature sense that 23 na? And when it is same as what you set, the return temperature sensor will directly control this automatic expansion device, means it will close the supply of refrigerant, right? But in other cases, like window, split or ductable split or even package, it will directly close the switch of the compressor. But in this case, the return temperature sensor will control automatic expansion device, which is connected to the indoor or a set of indoor as per the requirement. At present, only one indoor. So when it is closed, what happened in the refrigerant line? The pressure increase or decrease? Pardon? Increases. देखो यहाँ refrigerant flowing ना, और यहाँ आप क्या करें, flow हो रहा तो उसको बंद कर दिया, हो रहा तो आप क्या करें, बंद कर दिया उसको. अच्छा, we are restricting this flow by using this automatic expansion device. So the pressure in the line will increase ना. Remember, the same sensor is also connected to the outdoor unit. In an outdoor unit, you will find a big control unit, control panel, like a CPU motherboard. CPU motherboard, na? Similar to this, you'll find a big control panel or control unit in the outdoor, and all this indoor sensor also connected to the outdoor control panel, and the indoor sensor also connect to this automatic expansion device. So when this is closed, the pressure in the line will increase, and one signal is given to the sensor will provide the signal to outdoor control unit. So what happened? Whenever pressure increases, the signal to the compressor with the outdoor control unit, and with a fraction of seconds, the compressor speed decreases. Why? Because we are using modular, this inverter type compressor. Inverter type compressor means the speed can vary. And with the VFD drive, what is VFD drive? We'll discuss next. So inverter types, the speed can vary. So automatically the speed decreases. Speed decrease means the refrigerant flow will decrease, and it can maintain the pressure in the line, right? After some time, the temperature in the room increases. So what happened? This valve will open, this expansion device, and again supply of refrigerant. Whenever supply of refrigerant means the pressure in the line decreases, again the control system, with the help of control system, the compressor speed will increase, and increase the supply of refrigerant or the flow of refrigerant or volume of refrigerant. So we can say VRF or VRV. Yes.
If the speed of the compressor decreases,
Mhm.
then it will affect in another room. In another room also it will affect.
You see, for example, 10 indoor is connected to one outdoor.
compressor, yeah. Okay.
Out of this, at present, 3 is working. So the compressor will supply the refrigerant to maintain only 3. Similarly, if you switch on the 4th one, so the pressure in the line decreases. Automatically, the compressor speed will increase and make up that 4th FCU. And like this, if I switch on 6, 7, 8, etc., it will increase.
So it will be according to the requirement.
Automatically as per the requirement, increase, switch on or off, or maintaining the temperature, after maintaining the temperature, or after some time if the expansion device open, automatically the speed of the compressor vary with the control system. This is not done manually. This is with the control unit and with a fraction of second, or else if the pressure if you not decrease the pressure in the line, the pipe may burst also. So this is done with the control system. So automatically with control system, the compressor speed vary and maintain the required flow to cover the required indoors. You see, from the distributor it is applying to different FCUs. We can make a set cooling or heating as per the requirement. So I think you got the idea how the system works, right? But we have some more points to discuss. Now, refrigerant flow is varied using either an inverter control variable speed compressor or multiple compressor of varying capacity in response to change in the cooling or heating requirement within the air-cooled space. A large building can have in order of 50 to 60 indoors, up to 60 is possible, and up to 1000 meter of refrigerant piping. Here some confusion, because you see 1000 means don't think that don't think that indoor to outdoor length, last indoor. I'm talking 1000 means the total pipe length, including the branches. How exactly? Because this is important, because the vertical height is up to 150 meters. So this is, you see, 1000 meter and 150 meter, we have big difference. So vertical length is 50 meters, sorry, 150 meters. But 1000 meter means what? 1000 meter means the total length. About outdoor, and suppose these are the floors, and the outdoor is on the top. So the vertical length, the outdoor to indoor, is limited to 150 meter high. This is also important. 3 meter मतलब कितना होगा? कितने floors को cover करेगा ये? Suppose each floor 12 feet. 12 feet मतलब कितना होगा in terms of meter? Divide by 3.28. So 3.65 meter one floor. For example, 12 feet I'm considering one floor. It can be 14, it can be 16 feet also. So 3.65. So 150 divided by 3.65. You see, up to 41 floors. It's very excellent option, because vertical line up to 150 meter. 1000 meter matlab it's going to be big. So don't confuse. This 1000 meter is the total length of the pipe including the branches. But vertical length is up to 150. A large building can have in order to 50 to 60 indoors, and up to 1000 meter of refrigerant piping can connect them to their outdoor units. The refrigerant pipe work will also be fitted with several control boxes to create the correct flow of refrigerant to the indoor unit. Means some controlling devices or distributors as per the requirement. Next, working principle. After working principle, we'll talk about this drives. Okay. So here, what I explained the same. The indoor temperature sensor, that means return a temperature sensor. According to the actual load of the indoor unit, means as per the room temperature, room requirement. Suppose if I set 23 degrees centigrade, if the 23 is attained, then you see, control the electronic expansion valve as per the video. The expansion valve will open and close on the refrigerant medium pipe of the indoor unit, and it's control the compressor means compressor speed of the outdoor unit according to the change in what? Refrigerant medium pressure. As per the pressure, automatically the compressor, control the compressor means you can write compressor speed here. Compressor also add speed in the nodes in bracket, or after compressor you can add the speed, and it control how it will control the speed according to the refrigerant medium pressure. You can highlight this point, refrigerant medium pressure, varying the refrigerant volume of the system. So in this way, the air condition can itself adjust automatically to meet the need of change in the indoor load, so as to attain the goal of conserving energy. Means, you see, in this system there is no wastage of energy. Suppose out of 10 indoor connected to 1 outdoor, at present I am using only 2 in the 2 spaces. Then the compressor will supply the refrigerant to cover only the 2 indoors as per the indoor capacity. And the compressor will consume the electrical energy according to that supply of refrigerant only. Means there is no wastage of energy in this system. So this is also one advantage. But how it can be done? If you understand this VFD drive, you can understand how the saving of energy, how this compressor save the energy or reduce the power consumption. So this is also important, this drives. And remember, next we'll talk about these drives. We have 3 options. Constant, you see I'm starting from here, constant frequency drive, then variable frequency drive, and variable speed drive. Remember, constant, this is important, constant frequency drive or any of this drive is common for what? Compressor, fan motor and pump. At the time of fan selection and pump selection also, this drives will help you, because this drive is not only for compressor, for fan selection, even for pump selection also we'll discuss this drives. So remember, this is important. You must understand about this drives clearly. So first is CFD, constant frequency drive. And remember, constant frequency drive may or may not be variable speed drive. One more time. You see, constant frequency drive may or may not be variable speed drive. I'll take example of this ceiling fan. All of you know ceiling fan. This is ceiling fan, no? This online ceiling fan, which we are using in our home, right? Following online. Ceiling, if you talk about ceiling fan, suppose if I switch on the ceiling fan at level 3, you can increase to level 5 also, no? You normally 5 levels or 5 speeds in ceiling fan, right? So this is what variable speed drive, right? The speed can vary. But this normal ceiling fan is what? Constant frequency drive. For example, this is interesting and important too. For example, ceiling fan level 1, level 2, level 3, level 4, level 5. Suppose at present I am running at level 3 and the power consumption says 60 watts. After some time, if I increase to level 5, what will be the power consumption? More than 60, less than 60, or same? Correct answer is this. Same. Why? Because you see, normal ceiling fan or table fan or air cooler, fan motor, normal, not high class, is a CFD drive, constant frequency drive. And remember, in constant frequency drive, as I said, constant frequency drive may or may not be variable speed drive. It can or it can be same. Like for example, exhaust fan, toilet exhaust fan, with the same speed, na? So constant frequency drive. And ceiling fan also constant frequency drive, but with variable speed drive. But whatever the speed, the power consumption is same. Even if level 5 also it is 60. In home, if you are running ceiling fan at level 5 or level 1, you are using the same energy. Don't think that if you use at low level you are saving the energy, because if you run at 5, the 60 watts will use. Level 3 means only part of power will use, remaining it will convert into heat in the resistor, in the regulator. Okay, so it will register in the registers in the regulators of energy. Okay, because it's a constant frequency drive. So normal fan, table fan, air cooler fan, exhaust fan, etc. are constant frequency drive. If change in speed means the waste of energy, but no change of energy means no change in speed means same energy. Okay, this is one option which is commonly used. But in case if you talk about VFD drive, variable frequency drive, remember VFD drive by default is VSD. You can write here VFD drive in bracket. By default it is variable speed drive. Means variable frequency drive, by default it is a variable speed drive. See, VFD by default it is VSD. Means CFD can be or cannot as this variable speed drive. But variable frequency drive by default it is variable speed drive. So in VRF system, the compressor what we are using is what? Inverter type. Inverter type means with VFD drive. And VFD drive means as the speed decreases, the power frequency also decreases. As the power frequency decreases, the power consumption decreases. For example, one outdoor is connected to multiple indoors, like 1, 2, 3, 4, like this 10, 20, whatever. Out of this, suppose only 3 indoors I'm using. So according to that, the compressor speed will decrease and the power consumption also will vary. Means inverter type compressor, nothing but with VFD drive, there is no wastage of energy. As per the requirement, that much power consumption. So that's the reason, you see, so as to attain the goal of conserving energy. So we can save the energy, or in other words, we can say no wastage of energy in this. And that's the reason this is becoming popular in market. Not only with this reason, we have other advantages also we'll discuss. Okay, so got the concept of VFD, and this concept not only for compressor, we'll use in fan motor and even at the time of pump selection. And fan motor means at the time of learning VAV system, VAV, variable air volume system we have. So don't confuse, VAV is different. VRF and VRF or VRV, both are same. But VAV is different. It's a air-side system. At that time, we'll talk about this fan motor with VFD drive. So don't confuse with all V. Even in pump also, we have primary pump and secondary pump. Primary pump is a constant frequency drive and secondary pump is a variable frequency drive at the time of pump selection. So this topic is important. Okay. About the capacity. Anything to discuss? But this is not the end. As I said, at present we are learning just the concept, how the system works. The selection we'll discuss in separate after load calculation. Next, capacity 40 TR to 30 TR as per Toshiba make, but this may vary as per make and location also. In general, we can take 50 TR, 50 TR plus also available in market. Next, advantages: no waste of energy, no wastage of energy as the speed change, frequency changes, the power frequency. Next, individual temperature control is possible as per you write space requirement, not zone. You add here space. For example, 10 rooms, 10 indoors. So individually we can on and off and increase or decrease the temperature. Na? So individual temperature control is possible as per space requirement. Next, low space requirement. You see, outdoor is only one. Saving of space in outside the building. Even for inside also, if you don't find limit this required clearance to run the ducts, we can go for cassettes. If the option is there for duct, we can go for ductable. If you want to go for multiple space as one zone, it depends. So saving of space, this also one big advantage with the VRF, because in commercial projects, space is one of the major consideration, and space is expensive. Many times you'll not find the space to place the machine inside, even above the false ceiling. You cannot go for even ductable split. We can go for package, but if the package size is also big compared to VRF, in that case we can go for the VRF option. So space point of view, it's a big advantage. Next, use HFC category. For example, 134A, or you can write most commonly now you will find 410A, 410A. You can write or 410A. Next, disadvantage. One disadvantage we have. In case of refrigerant leak from any of the indoor, the complete system will shut down. Okay, so that's the reason if you are working as a site engineer and dealing with the installation of this unit, you must be very careful. You must check for all connections for all the indoors, and there should be no leakage. Okay, because in leak of any one indoor unit will affect to the complete system. Okay. Next, second disadvantage, no fresher option except ductable or cassette. If you're using ductable AHU or FCU or cassette FCU, we can provide the fresher. In case if you use high wall or tower type AC, tower type FCU, you cannot add the fresher. Na? In that case, separate fresher is required. Okay. So this is all about the VRF. So today topic is very important, as I said yesterday. Today we are going to learn chillers. Compared to other system, this chiller offer maximum capacity, and this is for big projects like high-rise building or hospital or universities, etc. So what we'll do first, I'll show you images for air-cooled chiller. So first we'll complete air-cooled chiller. Then we'll talk about water-cooled chiller. So what we'll do with the images, we'll discuss about the installation of air-cooled chiller. And if I show the installation part of air-cooled chiller, you'll get the idea, the appearance of air-cooled chiller. Then we'll talk about the components in the chiller, the primary cycle within the chiller. Okay. And after that, we'll learn about the secondary cycle, chill water cycle. Okay, so this is important topic, so step by step we'll discuss. So first let me start with the basic theory, page number 35. First, basic theory. What is chiller? A chiller is a term used to describe complete chilling package that includes multiple compressors. You see, chiller offer higher capacity, so it includes multiple compressors. I'll show you this, don't worry. And multiple condensers, and expansion, and a single evaporator. And the evaporator type in air-cooled chiller or even in water-cooled chiller is shell and tube type. So what is shell and tube? We'll discuss in detail. Internal piping and other controls. A chiller is a machine that removes heat from a liquid via vapor compression. Already we learned vapor compression cycle, or as I said, we have one more cycle, vapor absorption. But most commonly, as I said, vapor compression. Vapor absorption also we'll discuss later. In this air conditioning system, the chill water from the chiller is distributed to heat exchanger or cooling coil in the AHU. Not only in AHU, in FCU also. So here you write in air handling unit, or in bracket you can write or FCU, because it can be AHU or it can be FCU. I think you know what is AHU and FCU. And the hot water is written back to the chiller. So this is just a basic theory. So what I'll do, first we'll discuss the installation part of air-cooled chiller. Why directly installation part? Because with the installation part you'll get the idea, the appearance of air-cooled chiller, and we'll talk about the components like multiple compressor, multiple condensers, etc. So here you see, yesterday we talked about AHU. And if you talk about floor mounted AHU, the floor mounted AHU is a big in size. No? Similarly, this chillers also is big in size. So if you talk about this big machines like floor mounted AHU and chillers, you must install this at the initial stage of project. Initial stage of project immediately after completion of structure work. And you know what is structure. Structural includes footings, beams, column and slab. So after completion of structure work, we will install this chiller if the project in your project, suppose if you are using chiller, so first we will install chiller and AHUs. Why? Because later you will not get the clearance to install this big machine. Suppose for example, so I'll show you the images first so that you'll get the idea why the installation of chillers and AHU, floor mounted AHU at the initial stage of project. Initial stage means I'm not talking about design, because at present I'm talking about installation. Installation means we are talking about contacting site. So here in this image you'll get the idea. First I'll show you how the air cool appear in actual practice. So image number 23 online, and this is air cooled chiller. And you see this big machine, if you install after the exterior of the building, it is difficult to handle. You will not get the clearance. Similarly, yesterday we talked about the big AHUs, floor mounted. Suppose think that this classroom is a AHU room, and in this AHU room I'm interested to install floor mounted AHU. So after structure work there is no walls now, so easily the crane can pick and install in this area. Suppose after completion of brickwork, then it is difficult, you will not get the clearance. So for that reason this machine is installed at the initial stage and covered with the plastic or any other option. And at the time of ducting or piping, we'll connect the ducting and piping to this machines or to these equipments. Okay, so we have some more important points before installing chiller. First requirement is you must wait for the structure. In this image, can you see the structure online? It's a G+1. It's a big mall, so area is more, but the building height is, the building floor is only G+1. So here structure work. So after completion of structure work only we can think for installing this. And second thing, you must construct this base. Which base? Here, concrete base. So here you see. So in order to construct, so who is going to construct this concrete base? Mechanical or civil?
Sure. Civil.
You see, this depends on the scope. No doubt the construction is done by the civil people only, but this may be this may be under mechanical scope or civil. If it is under mechanical scope means you need to hire some separate civil people and complete this task, or else if it is in civil scope you can coordinate with the civil people. But in order to construct this we require dimension of this base. So how to get the dimension of this base? From where we'll get the dimension of this base? Yes, very good. Shop drawing. You already learned shop drawing, chapter 2. Shop drawing, site execution drawing. So in shop drawing you'll find this dimension. So you must construct this. So now, and apart from this chiller is expensive. It is in lakhs or even in crores. And sometime we are placing order and available within the city or in country, within the country, or we can place order from other country also. It will take some time, it may take 6 months also in shipping and custom issues all. So you must order this initial stage of project. Anyhow, as a beginner you are not going to order, but if you are working as a senior mechanical engineer in this contracting company, then your responsibility to place the order. Okay. So anyhow, this must be at the early stage, so that as per the requirement the machine should be available on. And one more thing, this is very important. This is general information related to the decision, because you see, if you are working on site, take the decision, but before that what are the types of decision? So first is right decision. Second, you see, if I talk about right decision, the people will think the second type is wrong decision, but in between we have one more, that is easy decision. So after right decision, next you write easy decision, third you write wrong decision. So if you are working on site and if you are thinking for installation, means the chances of wrong decision is less. But most of the people, you see, first is right decision, second is easy decision, and third is wrong decision. wrong decision. So wrong means if you're working on site means you have the knowledge, so chances of taking wrong decision is less. But most of the people take easy decision. Easy decision means for example today schedule for installing the chiller. So easy decision means I'm thinking just installing the chiller. I'm not thinking after installation the piping can run, and for piping the clearance is there or not. And I'm not thinking for other services. I'm not thinking for clearance for other services. I'm not going to coordinate with other service. So if you not think for overall means you are taking easy decision. Easy decision means just temporary, just instantly. And on site, if you take easy decision, most of the time you'll find problem. For example, I'll give you a simple example. You see, as per the drawing, this is called shelling tube. The shelling tube in the drawing it is showing at left side, because later with the shelling tube we'll connect the chill water pipe. But what you did at the time of installation, this shelling tube you install on the other side. Instead of left side, the shelling tube is on the right side. So installation of chiller is done. But what happened? The piping which is going to connect from left side in the drawing, which is final, as per the site condition considering other services, it's difficult because the shelling tube is on the right side. And after installing this chiller, manually it is very difficult to rotate. And even if you find the problem at the end, till the time the plumbing tank and the other options, other equipment, other service equipment, if it is near to the chiller, even with the crane also we cannot rotate this. Okay, so it means that you are not thinking overall. Don't go for easy decision on site, because most of the people do this. First, they are thinking the present task, but you must think overall. You must read the drawing, and sometime error in the drawing also. Sometime error in the drawing. So you must go for planning at least one day before. If you are talking about these big machines, small machines, okay, we can reinstall, we can move, okay. In that also, if you go for right decision, that is recommended. But for big machines, you must go for the right decision. Easy decision will not help. Okay, so easy decision means quick decision and without considering the other options. So go for the right decision on site. Okay, so this will help you. And this right decision will take time. The right decision will require some additional planning, some additional time, but you will not find the problem with the coordination with the other service, and at the end you will not find the issues, because most of the time the problem you will find at the end, and at the end you will not get the time, and at the end you will not get the clearance also, because other services also installed. Na? So be careful, go for the right decision on site. Okay, so this is one basic some general theory. This will help you. Next, so you see the installation. So now I'll show you the sequence of installation of chiller. So first, as I said, the structure is required and the base. So think that the base is ready, the concrete base is ready, the structure also completed, and think that the chiller also deliver on site. Okay, so now we'll contact to this crane operators, and this kind of people we can call as other trade workers, because these people will not completely involved in the project. Na? They will complete the task, take that fee or the charges, and move to the other work. So this kind of people we can call as other trade workers. So you must coordinate with the crane people. So at present on screen, the crane is available on site. So first, if you show the location of chiller, where you want to install to these people, according to that, first they will set crane. So these images will help you. It is in sequence. So here you see, they are going to set the crane. If you closely observe here, the floor and the tire, there is a gap. Means with the hydraulics, at the time of working, the tires is not on the ground level. It is lifted. Why? Because to avoid accident in case of at the time of loading. Then here is the arm and hook. To this hook will tie the belts, nylon or any high strength belts, and you see the trolley of, so here you see, here you can see the belt in image 09. After that, 1 minute, let me confirm. Image 09. Then you see we'll tie this chiller to these belts, and slowly the engineer will coordinate to the technician, and technician will coordinate to the crane operators. Then with the coordination, slowly they will install on site. Here you can see, you see it is already lifted. So he is guiding to the technician. Then you see with the coordination the chiller is installed. The installation of chiller is done. And here you see, after installing the chiller, in between the chiller and the base you'll find spring isolators to reduce the vibration from the machine to the base. At present there is no spring isolator. Next you see in between the base and the chiller you find spring isolator. So at present you see there is no spring isolator because just now it is installed na? So I'll show you the spring isolator with the other machine. So this is spring isolator. So here with the rubber pad also, and there is no direct contact between this and this component. Okay, in between you'll find the spring. Okay, so this is spring isolator, and this is also required, and this is also important for interview point of view. And why we learn this installation part first, because with this you got the idea about the machine component. Okay, how the machine appear, this how the chiller appear. And at present we are talking about the air cooled chiller, right? Here you see. So why we did installation, because you'll get the idea about the appearance. So now we'll talk about the components inside the chiller. And inside the chiller the cycle is called primary cycle. Talk about the primary cycle, then we'll talk about the secondary, nothing but chill water cycle. So what are the components? At the starting we learn multiple compressor, multiple condenser, and a single evaporator. But evaporator type is shell and tube type. Shell and tube type. So I'll show you this one. First, here image 0, here 1, 2, 3. 3 cabinets here, and here 3 cabinets. Means total 6 compressors. At present this chiller is of 600 TR capacity. So total 6 compressors in this. Depends as per the manufacturer. It's not like that 600 TR means 6 compressor, means 100 TR 1 compressor. Depends, it may be 4 compressor of 1.150 TR. Depends. So at present multiple compressor, this 6 cabinets, multiple compressor, and this is electrical panel in between. And here you see this, can you see this fins here online? This fins. Inside you'll find the tubes. So this is condenser. So condenser 1, condenser 2, 3, 4, 5, 6, multiple condensers, multiple compressors, right? Then multiple condensers and expansion somewhere, small one, and a single shell and tube evaporator. So what is shell and tube evaporator? We'll discuss now. Here in image 0, chrome type cylinder is what? Shell and tube heat exchanger. You see at present, in general if you speak, this is shell and tube heat exchanger. But at present we are using this shell and tube for as a evaporator. Na? So this is shell and tube evaporator. This shell and tube can be used for condenser also, in water cooled chiller. Even the condenser also shell and tube. We'll discuss. Let me complete this air cooled first. Because the major difference between air cooled and water cooled is only at condensing side. The rest of the thing is same. So if I complete this air cooled chiller, then water cooled easily you can understand this water cooled easily. So tube. So first time we are talking about shell and tube. So I'll multiple condenser, and on the top you'll find condenser fan, right? Here you can call what? Condenser fans. Because remember, very important point, in air cooled chiller the condenser is cooled by means of air, by means of outside air, and in water cooled chiller the case is different.
And the major difference between air cooled and water cooled at condensing side, this is important. Anyhow, I will discuss this note in already given in your notes. So multiple compressor, multiple condenser, and a single shell and tube evaporator. So if I zoom here, see this is shell and tube heat exchanger. In general, this is shell and tube heat exchanger, but at present we are using for evaporator. So this we can call as shell and tube evaporator. So what I'll do, I'll show you some more images of shell and tube, then we'll discuss. Here the black color shell, you see this is a section of shell. So the outer is, the black outer is shell. Inside you'll find the tubes. So what happened, here you see, for example, as per this model, refrigerant in from left side in the tube and out from right side, as per this model. And if you talk about this image, in this chiller image, the refrigerant enter in from the top and flowing inside the tube and again come out from this, and water in with the yellow cap at the bottom in the shell and circulate on the coil, not in the coil, on the coil. It will means exchange the heat or reject, means the refrigerant will receive the heat and water loses the heat. And water will flow in this way, zigzag, and in the shell and come out as a chill water, and refrigerant here come out as a hot refrigerant. So in this case, in this model, water in from left and out from again from the side only. But in this image, you see water enter from the top in the shell, and you'll find the baffles, means the partitions. So water will flow up and down like this, and come out as the chill water. Okay, so in the shell, so depend on model. In some model the water in from side and out from side, in some model water in from front and out from the front right only, depend whatever. So in the shell the flow of water, in the tube the flow of refrigerant. So that's the reason it's called shell and tube heat exchanger. So at present we are using as a evaporator means. So I'll show you one more image. With that we'll discuss in detail. You see, in this model, the refrigerant here, refrigerant in means chilled refrigerant in, because evaporator means the refrigerant will supply after. If it is a evaporator, at present we are taking shell and tube evaporator, so the refrigerant will in after expansion. So refrigerant is chilled refrigerant, so chilled refrigerant is in and flowing in the tube. And what happened here, you'll find hot refrigerant out, okay, and in as what, liquid, and out as gas, you know this. So inside the tube, what, refrigerant, chill refrigerant, and here in the shell, here H2O means water in, but which water, cold water. Cold water means normal temperature, cold water in and flow on the, in the shell means, so it will flow on the coil. And as per second law of thermodynamics, the water is cold and refrigerant is chill. So heat transfer from high to low. So water heat is given to refrigerant. The same cycle way. The water heat is given to refrigerant, and refrigerant come out as hot in the gas form, and the water come out as 2O out. So the condition is chill, cold water in, chill water out, and chill refrigerant in, hot refrigerant in gas form out. Okay, and again this refrigerant by the compressor, the cycle completes. Okay, but where we are supplying the chill water, that we'll discuss, that is the next cycle. But at present, primary cycle means within the chiller. Within the chiller again, the refrigerant will come out as a gas and sucked by the compressor. The primary cycle completes. But how we are going to use chill water, we'll discuss. It's in the next cycle. Means that is secondary cycle. Okay. So in this image, water in from this bottom as cold water and out as a chill water. Okay. Same process. But how to use the chill water, we'll discuss now. Before this is primary cycle. So what we'll do, in your notes, find out page number 37. The line diagram is given. So here you see, in this chiller, this is primary cycle.
So what you do in this page for this drawing, you write this as what? Refrigerant or primary cycle. Refrigerant or primary cycle within the chiller. Multiple compressor, condensers also you can add like this. So this is the primary cycle. Now we'll talk about the secondary cycle. Okay. So the secondary cycle is what is here. This is both the pipe. You can write secondary or chill water cycle. Before dealing with this secondary or chill water pipe, I'll show you the images of secondary pipe. Okay. Anyhow, we have a separate module for chill water pipe designing, pump selection, fittings, accessories, etc. At present, simply we are learning how the chiller works. Okay. So I'll show you some images of secondary piping, then we'll talk about how the secondary piping works. In this chiller you see this pipe is secondary pipe, chill water pipe. So here image 3415. So these are number of chillers and this is completely chill water pipe. Within the chiller, primary cycle, and this pipe which is outside is secondary or chill water piping. Actually this is with insulation. So pipe designing, pipe insulation, fittings, accessories, pump selection, etc. all you'll find in module 3. So at present simply we are learning the concept of chiller. Okay. So don't worry about the pipe designing, we'll discuss later. Now with this idea, again go back to your line diagram. In this I'll add some points you can update. So you see here what happened, this is cold H2O in, right? Means in this pipe cold water in, say 60 degree Fahrenheit for example, standard. The range is 40 to 60 degree Fahrenheit in. So cold water in and circulate on the coil and come out as a chill water, na? So this in this pipe you'll find chill H2O out, say 50 degree Fahrenheit standard temperature for standard chiller. At the time of chill water piping also we are using this temperature. And you see inlet is 60, outlet is 50. So whatever delta T, 10 degree Fahrenheit. And this also standard for standard machine. So remember this, at the time of module 3 we'll use this information. For standard chiller only delta T is 10, but we have other options also. The range of delta T is 5 to 16, but standard is for standard chiller 10. Yaad rakhiye. Here I'll put point number 1. This is point 1. See this area same as ductable. Already we learned. So if for ductable line diagram in your notes, you can consider the same. Here detail is not added, return is not added, pressure is not, so directly given the same as ductable. So what we learn in ductable, the same you can consider. This ductable indoor we connected the outdoor, na? And supplying the refrigerant. But now we are not supplying the refrigerant, we are not connecting the outdoor, we connect with the chiller. Instead of chill refrigerant, we are supplying the chill water. So this side is same, right? And you see it can be FC also, but generally for chiller you write AHU. And here you see point number 1. So in secondary cycle the chill water start from the chiller with the chill water piping and supplied to the evaporator of AHU or FCU. Okay. So this I am writing point number 2. The outlet I am considering point number 3 of chiller, of AHU, and the inlet of chiller I am considering point number 4. Okay. So here I am writing the information of these points. Point 1, 2. Point 2 is what? CHW what? S. So in bracket, first you write 1 to 2 and hyphen CHWS, in bracket write chill water supply. CHWS means chill water supply. So chill water supply. And point 2 to 3, देखो यहाँ तक chill water यहाँ से start हो रहा, it is supplying to the evaporative coil of AHU or FCU.
you'll find the evaporator in the chiller, and this is shell and tube type, and one more evaporator in the AHU or FCO. That is normal coil type, coil and fins. So chill water in, and you see that when the chill water is flowing here, you know what happened. You'll find the blower, filter, etc. So the air suck and filter and touches to the cool chill water coil and come out as a cool air, and the water receive the heat from the air and come out as increase in temperature. So the water is not so hot, or it is not in gas, so we are not calling hot water return, we are calling chill water return only. Okay, so 0.3 to 0.4 0.3 to 0.4 is CHWR. You can write chilled water return. And at present on screen the chiller is connected to only one AHU, just for learning, but in actual practice this pipe will continue and can connect to multiple FCUs and AHUs in the building as per the capacity of chiller, and as per the complete circuit route, the total length of pipes considering all will go for selecting this pump as per the capacity required. So don't think that the chiller is connected to only one AHU. It can connect to multiple FCUs and AHUs as per the requirement and as per the capacity, and based on the total length, total pressure drop will select the pump. And we have a separate topic for pump selection, and this pump you can write chill water pump. And this pump at present you can write primary. And what is primary and secondary we'll discuss at the time of selecting, at the time of pump selection. At present just we are learning how the chiller system works. So we have a detailed topic about pump selection. So at present it's a chill water pump primary. What is secondary we'll discuss later. So you see the water suck again supply. The cycle continues. This way we are supplying the chill water. So we talk about the difference between DX and chill water system. In DX system directly refrigerant is responsible to cool the air, but in chill water system the refrigerant is responsible to cool the water and the water is responsible to cool the air. This is about the chill water the secondary cycle, nothing but chill water cycle, right? You can write anyhow. We have a separate topic for pipe insulation, so you write insulation. One point we discussed from the starting of chapter 5, right from window to VRF. Running cost of this window split ductable is higher than chiller, right? We learn repeatedly for all them. So now we can discuss why the running cost is less in chiller compared to other system. One question to all. You see, because of this using water as a secondary refrigerant, or with this chill water cycle, the running cost will decrease 60 to 70%. But how? Any idea? Online or classroom? DX system. So the reason is here. You see, in other machines directly refrigerant we are supplying to the indoor, and you see, and in this chill water system we are supplying the water. So if you compare refrigerant with water, for refrigerant it changes phase from gas to liquid and liquid to gas, and for refrigerant we require compression, and for refrigerant we require compressor for compression, and for water the water remain water only in the cycle, right? And there is no change of phase and there is no compression. So water required only circulation, but refrigerant required compression. And again the compression capacity, this high compression capacity is required to compress the refrigerant compared with the circulation of water. For example, if I supply the refrigerant from the chiller to from this unit to the indoor, suppose my requirement is 10 HP compressor. Directly I am supplying the refrigerant from outdoor to indoor. But in case if I use water to circulate, I may require 3 to 4 HP pump only. So you see, 10 HP compared with the 4 HP pump, the running cost decreases almost 60%. Main reason. So because water we are circulating, we are not compressing the water, but refrigerant we require compression. And again we have a density difference of refrigerant, the property of refrigerant is different, but water remain water only the cycle, the water will not change the phase. So water we are doing circulation. For circulation less pump capacity is required compared to the compression of refrigerant. So because of this reason, the refrigerant, this chilled water system running cost is less compared to
the DX system. But no doubt the initial cost is high. The initial cost is almost double or more than that. But this is mostly this chiller is for big project. Big project means the client can bear that cost. But monthly bills are reducing now. And with the reduction in monthly bill, we can get the payback period. For example, system say for example 5 crores. Chill water system say 7 crores or 10 crores. Okay. And yearly saving with the chill water system, say suppose chiller cost say 1 crore. Okay. And DX system, this is 1 crore for chiller. And DX system say 70 lakhs. This is for DX system. Okay. For the same capacity, initial cost. But in chiller, suppose yearly saving with the chiller compared to DX system is almost 60% na? Or 60 plus. So yearly saving say 10 lakhs in energy, because 60% reduction in the monthly bill compared to DX. So yearly saving say 10 lakhs. So this 70 lakhs and 1 crore. So 30 lakhs is extra for the chiller na? And this 30 lakhs will cover in how many years? 3 years. So this 3 years we can call as payback period. So after this payback period, and minimum life of the chiller is not less than 10 years. So 3 years we are getting the payback now. How much extra is recovering? So for minimum next 7 years, the saving of 10 lakhs means 70 lakhs of saving. If you consider minimum also, the chiller life is more than 10 years, but minimum if I consider 10 years. Okay. So initial cost is high, but running cost is less. But only this payback period will, you see, for example, the life of the chiller is 7 years. And the payback period is the life of the chiller is 10 years and the payback period is 7 years. In that case, it is not considerable. Okay? Because again, maintenance and all will increase. So, chiller we are using where the usage is high for big project. And if the usage is high means saving also high. Right? And the payback period will reduce. And you will get the overall saving in running cost. So that's the reason for big projects, for like high-rise building, or campus, universities, airports, etc. You'll find the chillers. Okay. Because if the usage is limited means the monthly bill saving also less and the payback is going to increase and maybe equal to the life of the system. Then no use. Okay, so you must think for overall, not just initial or running cost. Okay. So this is about air-cooled chiller. But we have some more points to discuss. Can I raise this? Pipe, na? The material for this pipe is MS or BS, black steel, mild steel or black steel of schedule 40. Just make a note, this schedule 40 is a class of pipe. We'll discuss at the time of module 3. At present, just for information. So the metal for this chill water pipe is black steel or mild steel of schedule 40. Schedule refers to the class of the pipe. We'll discuss in module 3. To raise this. So we have some more important points to discuss about air cooled. Here, this is interview point of view. You see, air cooled chiller, what I explained, you can read this, the mechanism, because, but before this, page number 35, we have some important note. Here you see, and this is interview question. The first interview question is related to chiller. You do one thing, make a list of interview questions for chiller because this topic is important. In your notes or in your diary, please make a note of important chill water system questions. The first question is, what is chill water system? Second question, draw chill water cycle and explain. Draw chill water cycle and explain. Third question you can write, types of chillers. If the question is type of chiller means, by default, they are asking as per the type of condenser. Yeah, water, air cooled and water cooled. They ask type of chiller means they are asking as per the condenser only. If they mention types of chiller as per compressor means that question is different. As per the compressor means we have reciprocating compressor, air cooled chiller, then scroll compressor, list of compressor. As a mechanical, I think you know types of compressor. Anyhow, the list is given. In interview, if they ask type of chiller means they are talking as per the condenser, not as per the compressor. Compressor means they will mention. So here, very important point. So types of chiller is air cooled and water cooled as per the condenser. The next question you can write that they will ask the difference between air cooled and water cooled chiller. This is important question. So types of chiller is air cooled and water cooled. Next question, difference between air cooled and water cooled chiller. So many people do mistake at this in this question. If they ask difference between air cooled and water cooled, means they said in air cooled air is used, in water cooled water is used, with the common sense. But always common sense will not help. So the major difference between air cooled and water cooled is, here you see, in air cooled chiller the condensing unit, you must add the condensing unit because the major difference only at condensing side. Okay? So in air cooled chiller the condensing unit is cooled by atmospheric air by means of condenser fan. This point already you know na? Already we learn about air cooled chiller and you know the condenser is cooled by air. Right online? So you must, because in air cooled or water cooled chiller, in both you will find chill water cycle. And after learning also people have confusion. In air cooled they think that air is flowing in the pipe or something. In water cooled water is flowing. No. In air cooled chiller or in water cooled chiller, in both you will find chill water cycle. The difference only at the condensing side. In air cooled chiller condensing unit is cooled by air. You know this. But in water cooled chiller the condensing unit is cooled by water and the water is cooled by means of cooling tower. This we'll discuss. After this, let me complete the air cooled chiller. So the major difference only at condensing side na? Right, so this is important question. Okay. The next question, application of air cooled chiller. So now we'll discuss. Application is given in your notes. Find out page number 36 and highlight this application. This is important. So here you see the application. Air cooled chiller are most commonly used for high-rise building. Why high-rise building? Because the reason also given, you see, as the chiller are placed on the rooftop of the high-rise building, because at high altitudes means high height, the wind velocity also high. An air-cooled chiller cool the condenser by means of air, na? And on the height you'll find the higher wind velocity. So whenever the hot air rejects from the condenser, it will replace with a new cool air. So you can expect the efficiency in condensation. And efficiency in condensation, you can expect the efficiency in cooling. So here you see the wind velocity also high. This can pick up the heat of the condensing unit quick. So it not mean that this air cooled chiller is banned on low rise building. It's not like that, but recommended on the high rise building. And you see in Gulf, even for low rise building, find air cooled chiller. Why? Because for water cooled chiller we require continuous supply of potable water. So in Gulf, scarcity of potable water, the water which is safe for drinking or cooking or taking bath is potable water. Means normal water, no, not hard water, means soft water. So the scarcity of salt water in Gulf, again the water is available, the Arabian Sea is connected, but that is hard water. If you use that will corrode the metal within no time. So because of scarcity of water in Gulf, even for low rise building you will find air cooled chiller. Right? But recommended air cooled chiller is not high rise building. But if you don't have option for water cooled chiller, the scarcity of water, because continuous supply of water is required for water cooled chiller. So we'll discuss in the next water cooled chiller. So even for low rise building you will find air cooled. This application also important for interview point of view. Next we'll talk about water cooled chiller. Here first I'll show you the image how the water cooled chiller in actual practice. Then with the line diagram we'll discuss. So here you see in your notes the appearance of water cooled chiller, or else I'll show you some more images. Here you see this is water cooled chiller. It looks like a complicated machine, right? Air cooled chiller is a cabinet. In there you'll find the components, but water cooled chiller is like a robust or a complicated machine. Show you one more image with the piping connected, with the connected piping. Here this complete means present this water cooled. This is water cooled chiller, and water cooled chiller also connected to cooling tower. So cooling tower we are placing outside. Why the need of cooling tower we'll discuss, but at present cooling tower is placed outside, we cannot place inside. But this complete water cooled chiller, complete means this unit. So this water cooled chiller we can place inside the building.
air cooled we cannot place inside the building. It must be outside only. Okay, because of rejection of or because of condensation by using outside air. But this air water cooled chiller completely inside the inside the building, and this area we can call plant room or machine room. Yes, plant room, or it may be any floor. As per the approval by architect or interior or client, means inside the building. Okay. So here and this area we can call plant room or this machine. So here in this chiller you'll find two shell and tube, right? You see multiple compressor 1 and 2 with a high capacity. So multiple compressor, but even the condenser also shell and tube. So can you find out the two shell and tube on screen online? One is black color and one is gray color. Two shell and tube na? Now, can you identify which is condenser and which is evaporator? Or else I'll ask the question. Can you identify the evaporator in this two? Online people can click on evaporator. The correct answer is black. Because you see, evaporator means inside you will find the cooling na. So black means this is with insulation. First reason, this is with insulation. So you say evaporator. And second reason, you see, after compressor the pipe is connected to this shell and tube. So this is condenser na, because after compression the refrigerant will supply to condenser. तो यहाँ देखो compressor के बाद ये pipe कहाँ जा रहा, इसको जा रहा ना, तो ये condenser रहा, तो ये evaporator. So this is so two shell and tube, one is condenser, the below is condenser and above is evaporator. And evaporator, you see, the pipe is connected, cold water in, chill water out. And where we are supplying the chill water, you know, right, in the AHU. So this cycle is same as air cooled chiller. So in air cooled chiller we are getting the chill water, in water cooled chiller also we are getting the chill water. So don't confuse. The difference is in air cooled chiller the condenser we cool with the air, outside air. Now in water cooled chiller you see the condenser is shell and tube. The green color is a new circuit. This is hot water circuit or condenser circuit. So in this condenser circuit, below the cold water in, and in the condenser refrigerant is hot state na? So the heat of the refrigerant will absorbed by the water. So cold water in and hot water out, and refrigerant in as gas with high temperature and out as liquid, right? So what we are doing, we are cooling the condenser with the water. So that's the reason it's a water cooled chiller. So cold water in and hot water out. Again, in order to use that water again, you must cool the water. So that water we can cool by using a cooling tower, the one with one more cycle. So this green color cycle is condenser or this hot water cycle, or at present condenser cycle. So condenser cycle also will have the pump and connected to the cooling tower. So cooling tower, I'll show you the cooling tower now. Red color pipes. See, this equipment is cooling tower. The hot water is supplying from the top, you see, here and here, and it will supply in a sprinkler form. Here the fins, so it will supply in the sprinkler form, and when this fan operates, this fan will suck the air from this fins. So this fan is used to take the hot vapor from the water out, because with the air the hot vapor also collected and throw out. So what we are doing, we are throwing the hot vapor from the water na? And when the air passes through this water, the air also takes the heat from the water, evaporative cooling, and at the bottom you will get the collection of cool water, and that cool water again we are supplying to the shell and tube condenser to cool the condenser. Fine. So here you see one more image. This is hot water in from the condenser, means from the water cooled condenser, supply in the sprinkler form. And this fan will operate and it will suck the air from here, and in between it will take the hot vapor and also cool the water. So the cool water collected at the bottom, and this water will supply back to the shell and tube condenser, right? Following online? So the same thing we'll discuss with the line diagram from your notes. And you see find out page number 38. In page number 38, you see what I did when I prepared the line diagram of air cooled chiller in AutoCAD. Same drawing I modified to water cooled chiller.
So that's the reason again this chiller is like a cabinet. But in actual practice, the appearance you know, which is given above. So don't confuse with this. Actually, I modify the same drawing to water cooled chiller in CAD. So this will look like a cabinet, but there is no fans there. So but two shell and tube. So the actual appearance is above. So here this two shell and tube. So if I draw the line here, partition line, this side is 100% same as air cooled chiller. So chill water cycle. And inside the chiller also primary cycle is same, but the new thing is shell and tube condenser also shell and tube. So the new circuit is what? Here you can write condenser cycle. And here in this, what cold? H2O in, right? And here hot H2O out. Hot H2O out, right? And the water is responsible to cool the refrigerant, means condenser. So it's a water cooled chiller. Again, the hot water is supplying to the cooling tower in the sprinkler form, and the air will suck with these passages. And here is the fan this cooling tower fan, and it will continuously separate the hot vapor from the water, and the cool water collected at the bottom. And the cool water again supplied to the shell and tube condenser. And you see continuously we are taking the hot vapor out. So the level of water will decrease. It will also connect to the makeup water tank. So that's the reason I said for water cooled chiller we require continuous supply of water. In case of scarcity of water, we cannot go for water cooled chiller. Even for low rise building we can go for high rise we can go for air cooled chiller like in Gulf. Okay, next. So we'll talk about the application of water cooled chiller. Then in next class we'll do the comparison of air cooled and water cooled. Okay, and after comparison we'll start the designing in next class only. So let me complete the application. So application also important again in water cooled chiller, page number 30 39 I think. Yeah, no, 39 30 38 only. Sorry, 37. What application of water cooled chiller? So 37 application of water cooled chiller, highlight this. An application of water cooled chiller is low rise building, and the best example for water cooled chiller is airports, because airport cannot be high rise, or near the airport also they will not give the permission for high rise building. So the best example of water cooled chiller application is airports or campus. University is also not high rise building. Even hospital also as per standard not high rise. Campus, this laboratories, industries also not high rise. So these are few examples for water cooled chiller application. Okay. Malls we can, okay, as per the height of the building. We can take air cool or water cool, but it's not strictly low rise means water cooled, high rise means air cooled. We have other points to discuss. We'll do the comparison. In the comparison we have some more points to discuss. So we cannot say air cool is best or water cool is best. That depends on cost, that depends on outside ambient maximum temperature, that depends on the part load or the full load usage. That also depends on type of compressor, then maintenance. We have list of points to discuss. Then if number of points suits as per the site condition or requirement, in that case we can say that particular system is best for this project. Okay, so that depends on other parameter also. Okay, but if you compare air cool and water cool only as equipment, not considering the site condition. Okay, I'm comparing just air cool and water cool as a equipment or as a machine. I'm not considering the site condition. In that case, water cooled chiller efficiency is higher. But why this point also, this reason also we'll discuss in next class. Follow this is very important topic. And again you see why this is important, because at the time of chill water piping, pipe designing, pump selection, fittings and accessories, machine selection, in all that in all this topic you'll find this chiller. Okay, so end of today's session.